fairly thorough suite, which is they also catch the buggy implementations, which is a way of saying, these are misunderstandings I do not have. That's what we're saying. We don't tell them that, but that's really what's going on. Okay? This is all implemented in an IDE for the Pirate programming language. So if you write, for example, median of 132 is 3, it'll flash a thing saying incorrect. This particular example does not match the problem specification. But if you write this, it'll say it's valid. But you caught only one of the buggies in there, right? We call these chaffs, my students call them buggies, so buggies is what they're called from now on. So we caught one of the buggies, right? If I write a second example that looks like this, notice now I'm really demonstrating that I understand it's not average, right? Then, then it comes back and says you've caught 2 of the buggies, and so on. Right? So there's this incremental interactive process, and essentially I pitch it to my students as like a 24-hour TA for problem understanding. Right? You can do this anytime you want, and anytime you're stuck, now you have a very concrete thing to go and get help on. Like, why does this not pass? Or what am I missing? What have I not yet understood? Right? There's lots of user interfaces. You could have pop-ups, you could hover over each of these to get an understanding. There's any number of user interfaces. It's something we think about quite a bit. But the general principle here remains that we have tools by which we can automatically help students with problem understanding, okay? Which is like this big unaddressed problem. And now some of you, again, those of you who are software developers are like, wait, didn't you just say mutation testing in like a really long way? And yes, I did actually, except there's a very important difference, okay? In mutation testing, your goal is to generate as many mutants as possible, but of course you have to worry about, like, you know, what some people call the oracle problem, right? Like, how do I know whether it's a true mutant or not? But also, there the goal is like to test a final test suite. Here, if I were to generate 1 million mutants and give it to my students, I promise they will spend the entire assignment period trying to catch the mutants and never actually getting around to writing the program, right? Human behavior, if you gamify something, that's the game they will play, right? And this user interface is particularly good at gamifying students, and it sort of traps them in this loop, right? We are not evaluating their test suite. We're evaluating their understanding. So we only want a small number of mutants, and every mutant has to correspond to an actual misunderstanding that a student might have, right? So we prefer to call this something like semantic mutation testing, which is it has to match, it has to be about the semantics of the problem, not about all the ways the program can go wrong. Does that make sense? Like, you know, developers making sense? It's like a, it's a distinction it's a qualitative distinction that also is quantitative, because I want to give, like, you know, the top 3 or 4 misconceptions. Right? So median and mode, for example, median and mean being kinds of misconceptions that people might have. Now, you know, question is, of course, where are we going to get this? Well, you know, obviously, right, experts curate these. They look at student experience and student questions that students have asked, et cetera, over the years. There's a little bit of a troubling thing here, okay? There's this phenomenon that's well documented in education literature called the expert blind spot. Experts don't know what they don't know. They have forgotten what they don't know. They don't know what people don't know, et cetera, et cetera. It's like, you could almost call it the curse of expertise, okay? And unfortunately, most of us who are educators suffer from this curse, okay? Now, you might say, well, not my professor. My professor was a dud, but some of your professors were not duds and they suffer from the expert blind spot, okay? So the question is, how do we get around this expert blind spot, right? This is the classic, like, unknown unknowns, right? They don't know what they don't know. They do not know what it's like to be a novice any longer. So how do you make them simulate a novice? It's not very easy to say, you know, in your own words, tell us what a novice would do. They've done their best, okay? It's a very clever idea here my student Siddhartha had, which is, here's the thing. Let's say a person writes an example and it fails. It's incorrect. There's all sorts of reasons it could be incorrect. There could be a typo. There could be a type error. They may have just like flubbed something like, oh yeah, whatever, right? But if you look closely at all of the failing examples, in there are buried the misconceptions. For example, if they say 132 is 3, there's a decent chance that they think the answer really is 3. And if several students produce something that looks like that, right? That means you have multiple people who genuinely believe that the misconception is the middle element, whether it is sorted or not. You see? So the failures in there contain the misconceptions. Okay? So what we've been working on is a new workflow where we gather all the failing examples, and then we're using clustering techniques. Now, here's the interesting part. You can't do naive clustering. Syntactic clustering doesn't work, right? Like your example, I believe, was 194, right? Is that right? 194? Yeah. And this one here is 132. They're exactly the same example, right? They're actually in the same sorted order, but they're syntactically miles apart, right? So what we need is a semantic clustering technique. I'm not going to go into this. That's like half a talk, and I won't go into what we do to do it. But the idea is you have to do some kind of semantic clustering. Then you can look for misconceptions, and you can translate those into buggy code. And then, that's basically a program synthesis problem. It's not one that the synthesis community addresses because they only inadvertently produce wrong solutions. They don't advertently do so. We need them to explicitly construct wrong solutions. And it's a little, it's an interesting challenge question. Okay? And I'm going to show you a little example, a little evaluation of how this technique works. So I'm going to show you some Venn diagrams, a pair of Venn diagrams. In each case, we're going to have a circle for what the staff predicted, which is this left blob, which is yellowish, if you can see the color. On the right is a blob that's bluish, and that's like what the data reflect. Okay? And what we're hoping for, of course, is like the blue is contained in the yellow, right? The experts caught all the misconceptions, right? That's what we're hoping for. Here is one problem where we did this detailed manual analysis. The staff predicted a total of 5 misconceptions. The data showed a total of 11, 3, 2, and 9. Right? So 9 of these were in the data that the staff had not missed. That's like almost a quantification of the expert blind spot here. Right? And this is very actionable because those 2 we definitely want to keep. The 9, we might want to add some from there. Then these 3, maybe we don't need to keep around, right? Maybe they're not as useful, right? And maybe you can drop them and replace them with something where the students actually do have that mistake. Here's another program, a different problem, where there were a total of 17 on the right and 7 on the left, and only 1 was in common, right? So again, expert blind spot quantified. Experts have a whole bunch of ideas of what students are getting wrong, and students are making a completely different set of mistakes. Okay? All right, so this is a sort of technique. It's like crowdsourcing except with students, so it's like, class sourcing, and it turns out to be a very effective way to find misconceptions. You just look at the failing examples, gets around the blind spot, and it's also very lightweight because the students in particular, are not having to do any extra work they weren't doing before. Right? We're not saying, oh, come in for an interview, tell us what you are thinking, etc. They're just doing stuff that's helping them write their programs, and along the way, they're generating data for us to figure out what they might be getting wrong. Okay? All right. So that is the summary of the first technique, right? So students program before understanding the problem well. They don't have tools to help them with that. We would like lightweight ways to undo problem understanding so that the students are actually solving the problem we want them to solve and not some other problem. And there are lots of good reasons like recall issues, cognitive issues, why they might solve the wrong problem. Examples are a good way to operationalize this. We can use the semantic mutation testing technique, and even better, we can also mine their mistakes for insight that then helps like the next generation of students. Okay? That is the first part of the talk. Okay. Now I'm going to go on to the second part. So you remember, again, I put up this graph, and I said we're going to start over there, right? Before any code has been written, let's make sure we understand the problem. Okay? The second part is let's move that blob a little bit over to the right, okay? Which is, can we get students to do some kind of planning? All right? Now, for this part, I'm again going to give you a task. This time, you finally get to write some code. Okay? You can pick any programming language you want. You can do whatever you want. I really don't care. I'm going to put up a programming problem. A handful of you have probably seen this problem before. Rest of you can sort of figure it out. Okay? Here is the problem. I'm going to give you an input like an array, list, whatever data type you prefer. And what I want you to do is I want you to produce the average of that list. Okay? But I only want the non-negative numbers. In fact, I only want the non-negative numbers before an optional -999, like a sentinel value. Okay? This is called the rainfall problem. The idea is this is meant to be like rainfall readings, so you want to figure out the average rainfall. The negative values are like there's a faulty sensor, and minus 999 means that's when we cut off the stream. Okay, and you don't care about data after that. Make sense? Okay, so don't worry about I/O, any language you wish, go. 1 minute, let's write code, come on. I'm actually going to give you 2 minutes. It wouldn't hurt to actually write some code. And if you feel like showing me your code, that would also be cool. But I'm not going to like hover and force you to. Okay, good. I can actually overhear some interesting solution strategies. That's great. I assume Quinn has like an amazing data log solution all working and tested. I was going to make some fun about data log at this point about how those data structures working out, but yeah. Okay, so there's an amazing Prolog solution there in the front row. So tell me what strategies you used. Tell me, talk to me at a high level about what strategy you used. Someone, come on, be brave. Be brave. I mean, I'm not going to run test cases, so you don't have to worry about getting it wrong. Yeah, go for it.
Yeah, so,
Ramsey, yeah.
so filtering out is the strategy, right? So the first pass, filter out all the negative numbers.
Aha, okay. Good.
And then truncation, enclosure would be like a take until,
Okay.
and then a reduce.
Wonderful. Okay, so we're going to filter, and then we're going to do take until, and then we're going to reduce. Okay, great. Other strategies? Do you have a different strategy?
Yeah, slightly different.
Great.
In the first loop, like loop over the entire array.
Yeah.
As you're going through each number, add it to a sum and also iterate on a count.
Great. Okay. And then when you're done, you're going to average. Okay. Same. Okay. And we all, it's Ramsey, so I can afford to like take a little shot at you. We all see the bug in Ramsey's solution, right? Yeah. If you filter first, you've lost your sentinel. You can't do a take until. Okay, but no. Okay. Yeah. Okay. All right. So, but other than that, you're all perfect. Okay. So, in fact, in 2010, there's Mark Gosdale's a very well-known computing education researcher. Now, this problem, this rainfall problem, is kind of notorious. It was first published in about 1984 by a guy named Elliot Soloway, and he was trying to use this to understand how students plan solutions. Okay, the problem was nobody could implement it correctly, so he never got around looking at planning. He's like, I don't know what's going on. Nobody can even implement it, never mind what kind of plan they use to implement it. Now, you gotta, he's at Yale, so what do you expect? But unfortunately, they tried at other universities, didn't work there either, right? In fact, it became notorious as the unsolvable problem of introductory computer science. Now, you're all sitting here saying, that is ludicrous. How can this not be a trivial problem, right? I mean, Ramsey's second test case would have caught the bug and he'd have flipped the lines of code and we'd be all set. Okay, so how could this be hard? Which tells you something about your understanding of CS1. Okay, novices actually find this hard. So it's so bad that 20 years of replication found that nobody can solve this problem, Mark presented it as a challenge. He said, after 30 years, why hasn't somebody beaten this stupid problem? In fact, what if we would like to design a course around solving this problem, right? Like maybe just set that as a goal, right? He's got this little thing at the bottom. Maybe these teach scheme folks might be able to solve it, but who knows? We'll see. So let's talk for a moment about why this problem could possibly be hard for a novice, okay? There's actually a lot of things going on in this problem, lots of moving pieces, right? There are basically about 6 different tasks, right? There's an act of truncating at the sentinel. You have to figure out what to do with the negatives. You got to sum it, you got to count it, compute the average, figure out what to do with the empty list, right? And all of these things are sources of bugs. And if you're a beginner, trying to do all of these together can be pretty overwhelming. So in 2014, Kathy Fizzler published a study where different places were using how to design programs, and what she found was actually students can do fine. Right? And students who had a clear structure of their programs had far fewer errors. They made good use of built-in and higher-order functions, Ramsey, okay? And they showed a much greater diversity of structures than in traditional imperative programming. Now, one of the things that's interesting about this is you can think about whether you want to do this. Roughly speaking, there are sort of 2 to 3 major structures that people use. One is your structure, which is a single loop. Another is a parallel of yours, which is to do 2 loops, same idea, but 2 loops. And the third is basically what we call a cleanse first solution, right? Basically, look at the problem and say, this is essentially an average. How can we turn it into an average problem? Right? And if we truncate and then clean, now we turn it into an average, so let's cleanse the data and reduce it to a solved problem, essentially. Okay? So these are the 3 large-scale strategies, and she saw students using all of these strategies and basically succeeding at this problem, right? Mark actually said this beat rainfall, whatever that means. Okay? So we've been studying these kinds of questions since to try to figure out how students plan programs. And we've got like a whole family of problems that we've been trying to come up with that do this. But all of these studies have a certain weakness, which is what they do is they ask students to write the program and then try to figure out what plan the student used. Right? But now that we can have students solve these problems, we can go back to Elliot Soloway's dream, which is actually focusing on the planning part, right? Like, ideally, planning is something that happens before the solution, not after the solution. The urban planners here might say, haha, good luck with that. But, yes, at least in principle. So what if we go in the forward direction? What if we get students to write plans first? Okay? All right. So now I'm going to give you an exercise. And the exercise, don't worry, there's no programming. So the exercise is, imagine, a place you live or a place you work, office space, home space, whatever. Okay? Draw out a little floor plan for me. You can do it in your head, you can do it on paper, you can do it on your computer. I'm going to give you a minute to draw a floor plan. Go. Okay. At most 1 person, 2 maybe? Yeah, 1 person. I mean like building architect, by the way, not like computer, but building architect, right? Good. Okay, notice the rest of you didn't even try to put up your hand. You're like, haha, I'm a software architect, right? You didn't even claim to do that. And yet you're able to understand this floor plan, right? They expect anybody to be able to understand this floor plan, right? Because there's a common vocabulary we have. Right? We have the shared vocabulary that we picked up. None of you went to architecture school. You didn't take an architecture class. But you're like, that slidey thing, that's like a door, that's a window, that's a wall. We have this common vocabulary. Right? And so planning is something that benefits from having vocabularies. Okay? And the other thing that's interesting about planning is that we don't just use a single notation. Right? So here, for example, is, falling water. And Here is the floor plan for falling water. Here's like an elevation sketch of falling water. And in fact, if you talk to the architect, you'll find like there are several notations that architects use before they go off and build the building, right? Now, I mean, I put up falling water a little ironically, right? Because Frank Lloyd Wright was not the best like civil engineer in the world. But the point being that even Frank Lloyd Wright didn't just go off and start building buildings. Even he engaged in a process of thinking through several steps, not only multiple stages, but also multiple representations, right? We look at the problem from several different perspectives. Or here, for example, is the original Apple mouse, the infamous single button mouse, right? And here is from the patent of the original Apple mouse, right? We've got, again, multiple stages, multiple representations, and each representation talks to a different person in a slightly different way. And so planning and design are these multi-representational, multi-stage activities. Like wonder, where is that in programming? You know? Now, of course, there's somebody in the room who's like, UML, finally! It's like, yes, and in fact, this is actually the point in favor of UML, right? It does give us different representations, does give us multiple stages, does let us talk about a program at some level of vocabulary other than lines of code, okay? I didn't think I'd come here and defend UML, but here we are. Okay, so, what is our vocabulary? So we're proposing that one vocabulary is higher order functions, okay? And there are I found that there are kind of two ways to think about higher order functions. A lot of people's introduction to higher order functions is like abstractions of code, right? Here is a traversal pattern, and you write it over and over, and we're gonna call this the map pattern. Here's a traversal pattern, you're gonna write it over and over, and we're gonna call this the filtering pattern, right? But another way to think about it is more as like units of abstraction in their own right. Right? They are abstractions of behavior, and there's a sort of uniformity that they represent, and this is the point of view that I'm trying to push and trying to like figure out how to train people on. So we'll do this as an exercise, okay? I'm going to put up an input-output pair, and you are going to yell out a higher-order function. Everyone ready? Okay, I'm going to put out an input-output pair and immediately free associate, yell. Ready? Ready? Yeah. Yes, okay, go. Good. Looks mappish, right? Okay, it's a sort of trivial map. Okay. Okay. Good. See, you already know how to play this game. Okay, so as experienced programmers, you have this vocabulary in your head. You have this ability to recognize from one example. You're all like one-shot learners here, right? One example, and you're able to like even point out the ambiguity when there is an ambiguity, okay? So I want to get it so that every beginning student can do just as well as you do, all right? And so essentially, you know, if you think about this, like there's a space of ways in your head. There's probably some kind of complicated decision tree, which probably involves things like what is the output type, you know, and like some case it's list, some case it's Boolean. What kind of an element type? Is it the same or is it different? Is the output length the same or different, etc. And you use all of these criteria to try to help you figure out like what kind of thing you are dealing with. Okay? So what I'm trying to do, our current project, is to basically, we need a notation for talking about these plans and designs, and I'm trying to elevate higher order functions to being that notation. Okay? Now, if you look at that picture, you might recognize that this looks a little bit like Scratch, which is a programming language that's a lot of kids end up programming in these days as their first language. And this is a variant of Scratch called Snap, and we've been working with the Snap team to be able to build our own little custom Snap environments. And so so it takes very little effort to build a custom Snap environment where the only thing you get is like higher order functions. Okay? And we've been having students try to plan out their programs using these higher order functions before they write code. And I'm going to show you for one program, there's actually like, here are 3 different plans. You don't have to read the details. What I want you to appreciate is 2 things. First is, one of the things I like about Snap is you can actually put text inside the boxes, right? That's kind of like not where code ends up being, but it's actually really useful for us because you can bottom out a text wherever you want, right? You can plan the outer structure of your program, right? Which is what Ramsey did, for example, right? He planned out the outer structure, and then there was some like textual details, like, and then at this point, what does it do? It like truncates at something, whatever, right? So you can write text, but also these are three different solutions for the same problem, and you can see like the first one is a filter and just text, right? The second one's gone one level of resolution deeper, a filter with an and map. Third one's a filter of an and map with like different details inside of it. Right? So we're finding this to be a reasonably flexible mechanism by which students can express their plans. We can also give them some high-level checking and say, you know, if you think a filter is the outermost operator, that's just never going to work, right? So trying to figure out how we can give students feedback. Of course, in a dream world, we would then take the inner text and feed it to like, you know, GPT and get code and try to run it. We haven't had any success getting GPT to produce useful code in this setting. But, you know, I think down the road, and you know, if somebody gets provoked by that statement, wants to show me that I'm wrong today, that would also be welcome. Okay, so where are we going forward with this? We're trying to study a few more things here. For example, left entirely to themselves, what representations will student use, right? Like just if you just say free-form plan, what are they going to do on paper, computer, whatever? We've been trying out experiments where we give them textual notations and diagrammatic notations and see which one they prefer. What do you think would happen, text versus diagram? Diagram, right? Yeah. Overwhelmingly text. Overwhelmingly. Like diagram's not working in the slightest, which is weird because I think most of you would probably draw a diagram, right? So is it they're not comfortable with diagramming? Is it like, I don't know, kids these days don't know how to use paper? Like it's not entirely clear, but it's also, you probably have some sort of visual notation you've built up that's probably your own personal visual notation. They probably haven't gotten far enough to build up that visual notation yet. I don't know. We're trying to figure it out, right? Also, will they do things as like organize like a recipe like 1, 2, 3, 4, 5? Will they draw text in like more, you know, indented ways? We're trying to figure that out. And in some sense also like what is the split between programming and planning? Right? Because, you know, I've sort of presented like, well, you know, Frank Lloyd Wright did that, so obviously we must all plan before we build anything. But we know that that isn't quite how programming works, and we're trying to understand like what is that iterative loop? What is that mix of things? Okay? So there's lots of papers. I'm not going to expect you to read any of this. There's lots of papers. If you want to, you can go look at the titles later. And what I want to do is to have lots of time for discussion. So I'm going to end my talk now. As a reminder, we started off with this analysis of a problem. And the analysis of the problem is programming is harder than we think. Okay, especially for novices. And I gave you I made some jokes about 3D printers at the beginning, but I gave you this rainfall problem later on as concrete evidence. There's lots of problems like this of concrete evidence of students having difficulty writing programs that you might think are trivial. Okay, I then showed you one solution to this problem, which is try to make sure they first understand the problem so that they don't spend all their time frustrated. Another thing is to try to talk about planning tasks before they do programming tasks. And those are the two parts of the talk, and you're welcome to reach out to me. And I am now happy to take all of your questions, comments, criticisms, and everything else that you have. Thank you. Bring it on.
So I really love this section about understanding problems before programming. It reminded me of some of your earlier work. I think you called it mystery languages.
Yeah. Oh, yeah.
And for people who don't know, the idea was that there was these languages that weren't described to the students, and then they had to come up with like inputs that would show off the differences between these very subtly different interpreters.
Oh, yeah.
So that has me wondering, or suspecting, I guess, that you've applied the same technique to much more complicated domains than median. And I'm wondering what surprising insights and misconceptions you've found in some of the more advanced applications of testing understanding like this, I guess.
Wow, you give me a lot of credit that I'm not sure is deserved.
So posted like 15 papers about
let me
this.
tell you about the mystery languages because it's kind of a fun thing, right? We're trying to teach people about, so this is something we do in my upper level programming languages class where we're trying to teach like semantics, right? These are people who know how to program, or at least they think they know how to program, and they come in. So we're now talking about like principles of organization of languages and things like that, right? And so the way we structure things is we go through a sequence of features that get incrementally more interesting. So you start literally with numbers and work your way up from numbers to like functions, higher order functions, continuations, all the way, right? But the point is in every one of these features, there's variation between how those features are represented, right? So when you say objects, right, we all know like the word object means about 17 different things depending on which language you're in, right? Even a function call means different things. Fortran and COBOL function calls behave differently than function calls do in like modern programming languages. So in the mystery language idea, what we do is we give them an implementation, you write a program and you run it, and you don't get one answer, you get like 3 answers. So if you're at 1 plus 2, it'll say 3, 3, 3. Okay? He says 7 plus 5, it'll say 12, 12, 12. Your job is to come up with inputs so those 3 answer outcomes are not the same. You're just given a syntax and you have to reverse engineer the semantics, right? So for example, if you say 1 divided by 0, you might be like, in one case you might get like infinity, in another case you might get nan, third case you might get like 0, right? So now you've told them apart. And the idea is to treat this as a sort of a scientific method, right? An experimental process where you construct a theory, you generate an experiment based on that theory, figure out what it does, and then refine your theory and keep revisiting your theory. That's the idea behind mystery languages. So we are actually looking at how to combine these things more. That, in some sense, that is writing examples for problem understanding as well, except the problem there you're trying to understand is what is the semantics of the programming language. And that's a little different from this in the sense that you're trying to find differences that are relatively small, that to most people you might not even observe them, but when you do, they are very surprising and shocking when they happen. There's a very robust theory in cognitive psychology of what is called the theory of contrasting cases that says it comes out of perceptual psychology. And essentially what it says is that oftentimes the best way to understand something is to see a bunch of similar things and just focus on how the little things are different rather than trying to understand an atomic thing in itself, right? So we don't use contrasting cases over here because we're not trying to get at subtle differences, right? I don't want you to understand like minute differences. That's what like mutation testing is good for. I want you to understand like high level difference in median and mean, right? But when you get to these semantic features, so I think the thing is it's the same set of ideas, but the way you express the ideas has to be very different because in one case you're interested in broad stroke differences, in another case you're interested in fine grained differences. The broad stroke differences are to get started. The fine grained differences are if you want to become a semanticist, like your whole life is one of pedantry, right? It's all about fine grained differences. So does that make sense? There's actually, you are exactly right to see that there's a deep parallel between them, but the methods are slightly different because the goals are slightly different. Yeah, does that make sense? Yeah, thank you. Great question. Hello.
Hi, so 2 questions about Pirate, which looks fascinating. First is, are there capture methods built into the language? Or is it just students turn in all of your guesses and iterations? So that's question 1. And question 2 is, so what's the life cycle like after students learn on Pirate? Do you switch them to Python next? Like, what happens to them?
Yeah, that's a good question. So to answer your first question, actually, so we do the logging of examples in the system, but the Pirate language itself is very explicitly privacy respecting. It has been deeply tempting to log every damn thing we can. In fact, we log nothing. Okay? I don't want to know about your programs. I want you to be, like, I don't want a student to feel like, oh my God, somebody's watching over me and that's going to affect my performance. This has been very useful for us because I also co-run one of the largest middle school outreach programs in the US. And thankfully, school districts, unlike a lot of other people, care about privacy. They have minors, right? So we get school districts who contact us and say like, so, we are interested in your curriculum, but like, what's with student privacy? And everybody else is like, we log the shit out of you, right? Because analytics. And we're like, we log nothing, go for it. And they're like, thank you. We've gotten like badges of excellence from various school districts, like this is what we wanted to hear. And that is, as a researcher, it's like, okay? But I have to decide whether I care about students or my research more, and I care about students more. We're looking a little bit about like how we can try to reconcile that a little bit. Like, you know, like maybe we can log some like statistically log events, things like that. There's a bit of a movement of this sort of thing. Like what should, you know, a good question is like, what should FOSS systems do, right? What should free and open source do? Logging is useful for finding problems, right? The trick is when the logging coincides with identity, right? But if you don't log with identity, you can't track longitudinally what a student is doing. It's super hard. It is much harder than my small brain is capable of dealing with. So, and like all of the Pirate team, Ben Lerner, Joe Politz, and I all came out of doing like web security research. So we knew all the ways things can go wrong. So we're like, first, do no harm, right? Yeah. So your question about the Python question is interesting. So we have a book called Data-Centric Introduction to Computing. And the whole point of the data-centric introduction is we start with a whole bunch of stuff this is all like in Pirate. But then when we get to programming in state, we actually do something interesting that most books don't do. We use the two languages in parallel. Okay? And the reason is we want students to learn how to transfer ideas from one language to the other, and transfer is one of the most robustly difficult problems in all of education, not just computing education. So for example, when you look at state, you look at every one of these programs in both Python and Pirate, okay? And you see how to write these things both in Python and in Pirate. You get to see, like, each language in its own right. You understand a little bit about strengths and weaknesses. Pirate's syntax is very explicitly designed to make a distinction between variable mutation and structure mutation, which is something most languages screw up, and that causes all kinds of confusion for students. So, like over here, right, there's this weird syntax here that says, here you just put an equals, here you just put an equal sign to do the mutation, but here you have this funny like bang colon thing going on to make clear that you're changing this field of that object, right? So it's very carefully thought out. We're doing a bunch of research on these transfer issues, and the book is basically a research-driven project. Okay? Does that answer your question? Thank you. Next question. Hello.
Hi. I'm curious, you showed us planning in the small for, tiny functions.
Yeah.
And of course, as students progress, they write larger and larger programs.
Yeah.
And for, us in the audience, some of us are writing huge programs and planning entire architectures or whatever. I'm curious, what parts of these ideas stay the same as you get to larger programs? What parts change?
That's a great question. I'm going to give you a terrible answer, which is I don't even want to think about that. Okay, and there's a reason, right? Like I like it's same thing with like Pirate, right? It's very easy to build a programming language and then say like, oh, shiny thing, oh, another shiny thing, and add every shiny thing. We have a very clear focus on what Pirate is for, and almost definitely it's not for other things. Right? If people can figure out how to use it for something else, that's great. If they want to send a pull request, we might consider it, like it's happening right now. But by and large, we just don't want to know about it. Right? We want to do like drill the thing we do really, really well. So the same way, like I have obviously as somebody who's built large systems, deployed large systems, I have opinions on these things. But there's a lot of other researchers out there. Like you open like any software engineering conference, like half the papers are about this sort of thing. I don't feel the need to add to that. Right? I want to take this problem and nail it, and let everybody else who's nailing those other problems nail it. How's that for a terrible but like very honest answer?
All right, two more questions.
Back there. Oh, yeah, sorry,
Yeah.
please, yeah.
No worries. So it's interesting you were talking about the interchange between planning and writing your program and how you go from, and I was reflecting on the way that I came to my solution, and the first solution that I came to in my mind was definitely the two loops that you mentioned. And after I wrote it down, having it on paper, I was able to look at my solution, and maybe within the last 5 seconds, I was like, "Oh, I just moved this
just
into the
combine
first
these two.
loop."
Yeah,
and you can just
yeah.
loop once.
Yeah.
But I think part of what was going on there is once I was able to see it on paper.
Yeah.
The structure was emergent to me,
Yes,
right?
exactly.
The plan, like kind of the way our eyes fuzz over, and you're saying like, as an expert, you can see the plan in the program.
That's right.
And it was able to easily move one element in.
Right.
But yeah, so I'm wondering like that planning programming loop back and forth.
Yeah.
Any thoughts on how students might do that?
Yeah, this is our next big research question. I don't even want to speculate because I don't know, and I would just be guessing just like you would. Your guesses are probably better than mine. So, but this is the thing we are trying to figure out. Like we think everything's going to be planned before every programming happens. Similar thing with testing, right? Like what's happening is we split testing into two parts. Write examples to understand the problem, which are still test cases, and then write the rest of your test suite. You still have to do that, right? But here I think it's going to be even more iterative, just like real testing is also more iterative, right? So yes, and I don't have any scientific answers to your question.
I guess I was curious about the tactile representations of plans that you had mentioned earlier, and how students kind of come up with their own. do you think there's value in either optimizing like the existing like block-based solution that you worked on for tactile representations, or maybe just like drawn representations?
Yeah.
And kind of as a follow-up there, I'm just curious on like if students have come up with their own like notations that you're like familiar with that you've seen like patterns in, other than like the text and recipes that you had mentioned.
The latter, so the former question, I don't, Zishan, there's a hand up there, by the way, right back there. So there's the former, I think it's premature for us to optimize. Now, you're pointing out, of course, something very significant, right? If you have a non-optimal representation, people might not use it, and if you'd optimize that representation, maybe they'd use it all the time. And it's a sort of a resource issue for us to figure out where to optimize. But I think I still want to do more qualitative, formative research to figure out whether that block-based solution is even appealing to them before spending time on it. Right. So I don't know. As for the second, no, it's nothing yet. Nothing's emerged. And we're seeing like, we've got like hundreds of these, and all we know is like nothing other than like this sort of checklist, sort of the recipe list kind of thing. But that's probably driven by an example we showed them. So it's very hard to tell. And what we need is an iterative loop where we generate like, here are 5 different ways you might imagine writing a plan, and then see what they come up with, and then like keep parsing that space apart. Yeah. Thanks.
I'm thinking about your first and last slide about the graph of like frustration over time, which I thought was really cool.
Yeah.
To a certain degree, though, like some amount of frustration is still inevitable.
Yep.
And
good productive struggle is a well understood theory in education.
Ooh,
yep.
Yeah. Sure. Okay. So to me personally, and anecdotally, like from my friends, it seems like one of the aspects of programming is the development of like an emotional skill around not reacting to problems with excess frustration, or not letting it like restrict, or like cloud your judgment and like.
Yep.
So, yeah, like how much of that development of that emotional skill is within the scope of like a computer science education, and like what are ways that you can help students on that path?
It's a great question. It's absolutely critical, and I think we have a tendency to focus too much on like both technical and cognitive aspects, and forget the whole sort of emotional aspects and social aspects. Okay, so you're completely right. Now the thing is, there's also some reasonably good research that shows that like students, so I'm going to draw a graph for you. Okay, this is self-efficacy across time. Okay, and students, and this particular study was looking at male versus identify as male versus identify as female students. Okay, lots of issues with that, but just take at some large scale. So here's the graph. Okay, everybody starts off down here. Basically, everyone ends up kind of up here, but the males go like this and the females go like this. And the females get to this point and they drop off. So what's left is the females who actually were willing to brave through it. Okay? So the thing is, you notice that I didn't draw a flat line as my goal. My goal is still like bumps, right? What we have to do is to make those bumps not so overwhelming that the student stops. And then what we have is this huge survivor bias where like, yeah, I powered through it and it was okay, but we don't hear from the others, right? So I think what I'm hoping to end up with is like a collection of technical, cognitive, and social and emotional aspects so that we can achieve that kind of goal. So we have like productive struggle and not unproductive struggle. You're absolutely right. Last question. Okay.
That was great.
Good. She's shutting me off. Thank you. Bye.
Thank you, Sharon. Thank you so much. I think everybody is now fully awake and ready. Brooklyn says she's giving a quiz for her talk as well. So, be ready. Thank you, Sharon. So up next, we have Brooklyn Zelenka. She is my boss. So I can't say no. Brooklyn's really awesome. She's talking about work that we've been doing a lot of work on together. She's CTO of Fission.
Please.
Brooklyn is an amazing person who's always about challenges. If there's not a challenge, we won't tackle it. And that's really awesome. And she's really great. My daughter goes on every call that we have, and she calls her Elsa because she doesn't want to use her real name. Well, I guess the computer's coming up. We're getting there. Yeah. There we go. I think we got it. All right. So yeah, without further ado, Brooklyn Zelenka on seamless services for an open world.
All right. Oh yeah, that definitely works. Hi everyone, thanks for coming to Causal Islands. And as Ishan just mentioned, I'm going to be talking about seamless services for an open world, talking about light cones, user agency, and connecting absolutely everything. The past couple decades, really, the incentives in tech have been to gather as many users as you can, build a wall around them, and defend it with a moat. And there is connections between these different little fiefdoms, but they're only really done point to point and in a very closed world model. For us to make any further progress, we might need to think about doing things differently. In fact, this is not a new idea. This is a fairly old idea, right? Even the late, great Joe Armstrong saying, wouldn't it be great if we could connect every process to every other process in the world? To talk about this utopian vision, I'm Brooklyn Zelenka. You can find me anywhere on the internet as Xpeed. And I'm the co-founder and CTO at Fission, where we're working on tools and technologies and research to do exactly these things. My background is mostly in programming language theory, virtual machines, and distributed systems. And increasingly, I work on standards and less code. Zishan has written the bulk of the code that I'm going to be presenting near the end. But if you're into standards, we're actually going to touch on a fair number of these as well today. So if nothing changes, the rolling weight of the status quo looks something like this. If you want infrastructure, you need to go to one of them, or maybe this long tail as well. But really, it's Amazon, Microsoft, and Google, sometimes called the hyperclouds, that control most infrastructure in the world. And they do a pretty great job of doing things at scale, but just Amazon alone has as much of the market as that entire gray section, right? If we don't want this trend to continue forever, and on one hand, there's nothing wrong with that. They're really great at scale. But I'm not sure that I want Amazon to own absolutely everything on the internet and all of the infrastructure and decide what goes on and off the internet. So if we don't want this to be the case, we need to take the current light cone of the future of all possibilities and redirect it, at least a little bit, just tip it off its axis so that that no longer becomes the default position. What we're talking about today is nothing less than connecting all of the world's users and services using open interoperable standards. We've already done this before. We have TCP and IP and HTTP. Nobody controls HTTP, right? There's a standard, anybody can implement it. It runs on every machine worldwide. We can do this again. But we need to do it now for storage and for compute. And anything that we come up with has to be substantially better than the status quo, right? It can't just be because it's decentralized or because it has user agency. People say that they care about these things, but then they also, Facebook has 2 billion users. It has to be better both at the level of the future that we want to see, but also to make it convenient enough for people to actually adopt. When we started looking at these problems, not quite 4 years ago, we knew that we always wanted to get to compute. And to do compute, you have to have data. And in order to do data in production, you need to have an auth system. You can't just throw data out into the world, especially when it's available absolutely everywhere. People often like to put auth above data, but it's actually more fundamental. It's not like someone put us on this path intentionally, right? This was all done with similar ideals to what we have today and what I'm presenting today. It was all these small, reasonable steps that got us into this painted back corner. A lot of the web was designed in the 90s. Back in those days, you had a beige box under your desk. It was relatively slow, and you had to dial into it and tie up your phone line. So of course, you would rent a box somewhere else, and you'd put they would run a process in front of it with, more professional hardware, and you'd connect to it over the internet as you needed it. So maybe they're running a mail server for you. But you're not always connecting to it, so they can scale up and do multi-tenancy and have lots of people on the same machine, which means that they need to put access control so that we can't read each other's email inboxes, or we can't look at each other's photos, unless it's intentional. But of course now the demand side has scaled up per provider, so the server also has to scale up too. So we do replication, we put load balancing in front of it, and we have this many-to-many system hidden behind this abstraction. And over time, that gets really difficult to work with, and we want to scale things automatically up and down, so we invent the cloud. 15 years ago, I worked as a Apple genius and was interacting with the public every day. And people would come in really terrified about the cloud. They didn't know where their stuff was anymore, right? This was a new scary abstraction that we now take for granted. And now we have these even scarier, newer abstractions like serverless, which is ironically more servers. But at least it's finally breaking out of this same pattern of I, at least conceptually, have a computer running somewhere. At least now it's coming down to functions. And so this picture played out for many, many years. And fundamentally, we've been trying to keep the same picture going for a long time. We have this single source of truth, right? We have like the database, or where's the server? This has created front-end development, back-end development, DevOps as specialties that are deep, right? You want to learn Docker and Kubernetes and all of these parts. It is a multi-year endeavor. You can't just pick it up and go and start running. And we invented the LAMP stack in the late 90s to work in this beige box world, and we've been extending it since, right? We want to make the thing running in the cloud work like the thing that's running locally. And we've extended this metaphor for literally 20 years, 20 plus years actually at this point. We're taking this random walk through the solution space. And it's not like you get a zoomed out view like this. You're sort of in a dark room trying to find which way up. We're performing gradient descent on the future. We've hit a local maxima. I refuse to believe that what we currently have is the highest possible point in the design space. Just AI, zero-knowledge proofs, and fully homomorphic encryption have blown my mind in the past 5 years. Things I literally didn't think were possible. So there's no way that at the networking layer, we've hit the maximum possible solution. It's also possible to go deep, deep into a dystopia. We want to avoid that too. But even if we find the next hill, we don't know if that's the maximum one. So we need to go and explore a huge number of approaches, and we need to have technologies that let us explore all these approaches, that don't push us into a single funnel. So we want to find our way up here over time. Sometimes this means taking things like the LAMP stack or other tools and saying, well, what if we threw out the basic assumptions of it, took all those pieces and recombined them again, and see where else, with the new things that we've learned, we can create a new structure that's maybe more fits the ecological niche that we're in. Or another way of putting it, what if we burnt it down and rebuilt it? So we're in this new environment now. We no longer dial directly computer to computer. The network supports that, but we don't do it. If I want to send a photo from Winnipeg to Saskatoon, I first cross a border and I go to US West and make this loop, which at the level of sending a photo, nobody's going to notice, right? However, it is a tremendous amount of added time, energy, carbon, and just maintenance of all the plumbing, right? All the routers, all the fiber in between. As data starts to develop faster, and we start to have IoT and AI generating more and more data, right? Self-driving cars on Teslas, they have LiDAR arrays that are pulling in geospatial data, and it's so much, so large data that they can't actually push it over the pipes over your home Wi-Fi. It doesn't make sense. They do some pre-training on it locally on device, like literally in your car, and send more of like a snapshot of the data back to the main servers to do larger self-driving learning on. If we're producing data at this rate, we end up in the situation called data gravity, where the more data you have, the more you start pushing data or pushing jobs to that one place that produces more data, and you end up getting sucked into this black hole where the data can never move from there. And there's no actual solution to this problem, right? But we need to be able to work around it. When we look at cloud infrastructure, so these are, I'm going to pick a little bit on Amazon, mainly because they're the incumbent. Here's Amazon's servers worldwide, and the number of servers per region. And because Amazon's responding to the market forces of capitalism, they obviously make this really efficient, and they put it near large population centers, which means that they can invest in places where people actually are, because nobody lives here or here, except that they do. And the main difference is that these people aren't profitable. They're online, they're coming online at a very high rate, but it doesn't make sense for them to serve them, right? The data center in Cape Town is significantly more expensive to store data in than US East 2, which makes no sense, right? Except it makes complete economic sense because it costs them more to run a data center there, because the individual people there are less valuable to them. Just this circle has 50 million people in it. In North America, we have about that many people per data center. In South America, it's about 1 data center for every 500 million people. And in Africa, it's 1 for 1.5 billion. And there are parts of the world that don't even have a direct land connection. You have to put a wire underwater or go up to a satellite to do connection. This works okay, right? For sending a text message, it's not that critical. Even if everybody's sending stuff into US East 2, okay, fine, it's going to take an extra couple 100 milliseconds. It's fine. But increasingly, we have need for self-driving cars, IoT, geospatial data, and AI, et cetera, that need actually lower latency computing, right? Ericsson has set the line at 8 milliseconds for doing things like factory automation. 8 milliseconds with the speed of light is actually not that far, right? So here's 8 milliseconds in a vacuum. So this is the absolute physical ideal. Gets you not quite to Havana. Gets you close. Gets you off the coast of Florida. If you want to do that as a round trip, that gets you to about Halifax. And if we put that in ideal fiber, perfectly straight, no curvature, nothing, gets you about to Montreal. This means that as we produce this much data at these rates, increasingly, we get trapped in these causal islands. And yes, this is the slide where Boris named the conference for. Because data travels at maximum at the speed of light, we can't keep up with each other all the time. This is a light cone. We live at the present, which is the middle point there. And as a signal emits from that point, it extends out, sort of ripples out from that place. And we can finally get into points where there's some overlap, right? And often people at this stage say, oh, well, that's really great. I'll just put my data center between all the other data centers and have like a relay or some consistency check there. And this has been done. Google has a system that works basically like this. It's like it's okay for most things, most of the time, for point-to-point between data centers. The problem is, as soon as you start adding in other points, it gets really tricky really fast. Because essentially, you have multiple light cones sitting next to each other. And if we only work in this tiny little triangle, then we end up in this case called causal subjectivity, which Quinn will talk about a fair bit tomorrow with the Rhizome database work she's been doing. This idea that a server has to live in a specific place doesn't respect physics. This isn't an ideological point. This is base physics. We can't keep up with the amount of data that we're producing. We need to move our data and our compute closer to where users are. And for things that are trapped in data gravity, So the data itself, we need to be able to move the compute to the data, not always downloading the data and computing on it in a data center. Beyond that, unlike the 90s, we have a very varied network, right? We have extremely powerful devices in our pockets that can do most computation that they couldn't do 20 years ago. We have cloud and now edge servers, things that are much closer to users, and things that are starting to be run by the commons, by everyone, by you and me, right? IPFS, BitTorrent. This means that I can start something from the browser, have it kick off a WebAssembly process that calls into an edge worker that goes over into IPFS and grabs some data and operates on it. Right? It needs to move seamlessly between all of these different systems without having to go through the same auth server over and over again. In short, places are not a great way to organize computation. They're a way. They've worked pretty well for a while, but we've now grown beyond them. So how do we get back to our roots? How do we make the network good again? The good news is that this has all happened before, and I'm sure that it'll happen again. If you go back and look at the history of telecommunications, radio, telephone, we've ended up in a similar situation. And we've found solutions. And I'm sure that even with the things I'm talking about, we will find the difficult parts, the local maxima, that we need to then go and explore other places too. When the web was founded, it had these principles. So this is in the early 90s. Decentralization. I don't mean in the blockchain sense. I mean literally that the network is decentralized. The internet was designed to be resistant to nuclear attack, right? So you needed to have things spread all over the place, which also means you need lots of providers running things. Non-discrimination. You can run any service you want on top of this network. Bottom-up design, universality, and consensus. Consensus, again, meaning that we're just going to agree on the standards that we run. We almost ended up in a situation where there was a Microsoft internet and an Apple internet and an AOL internet. And that didn't happen, thankfully, because we adhere to these principles. And in fact, we've done a really good job with these through the bottom layers of the stack, so at the physical and the data layers of the stack, not so much at the application layer. So a lot of this work that we're talking about is taking this and extending it all the way, finishing that vision from the beginning of the web. There's this idea from Simon Wardley that inventions start relatively visible and novel and slightly broken, and over time become a utility and become more mature and become invisible again. And that the structural system says that most of the money for this is going to be down at the far end of utility, when we're doing things at high industrial scale, which entrenches that position of, well, we're going to keep things the way that they are as long as they are. We're going to run the lamp stack forever. But when you get down into utility and it becomes invisible, it opens up new opportunities for new innovation. And so you have people trying things and experimenting and starting this next cycle repeatedly. Distributed systems and concurrency have followed this path. We started really concerned about physical infrastructure. How do I actually run a disk? How do I move the needle on a spinning platter or a tape-to-tape reel to do concurrent processing and loading data concurrently? We moved into immaterial objects, basically abstractions over that, distributed state machines, and we're roughly here in this picture. Right? We have some distribution, and we're starting to explore adversarial things, asynchrony, failure, et cetera. And a lot of this work, for especially the back half of this presentation, kind of moves that over and says, well, what if we worried about, yes, these trustless systems, but also in a scalable way? We need to do this in a way that respects user agency by default and out of the box. There's 4 principles, right? You need to be able to enter a system. You should have the option to leave without being held hostage with your data or your service locked into a particular way of doing things. You should have control over your own data. You should be safe no matter where you move on the internet. And you should be able to provide capacity to others. You should be able to plug in a desktop machine and have it serve compute jobs or serve data to others. So finally, in the past few years, we're seeing signs of a way out. And this is both technological and social. They're both algorithms and systems being set up, but also a social consciousness. If you look at Mastodon or Blue Sky, right? People are becoming aware of these things. There's a movement towards self-certifying data. Web3 is a bit of a controversial term, right? A lot of people think that is just about blockchains, but there's another group that has sort of big tent Web3. And honestly, I don't really care what the term we use for this. If we want to call it the self-certifying web, great. It's just a bit of a mouthful, where we have cryptographic user keys to say, I did this thing, I'm going to write back. And content addressing, so the ability in, say, Git to say, yep, this is the hash of the thing. I agree that this is what was actually committed into the repo. And there's actually one layer around this, which is not just authentic data, but also authorized data. Proof that you were allowed to do that right in the first place. The way historically we've done access control in that auth data compute stack that I talked about right off the beginning is with access control lists. So here we have a user, and they want to access some service. And when they make that request, they get stopped essentially works like a bouncer in front of some hip, cool club who says, are you on the list? And you present your ID, and they go and they look at the list, and they say, yep, that's you, great, you're allowed through, and you can actually talk to the service. On one hand, this is great, because you can put this thing anywhere in front of any service, and it'll work. The downside is that the user and the service aren't actually in control anymore. It's this auth service that's in control. And if anybody can take control of that, they can take control of the service, because now this is a trusted link. Additionally, this list is now the source of truth for who's allowed to actually do things in the system. So even if we wanted to interoperate with others, we wanted to have another service use this list, we either need to synchronize those or always make requests into this auth server continuously, which is in fact the situation where we found ourselves. The other solution for this, which is not a new idea, but that is starting to gain some steam, it's called capabilities. Here you have your user and some service, and the user knows how to find the service. And they send them, it's essentially like a ticket. So the metaphor, instead of being a bouncer, it's like when you go to the movies, you get a ticket, and they don't care what your ID is. They don't check who you are. They just say, do you have the ticket? Great, you're allowed in. And even better, if I can't go to the movies that day, I can give my ticket to Zishan, and Zishan can go instead. This puts me and the service in control. All of the required info is stateless, so it doesn't belong in a particular place. It can move around with requests directly. And this is where the movie theater metaphor breaks down a little bit. I can make copies of these tickets and tell others how to access this service without having to talk to a third party, without even having to talk to that service directly first and say, yeah, I gave them the ability to also call in. They're going to do this on my behalf. So I can send somebody else this little ticket, and they can also now make requests. ACLs and things like OAuth. This is a OAuth negotiation flow. It is, I think, 12 steps. This first half is negotiating with the authorization server, so the yellow box, the user, application, and auth server saying, OK, user, do you really want to give this application access? Yes, and it goes back and forth a bunch of times. And anything could fail in the middle here. And then once that's done, the resource server, the place where you're actually trying to run some compute or get some data, has to still go back through this authorization server and say, the thing that I got from them, is this valid? Am I allowed to actually do this thing? We've got to go back and forth a bunch of times here again. It would be really great to not have this single point of failure in the middle, this place where we always have to connect out to and go and pay the latency for. And so with capabilities, things like UCAN, there's a bunch of these system now, it simplifies the picture greatly. Right? here's that first half. It's literally the application asks the user, can I do the thing? Yes, great. And then later, it can use that token that it got from the user to go to the resource server and say, hey, look, I'm allowed to do the thing the user says so. It's a much simpler picture, even in our heads. So that's auth. That's the bottom layer. What about data? Historically, we've used physical addressing, location addressing, and this is never going away, right? This is base bottom truth, right? But we want to get away from it as much as possible. In fact, we've already done, nobody types in, when you go to your browser, 42.123.45.6 to get to some server, right? We've added domain names. You go to example.com and you load whatever's over there. And it's just a mapping of a friendly human readable name to an IP address. It's a mapping of a name to a server. But it's still fundamentally about the location where something is. If I load that page tomorrow, it could be different. And to scale that up on, say, a CDN is really difficult, right? We need to do all kinds of tricks to fake that we're actually at example.com. There's this newer idea called content addressing, where we say, here's some content, and here's its hash. I'm going to run it through a function and get a small digest that's unique to that content. And I don't care who has it. Just find it for me. And so if I hash some data, or you hash some data, or a third-party provider hashes that data, we get the same value. It doesn't matter anymore where it lives. This also helps for linking data together. So I can have some JSON that has a hash of its own, and it can link to other chunks of JSON, producing a nice, rich graph. And once I resolve that first link, which we can even put behind a domain name as well, I can follow paths inside of here, just as easily as we would with normal pathing. So these are the starts of some open services, at least for auth and at least for data, right? These are ways that we can actually connect systems together. These exist today. They're a little bit early. They're getting adoption. They're moving forward a little bit at a time, right? People have been using things like magnet links and BitTorrent to download their Linux ISOs for a while, right? But we need the same thing for compute. So compute, like data, should be ubiquitous. It should be everywhere. We shouldn't have to think about it. We should be able to depend on the idea of having compute around at all times and only go out to the network when we actually need something. Not as the default, because that's where the compute lives, but because I can't do something locally. My phone is way more powerful than my first laptop, right? I can do 99% of things on device. And when I do need to go out, it's because I need to use a GPU or some other resource that I don't have locally. This needs to be fully consistent between clients because I need to be able to move compute from here to there and have it be equal. And ideally, I would like it to be deterministic so that both runs are the same. So they're completely indistinguishable. In the same way that we had content addressing for data, I want input addressing for compute. And we need to replace the hard dependency that we have today on the hyperclouds with open protocols and nodes. That's not to say that they're going to go away. They've done great things at scale, but they should be able to participate, and we should level the playing field for everyone. Developers don't want to think about compute. We hear this over and over again. They say, well, I just want to write some code and just have it taken care of. And this is what serverless was sold as, but hasn't really panned out because you have to go to these specific proprietary APIs that are different based on the provider, and people are trying to abstract over them. And maybe if you write it like this, then you can run it on both Azure and Lambda, but you need to tweak it like this because sometimes it'll be on Azure. Like all of these things gets really difficult. With open standards, we can make this picture really easy. We have users and devices. We have service providers. And they can just dip down into the ubiquitous compute substrate and pull out values, regardless of where they are or on what device they're running. It also means that if you have a request that has multiple components in it, you can route that anywhere around in the network and say, OK, I want these 5 things run. Cool, I'm going to send that out to some compute broker, and they're going to pass that along to who can actually run these tasks. and let that sift through the network until it can find the relevant service providers. What this enables, in addition, when we're talking about the potential solution space, is truly disorderly programming, where it doesn't matter where you're going, right? We should make it so simple to think about compute that we can experiment with different ways of computing and different kinds of services without having to say in advance, like, well, I want to register this kind of job. No, just say, hey, I would like to run this kind of job. Who can provide that for me? Oh, you have a GPU? Great, I'll send that over to you. This compute substrate has more than 4 parts, but the 4 that we're really going to think about here are scheduling, execution, verification, and reuse. I think it's uncontroversial to say that WebAssembly is eating the world. So WebAssembly, for those not in the know, is ironically neither web nor assembly. It is a common execution engine that exists in all browsers and also runs on desktop and mobile, where you can write code in any of 40+ languages, and it'll compile into this same virtual machine and be able to run anywhere. WebAssembly itself isn't deterministic. It has one little corner where it isn't, but you can enable a flag and make that go away. There's a small performance penalty, but you can make that case go away and get completely deterministic computation. So if I run something or you run something, we'll get the same result every time, which is the final part of this stack that we talked about right off the top. If we have auth data and compute everywhere, with things like UCAN and IPFS and the web native file system, we can compose them together with a bit of glue, or maybe a lot of glue, and get something like the interplanetary virtual machine, which is what we've been working on at Fission. The basis of this is an idea that goes at least back to the 50s, if not earlier, called code as data. So if I have arguments and some WebAssembly, literally the binary, and I content address them, and the WebAssembly itself is just built on just regular standards. There's nothing special here, right? It uses, in our case, the WebAssembly component model, which is out of the Bytecode Alliance. We can combine them as a task, and then also attach a little bit of scheduling information to say, like, well, I want this to run, up to, this much timeout, et cetera. We get something that looks a little bit like a closure, right? It looks a little bit like this kind of code, right? Here's a function that will, when it's invoked, cause an alert box to pop up. But it doesn't do it right now, right? It's just a description format that we can move around as data. I can pass this reference around, right? Because I can content address all of this. It's just data. I can pass this around and nothing happens until I say, hey, actually go and execute this thing, and then I get the pop-up. And when it actually runs, we get a new structure that points at the task, and we call this a receipt. And it contains a little bit of metadata and trace, as well as the pure values that have come out. So if I'm doing addition, 1 + 1, it'll give me back 2, and any effects, anything else that I want to on-queue into the system afterwards. One of the major advantages of this, of having it be ubiquitous and able to run anywhere, is that we get very, very high availability. There's a term, embarrassingly parallel. This becomes embarrassingly available. Systems try to run with replication so that they get high availability, so that you can't take the system down. Joe Armstrong, one of the creators of Erlang, said there's no such thing as 100% uptime. Right? You can have cosmic rays or an earthquake, or the network goes down, somebody cuts the underwater cable, and it's no longer available for some period of time. Right? Amazon goes down, and they're brilliant engineers. Right? But if we can replicate this, because anybody can run the computation, we get very, very high availability. And you can make a request to any of these providers. You have options. You have choice. And it scales up. More people using it, more people that can also plug in and run jobs as well. This is run by the community, for people. And if we take any section of this and add up the availability inside there. So these are not super high availability numbers, right? We have 99.0% availability on one of these. But if you combine them and do the, the simple math to find out how available this is now, just these three are now 11 nines of uptime, which is pretty good for most SLAs. So in aggregate, if enough people run such a system, we have essentially approaching infinity nines. We have incredible availability across the system. There's a downside. You need to actually find somebody to run the compute for you. So most of the time, that's yourself for most jobs. But if you need to have access to, say, a GPU, and you're on your phone and it doesn't have enough power for something, you come online and you say, hey, I want to run this job, represented by this gear. And you have a service provider that says, hey, I can do all of these things. You need to get routed through some common layer. In the current implementation, we do this over a pub sub system called Gossip Sub. But you can also imagine putting this on a DHT so that you can advertise, hey, these are the things that I can do. Route to me, please. There's also a concept that we're not going to delve too deeply into in this discussion called affinities. So to say, hey, I have a GPU and capacity to run right now. I'm a reputable source. I'm really close to this petabyte of data that you want to operate on. You should send the job to me instead of to somebody else. Instead of just sending individual jobs at a time, which is totally fine, but means that you're always waiting for a response back continuously, we do this thing called a distributed invocation with promises, sometimes called promise pipelining, that looks a little bit like data flow, right? Where we can take the output of one thing, and before it finishes, say, hey, when that's done, run this next thing as well. And we can send them together, or we can send them over time. It doesn't really matter. And they can chain together into these graphs of computation that don't even necessarily have to come from the same user. They can come from multiple requests, multiple people reusing the same results. So we can take this graph and push it to a single machine, but we're not giving, there's nothing here about the location of where things run. We've taken that decision away from the programmer and said, at a high level, what kind of thing do you want run? And we let them lay it out like this. And then the system looks at it and goes, oh, OK, I need to sign, like, yep, I ran this thing. I certify that I actually produced it. So we do this pipe, where at the level of WebAssembly, the components stack together and run efficiently through. And in an async process, we pipe out, hey, generate a receipt for me. And that goes into a nice readable JSON document off to the side. And the advantage of this is now I never have to run that step again. It's deterministic. If I run it now or in a week, it's the same value. So if I have that same argument again in one of these chains, I can skip it and take the value out of that receipt and say, yep, pretend I ran this, put that value in here, and continue. And we can collect up these receipts. This is memoization at global scale. Ryan, our head of design at Fission, has called this run once and never again. A unexpected thing that comes out of this, out of input addressing, where instead of it being a hash of the content, it's a hash of the inputs to the cached output on the network, is we get a reverse lookup table. If you run AI tagging or moderation over some data, which is a pretty heavy process, it's a pipeline of images that are being, of an image rather, sorry, that's being transformed. We're going to simulate a crash halfway through and resume, and then also do a variant reusing parts of the computation. So here's our nice cat on a space keyboard pic. We're going to show a little bit of the code. So it's just regular JSON with some content addresses for the WebAssembly and passing arguments to it. So these are the two functions that we're going to run. We're going to do a crop, rotate, and blur to start. And this is sending it off. It's not running inside the browser. It's actually going out to a remote process. And it takes a little bit of time to run. And workflow 2 does the same, but it's going to grayscale at the end. We don't have to do all that work again. We can just pull them out of the cache and get a grayscale at the bottom. And so we can do this across providers. Today, it's just point-to-point. It's actually relatively early work. It's about 4 months, I guess, in, but actually making pretty good progress so far. The upshot of this is that we can think about parallelization and efficiency from a new angle. So obviously, as you add more machines, you want to get linear scaling. You want to have it be, 2 machines will be twice as fast, 10 machines will be 10 times as fast. And in practice, that's not what happens, right? You need a little bit of coordination, called Amdahl's law, where the jobs need to synchronize and they need to check in with each other. Hey, I'm waiting for this thing. It's not done yet. I'm going to sit idle. All of this stuff. So it actually kind of tapers off a little bit. And in practice, there's a tipping point where it becomes less efficient because the overhead is so high. So I'm not sure if any of you have been in a team where the team then scales up really, really high, and you have all of this overhead suddenly. You have to have all of these meetings, and it feels like you're getting nothing done. Same thing happens to computers, right? You have incoherence, data contention, you're waiting for things, you have to coordinate, check that you have locks, etc. But because we have this memoization, we can actually do better than linear on popular content. So this isn't on everything. This isn't on the first run. You pay a penalty the first time it runs, but after that point, you can pull it out of the network. And this isn't a completely new idea, right? This is how BitTorrent works. You can say, hey, how many providers do you have? The more providers, the faster it'll download. Great. Usually this is the point where people say, okay, that's great, but I have to trust everybody. And that's a trade-off you can make. You can say, I'm going to go to this specific centralized cloud in this.
Hey now.
It's at the point where you can play around with it. The demo that I showed is real. You can actually click through that. There aren't people actually running this on the network yet. Our hope is that by sort of end of year, we'll have something that people can just say, hey, I want this thing run, and it'll just go off and hit the network, and you'll get results back.
Super cool talk. Really excited about the whole ecosystem. Just zeroing in on one little offhand comment that I was really interested in. What's the state of TLS Notary and recording TLS sessions and then reusing those as proofs? Because that seems really significant. Or what are the constraints around that?
Yeah. So this is there's a paper called Deco. It doesn't require the server to change at all. The client needs to run a second, or it needs to coordinate with a second party where they basically join their keys before they make the request, and then you have the second attestation that from a third party that you got back what you claim you got back. The paper's great, would recommend. I'm not aware of it being put into practice other than we're looking at this actually for a couple of our systems. Blaine on the Fission team is building a name system, thinking of it like a superset of DNS that also runs in this self-certifying way. That will also probably use something like Deco, but it also gives you this ability to, instead of just saying yeah, totally trust me, this is what I got from the server, you can also get secondary attestations that in that specific session, this is what happened.
Other questions? Cool. Thank you, Brooklyn.
Great, thank you.
I think it's now time for lunch. So go lunch. And yeah. Announcement, 5 minutes. We will be restarting the conference in 5 minutes. You can eat at the chairs. 5 minutes for some live music time and a lot of good stuff. 5 minutes. Okay, 2 minutes, everybody. 2 minutes. Come back into the theater. In 2 minutes, you can bring your food, your snacks, your sparkling water. 2 minutes. Or die. I was going to say, that's good energy. All right. All right, all right, all right. How was lunch? Was it dope? Pasta's dope. Cool. We got some announcements. Mr. Benson.
Okay, so posters arrived. If you ordered a poster, they're in the lobby. They're in tubes. If you don't need a tube, we have some flat ones too. If you didn't order a poster and you want one now, there are enough for you. So don't worry about it. We can give you one.
Everyone gets a poster.
Everyone gets a poster. They're all under your seat. No. Lula Lounge tonight. We'll go from here to Lula Lounge. I mean, you can go whenever you want, but doors 6:30. The performances start at 7. There will be food there. There will be beer there. There will be wine there and other drinks. We will be providing you with a couple of drink tickets each, so you don't have to worry about spending Toronto prices
three
on
different
drinks.
Performances, short performances. David will be performing again tonight.
A
Ramsey
DJ.
Nasser. Jen will show some really great artwork, art stuff. So it'll be really fun. So make sure you catch that.
Yep, and that's it for me. If you need directions to Lula Lounge, you can find me in the lobby. Enjoy.
Cool. Thank you, Chris. All right. We are ready for our next speaker. The little story on this one with David, who's at McMaster University. I like this Networked Imagination Laboratory. I came to programming through music. To me, music is always the future of programming and computing. I wouldn't have been writing code at all if it wasn't for music. And Sam Aaron, who is I've been a big fan of for years, was like, you have to bring this person. You have to bring David. He's amazing. And then I listened to David's stuff and watched performances and was like, this is awesome. And we talked about like kind of a mix of talking about his work with live coding and music and network music. So super excited about this one. The many stories of algorithmic improvisation, AKA artistic live coding, the true future of programming. Take it away, David.
All right, thanks a lot, Zishan. Just wait for my screen to come up. Well, while I'm waiting for the screen, maybe I'll just take a moment to say thank you to Zishan and to Chris and to the entire Causal Islands team. I was here all of yesterday, and I feel like I learned a lot from everyone's talks. I'm sure I'm going to continue to learn a lot for the rest of the conference. I'm just really happy to be here. I'm coming to you from just down the shores of Lake Ontario, the southwest corner of Lake Ontario, Hamilton, Ontario. McMaster University, where I work, sits on a kind of sandbar just above a body of water called Cootes Paradise, usually nowadays. That is kind of like a little body of water off Hamilton Harbor, which is itself off Lake Ontario. It's a ecologically and historically significant place. That little corner of Lake Ontario is mentioned in the Between the Lakes Treaty, which was a treaty between Anishinaabe people and the Crown. We're often in the habit, and I think it's a good habit now, of acknowledging the territories on which we work. McMaster, where I work, is the traditional territories of the Haudenosaunee and Mississauga people. And I think that there are like complicated responsibilities flowing from that, and I think probably many of us in this room who are settlers like myself also have those complicated responsibilities. And so I hope that one thing we can do in the conference is pay some attention to that. The work that I'm going to present, I think of it as work that has, it's a product of, my labor and of the labor of the people that I'm working with, for sure. It's also a product of that land where we're all working. It wouldn't happen without it. It's kind of a part of it. It's also a product of the colonial relations that have been established on that land. So that's a way of saying that it's very non-innocent work. And I think that, without wanting to kind of make anyone too uncomfortable, I think probably a lot of the work that we're talking about here today and yesterday and tomorrow is not innocent in various ways. One of the ways that the work I'm going to present is, let's say, not innocent in respect of the colonization of where we are, is that it's very, very dependent, uncomfortably dependent, I would say, on accelerated graphics cards, on GPU technology, on ever greater amounts of computation, which depends on the extraction of all kinds of weird minerals from different places in the world.
Oh, I think it fell asleep.
So what do I do about that? That's something that I'm, continuing to think about, and maybe we can all think about it together. So, my title originally was "The Many Stories of Algorithmic Improvisation," and as I was sitting there yesterday, listening to everyone's talks, my talk has been changing too. So I'm going to go off script a little bit, with apologies. And so maybe it's the not so many stories of algorithmic improvisation anymore, because I think I've kind of, listening to people, I've kind of decided more of the stories that I do want to tell here today. And I think what I want to do for the first maybe 20 minutes or so is a very slow improvisation / tutorial with you all. So if you do have a laptop with you, I strongly encourage you to pull it out and to try to do the things that I am also doing with me at the same time, if you can. And if you're doing that, please don't be shy. Like if you that you're going to make a sound and you're afraid that it's going to disturb me, it's not going to disturb me, it's going to energize me. Like I love hearing the chaos of multiple laptops rendering different but related things at the same time in a room. It's like one of my absolute favorite sensory experiences. So, if you can make some sound and some flashing lights or whatever from your laptops out there, that would just be great. So with that said, I have taken myself here in Chrome to this website, estuary.mcmaster.ca. And what I get when I go to estuary.mcmaster.ca is something that looks like this. Looks like this if you're not zoomed in at first. And this is a collaborative, multilingual live coding platform that I've had the great pleasure of working on for the last 8 years or so, and playing with all kinds of people, both people that are working on the platform and people that are using it and playing with it for various reasons. And if we go to the About page, we learn a little bit more about those people. So I'll leave that as an exercise for the reader. I'm going to set my view up to be a little bit more convivial for me. You don't have to do that step if you're following along. And I have an interface with 2 panels, and I'm going to start live coding in them, because the best way to talk about live coding is not to talk about it. It's just to do it. I have these drop-down menus, and I'm going to pick Mini Title, which is an estuary-specific variant of a really great, popular, influential live coding language called Title Cycles. And I'm going to start to use title cycles. And I'm going to make a pattern that hopefully we will hear in a second. I believe I'm making sound. Yep. Am I coming through to the room? Let's figure that out. There we go. Thanks. So there's a recorded sample. It's being played once per cycle. And the way this language works, everything in between the quotation marks is a pattern where time is divided into regular units. So if I put GTR twice, and then I click the evaluate button or I press shift enter, I'll get 2 of them per cycle. Don't hesitate to make sound out there in the audience or at home if you're following along. there is going to be like kind of a test about this later. So best way to learn is to do. It's possible to pick other samples from the same bank of samples. What we have is actually equivalent to this. And there's really two ways that this starts to get more fun, I think, which is to start to combine different types of patterns. That's way number one. So we have a pattern that's triggering sound samples, and we have a pattern that is changing the transposition of them. Those two patterns both take the same length of time, so they always line up in the same way. If I put angle brackets, the second pattern will now take 2 cycles instead. We'll get 2 note zeros and 2 note fours, which has a little bit of extra interest in this case, I think, because the samples themselves have a longer duration than the triggers that we're sending. And so we get to kind of experience the slightly more complicated way the texture of that sound interacts with the pattern as well. We can do math on this. So if I'm going to put that last part of the expression in brackets and add 3 to that pattern, everything moves. And that motion up 3 semitones, that's the technical description for what we just did. That was an improvised motion. Like, I just made that up right now. I'm not sure there was any right or wrong answer to that. But it's only by picking a number, as it were, and making it happen and seeing what it sounds like in the room that I get to know what that sounds like. We could make this a pattern too. This is going to work in here, but let's add another pattern. I can't resist. Let's pattern the panning and let's make it random. Can't tell if that's working from here on stage because I'm really close to one loudspeaker. It's mono. Okay, never mind. Imagine the things were in different places, left or right. Well, we could make the gain random, which is going to really make things kind of sparse because we were kind of at full volume already. So now we're going between nothing and full volume. So everything is kind of, the average of everything has gotten lower. Oh, I hear some guitars out there. That makes me happy. Keep that up. More of that, please. So this expression rand that I've just added is giving us random values between 0 and 1 that are a deterministic function of where we are in a metric grid, which is kind of a cool thing. I'll come back to this in a second, but I can't resist saying it now. It's kind of a cool thing because one of the consequences is that when we make music in this way with people that are distributed, let's say they're making music together from different locations, different parts of the world, if they're using the same metric grid and they have clocks that are synchronized, loosely speaking, then they're going to get the same results in different places and different times, even though everything in this platform is being rendered locally. The only thing that the server is ever doing, even when we do collaborative things in this platform as it's structured, is sharing information about the programs. all of the rendering happens locally. Okay, continue to improvise a little bit. Maybe I thought that making the gain random would be a good idea, but maybe now I'm a little bit dissatisfied by the way that things are kind of popping in and out of existence because of how extreme an effect it is. So I will remap the range of these random values between 0 and 1 to be between 0.6 and 1. That's better. Often when people play with these things, one of their first impulses in improvisation, it's not a bad impulse, is to work with other layers. I think it comes from the fact that auditory perception itself is often capable of dividing things into many layers. So it's not surprising that when people improvise or people compose music, they want to make different layers and have different things happening at the same time. So the way that we would do that here in Estuary and mini title is with stack. And we would then have a list with square brackets and quotation commas. And we can put some other pattern, like maybe this. I didn't add that. I have to make a quick detour here to the wiki for Estuary. To grab a URL of a community-hosted bank of samples. There's a bunch of these out there. I said a moment ago that one of the fun things to do is to start to combine other patterns, to pattern other musical parameters at the same time. That's one of the things. Another really fun thing to do is to start to transform the patterns in different ways. So what if every 4 cycles we had twice as many guitar triggers, but we maintained the same pattern of harmonic transposition? And we stuck all the extra guitar triggers on the right side. Well, we're in mono today, you won't hear that. Imagine it. This is a multilingual platform, so I'm going to start working with something else at the same time. Well, not at the same time, going back and forth. Work with the punctual language instead and start with something simple. technical. But maybe it becomes interesting if we start to do things to it. Like doing things differently in different parts of the cycle, like we were just doing with the music a second ago. To buy myself a little time, I think I need to make the music a little bit more complicated so that we don't get, too bored of just hearing the same thing over and over again. We're not actually hearing the same thing over and over again. It's randomly leaving off some of the guitar notes, but that's pretty subtle. I think a simple way to do this would just be to make the transpositions really long, so they're always changing. Two, 3, 4, 5, 6, 7, 8, 9, 10. Works for me. Now that I'm back in the music, I can't help but pay attention to it. What if some of these samples were reversed? But not most of them. Is that my first syntax error? Has anyone else had a syntax error yet? There we go. Yeah, there's no shame in it. And if anything, there's shame in not having a syntax error. It means you're taking it easy. What's my syntax error though? Oh yeah, perfect. This is what's so great about doing this for like a crowd full of many programmers. It's great. Okay, now we're getting some of those backward samples. I could listen to this texture forever, so I'm going to go back to paying attention to the imagery, and I'm going to do something that I often do if I'm just improvising totally off the cuff like I am right now, which is to go to Wikimedia Commons and grab whatever the picture of the day is. And if I go through to the deeper URL that is CORS compliant and grab that, that. Oh, that's too dark. fit the mood of the music exactly, but maybe it will later on if we keep improvising. These two things will come back together. Well, I'm going to back up, actually. One of the things I think it's quite fun to do with pictures is to make them kind of wiggle the way the lines are wiggling. So that might be something like this. We won't move the image at all in the X dimension, but we'll move it in the Y dimension by an amount that corresponds to where we are in the X dimension and its analysis of the audio at that time, which would look something like this. So it's moving up and down, but not the same amount in all places. It's fun to play with masks and geometry. In generative visuals, there's a lot of cool generative visual work out there. There's a tendency to do things that occupy the whole screen all the time. It's easy to do, and I sort of fell into it here today too. Right away I was kind of, already I've filled up the screen with stuff. It can be a little bit overwhelming though, so it's nice to have ways of like toning things down and keeping them really small on the visual surface. This might be one way. So it fades a little bit as it goes towards the top and the bottom. Can make that fade a little bit more extreme by putting those values between 0 and 1 to the power of increasingly high numbers. If we put it to the power of 4, it concentrates a little bit more on the center of the screen. It's a little bit more abstract now. We have lost the referential information that the image had in it originally. But maybe now we can use it as a source of colors and textures, now that it's not so obviously a symbolic image. First step, I'm adding some feedback. Video feedback is fun. Stabilizes things a little bit, reminds us a little bit of analog video, maybe. Getting a bit hard to see. I'm going to change the theme to dark so that text pops out over the visuals a little bit more. What if our video feedback was moving? That's easy to do. Have it not move in the X dimension, but move only in the Y dimension. And let's have it move outwards. So that means we would be grabbing color from the previous frame at a place that's more inwards. So I could take Fy, which is the Y position, and multiply it by something less than 1 in order to grab from somewhere more inwards on the screen. Oh, I think there's a... What did I do there? And for me, this is the first time with the visual improvisation that we're doing here, where it starts to get what we had in the music a while ago. Like I drew your attention to the way that the lengths of the guitar samples overlapping slightly with each other produces an interesting effect because those times don't line up with the times of when things start. So there's a kind of emergent effect there that is interesting, where the computation is producing a result that in some sense is what I intended, but also exceeds that in ways that I can't necessarily predict. There's parts of what's happening visually now that I'm not really sure why they're happening. Like, I still understand the code, at least I think I do. But I can't fully explain, for example, that kind of white banding effect that we see there. Is that some kind of artifact of, the way, the limitations of the textures in OpenGL and the shader? Maybe, I don't know. Some specificity of my accelerated graphics card? Could be. Sometimes it's those kind of things. Or is it just that there's something about this image, that the interaction of that source material and image and this music that is happening to produce that? I don't know. We got to that point of not really knowing what was happening fairly quickly. And I'm quite happy to be there. Yeah. Yeah, let's try it. Let's go to yesterday's Wikimedia Commons image, maybe? There we go. It's a very long URL. Oh, we gotta go to the deeper URL. Sometimes it's hard to see my mouse. There we go. Oh, I had it. I lost it. And I'm going to maybe just show off something a little bit here while I'm here too, which is to change the crossfade time. One of the characteristic features of this language Punctual is that it responds to a kind of unique dynamic of live coding. Live coding creates a situation where often you want to replace a program with a new version of a program and still have the old version around for a little while. Because it sounds kind of abrupt if you just sort of change things all of a sudden. So in Punctual you can evaluate, but everything about the evaluation environment, the time that it happens, is actually part of the program. It's an important part of the specification of the program, and that interacts with these crossfade times, like the 15 at the end here. And if it's working, we should have a 15-second crossfade to that other image. Well, we still got the banding. Make a nice graceful exit here. I'm gonna have the video gradually fade out while the feedback stays up. And then over here on the music, I will just type out my fade out. Some of you may be thinking, shouldn't that be automated? Like, shouldn't we be automating this fade out? Yeah, I guess. But actually, I quite like doing these manual fade outs where I type it. It's good typing practice, for one thing. But there's also something meditative about it. Or maybe athletic. Something in between those two things. something about our feedback algorithm is producing those that banding, because even when there's no input to it anymore, it's still doing that. Okay, so I have some slides that I'm going to just whip through to give some ideas about live coding, now that hopefully we have some sense of what it is or what it could be. I'll start with this one, because this is one of my favorites. Wendy Hee Kyung Chun on source code as fetish. She wrote back in 2015 that software as source relies on a profound logic of sorcery, a fetishism that obfuscates the vicissitudes of execution and makes our machines demonic. Further, this sorcery is the obverse rather than the opposite of the other dominant trend in new media studies, the valorization of the user as agent. A little bit further down, closely engaging software will not let us escape fictions and arrive at a true understanding of our machines, but rather make our interfaces more productively spectral. As a fetish, source code can provide surprising deviant pleasures that do not end where they should. Framed as a resource, it can help us think through the machinic and human rituals that help us imagine our technologies and their executions. And I like this quote as someone who's been doing a lot of live coding over the last 10 years, because I think that one of the things that's happening in live coding is that we are exploring a generally held fetish for source code, and that lets us kind of like turn it around and examine it, and perhaps also gain some pleasure from it. I think that the way that the word fetish is being used here is kind of echoing the way the word fetish is used in classical Marxism, the fetishism of commodities, the idea that the price of something, the way that it appears on the market, conceals this larger network that actually produces and eventually consumes the thing. And so source code seems to have a similar property. People imagine it as the thing that produces the results that we receive, but, well, the real story is a little bit more complicated than that, a lot more complicated than that, as lots of people in this room know. Another thing I like to refer to sometimes, thinking about what live coding is and what it might mean, is the Top Lap Manifesto, which is a tongue-in-cheek manifesto that was made by a bunch of people, I think a little bit over a decade ago. My favorite line from the manifesto is the second one, "Show us your screens," because I feel like that practice of doing things with computers and sharing the screen with people all the time, like, if anything, is the practice that I found to be so productive about live coding. It's that. So you might actually be sharing other types of things with people, and they might not look like text source code when you're live coding, and I think that's okay. The environment you're just using, Estuary, is a multilingual environment. There's lots of different programming languages that might be available there. On one level, my interest in this kind of thing is motivated by just like the very everyday practical realization that if you're improvising with people, which is something that I'm really fond of, and I think is a really important and productive practice, being able to have different quote-unquote tools in the toolbox for different people and different moments maybe helps other people find a way into things. But at a more profound level, it's also about a discomfort with the tendency of programming languages and technologies to be understood, even if only provisionally and locally, as one true languages. You know? People commit to them and invest in them in, let's say, monogamous ways, at least for a period of time. And for a long time, I've been interested in the complexities, sometimes hidden complexities of our relationship to language, and I take inspiration from, among other places, this minor monograph of Derrida's, The Monolingualism of the Other, which is a reflection on the complexities of his relationship to the French language. It's a meditation on this phrase the beginning of the monograph, I only have one language. It is not mine. He continues, these are little excerpts from the first few pages. The monolingualism in which I draw my very breath is for me my element, not a natural element, not the transparency of the ether, but an absolute habitat. So kind of referring to a kind of Sapir-Whorf hypothesis here, language as the horizon that contains us and lets us think about what is possible. But then he continues in almost the next breath, yet it will never be mine, this language, the only one I am thus destined to speak, as long as speech is possible for me in life and death. You see, never will this language be mine, and truth to tell, it never was. And the book starts to unpack these things in more detail, like all of the ways that the French language, for various reasons, universal and personal, is not really available to him. I am wrong to speak of a crossing in a place, for it is on the shores of the French language, uniquely and neither inside nor outside it, on the unplaceable line of its coast, that since forever and lastingly, I wonder if one can love, enjoy oneself, pray, die from pain, or just die, plain and simple, in another language, or without telling anyone about it, without even speaking at all. And what I really like here is this image of being on the shore of a language, because that's been my experience over the past however many years, practicing multilingual live coding and also doing all of the development that goes into this, never really being committed to any of these tools, but kind of like drifting on the tides and drifting in between different shores of different languages. It's an interesting place to be, and I think maybe it is not going too far to speculate that it is a place, this place of being open to languages that are closed to us, or languages that maybe are more, do more to serve others than to serve the self, could be an important part of having more people involved with whatever the possible futures of computing are. And making a little bit of a jump, I think that is, that's one of my interests in live coding. I think that's one of the ways I would connect it to synthetically some of the themes of the other speakers at the conference here. Like I think live coding, if nothing else, and I think it can be other things, but if nothing else, it can be a place where people brush up physically, bodily, sensorily against computing things and start to become comfortable with them and start to derive, as Chun says, deviant pleasures from them. And I think we need that, as well as all of the brilliant ideas that we might have about what can be done with these technologies. I've learned a lot over the years from working with a group at McMaster called the Cybernetic Orchestra. We meet almost weekly to do live coding together, and I won't play any of that now. But the S3 platform that I just showed you is well suited to doing such things together with other people, and it's just such a great practice. Debated about whether to play this or not, but I will. So this is an excerpt of a solo live coding piece that I did originally back in 2014, and I did various performances of it between 2014 and 2017. Haven't done it much recently, but I still think of it as a piece that is alive that I will go back to. A piece called Demon. I wanted to be able to play guitar and live code at the same time. You can't really do that. I don't have enough arms for that, but perhaps an agent could do that. And there's a number of these pieces out there, like live coding where an agent does the live coding. The agent, in this case, the original version of it was quite crude. It still is quite crude. It's basically walking through combinatorial sets of possibilities that I thought might be interesting, making choices in some cases very arbitrarily or random about them, and then being forced to type it out so as thus to share what it's doing with me, who is watching it and also listening to it. Because it's forced to type it out, of course, I can also change the code later on, and usually that's how performances of this went, at least at first, that I would play guitar in the beginning while it would do the live coding. You know, we would have that kind of interaction. And at a certain point, to take it apart, which was more complicated, I would put the agent to sleep and do the rest myself. This was at an algo rave, which is a characteristic event, a type of event, loosely associated but not exclusively with the live coding community, where people have a club night, dancing and that kind of thing, but a lot of the music is live coded or otherwise algorithmically generated. I'm going to skip ahead a little bit. Super crude. Like, I would hesitate to call this artificial intelligence. If anyone goes and looks up the old code repositories of it, like, do not expect sophisticated, artificial intelligence algorithms there. You won't find them. Later versions did have some simple machine listening, and who knows, maybe I will inject a little bit more sophistication into it the next time I get to go back to it. However, as I think about this piece now, I've been thinking about the echoes or connections of it with a deservedly much more famous piece of agential music, of artificial intelligence music, George E. Lewis's piece Voyager, which was an improvising agent that would make musical choices on stage and was used by Voyager sometimes just with himself playing along on trombone, sometimes with other people, members of the Association for the Advancement of Creative Music, free jazz musicians, basic jazz and free jazz musicians, basically, that would play along with this piece as it evolved over periods of decades. And Lewis has written in interesting ways about this piece. So the connection with the piece I just showed you is that, like Lewis's piece, I'm starting to think about the possibility of, as an artist, having this agent piece that I develop over a long time, not necessarily for anyone in the world to use, but maybe for the people who I already have musical relationships with to use, and for myself to use. And so it's interesting to read what Lewis wrote about this piece, because I think it connects in interesting ways to our present AI panic. Writing in the year 2000, Lewis writes, "For me, what Jerry Garcia called the anti-authoritarian impulse in improvisation led me to pursue the project of de-instrumentalizing the computer. The system is designed to avoid the kind of uniformity where the same kind of input routinely leads to the same result. Voyager's aesthetic of variation and difference is at variance with the information retrieval and control paradigm that late capitalism has found useful in framing its preferred approach to the encounter with computer technology. Interactivity has gradually become a metonym for information retrieval rather than dialogue." And so the aim is to make a piece then. I think that the implicit aim of Voyager is to make a piece that's about dialogue. And I see that as the aim of Demon as well, even to whatever extent it engages with artificial intelligence techniques. And I think maybe that's also something that comes out of the practice of improvising with computers, is this interest in more generally reconceiving the role of computing technologies as not only or primarily being about information retrieval, which is so often how things are cast, but as tools for dialogue, that is to say, tools for exploring our relationships with each other and with the physical world and things like this. So I think maybe now is the moment to quickly do a roulette. No, sorry, we don't have time for that last thing I was going to do. So I changed my mind. I'm going to show you one other thing that we do with Estuary, and then I'll take a quick question or two. So one of the things that is kind of fun to explore with Estuary and with collaborative live coding is making your own languages. And that the form that this has taken in the last year or two, beyond sort of deep, complicated languages like punctual or tidal, is what we're calling JSOlangs, which is a portmanteau on esolang, or esoteric programming languages that are meant to explore some kind of artistic concept, or maybe they're intended simply as conceptual art pieces in their own right. And JSOlangs in Estuary are simply little pieces of JavaScript that define new languages, and then you can use them right away. So this is an example of a JSOlang that I call Drone 0, and it's just a simple language that lets us take advantage of the fact that punctual produces both sound and visuals to make a language that produces sound and visuals with an even more reduced syntax. Oh, forgot a 0. So this is a language where the only element of the syntax is numbers, and the numbers make up chords in MIDI note numbers, which is a well-known standard. And so I can start to improvise with it really fluidly. The visuals are generative, but also predefined, I guess, as a particular aspect of this language's aesthetic. So yeah, those are some of the things that I'm doing. Multilingual live coding, often with other people, sometimes with agents. And it's a lot of fun. If I could leave you with one thought, it's if there's any way that you can fit improvisation with live coding into your life or into the life of people around you, come and join us, because there's like lots of people doing this stuff around the world. And there's lots of online communities and lots of ways of getting involved. So it'd be great to see some of you or hear some of you in those spaces. And I think I've got time for a couple questions.
So are you going to VJ the party tonight?
Sorry, could you say the question again?
Are you going to be the VJ for the party tonight?
I am doing a little performance at the party tonight.
Oh,
yeah.
awesome.
Yeah, thanks. Yeah, looking forward to it. I'll try to be. It's a party, so today it was like really meditative for some reason. So maybe I've got that out of my system now, and I can hopefully bring the party at night instead.
Have you tried using LLMs with this kind of work? Like ChatGPT kind of stuff?
Not so far. And I feel like I'd have to think really carefully about how I want to do that, because I knew I know the topic's going to come up. Like it's on everyone's minds, right? A lot of people have referred to it over the last few days. The thing that I think bugs me about the LLM hype right now is the way it taps into that thing that George Lewis critiqued, like the culture of information retrieval in computing. Like here is another system even more impressive where it's like, it's going to give people the answers. They don't need to do it themselves anymore, or, because we have a system that's going to give people the answers. So I feel like that when I do engage with those things, just like in the earlier and crude aspects of the daemon piece, it'll be trying to find some way of like engaging with it, but really, really not asking it to give me the right answers, and just like disengaging from that whole paradigm of using computers as devices to tell us what to do in order to get by and pass and conform. That is just so all over the place and crushing, but also resistible. Thanks for the question.
Cool. Anyone else? Oh.
I guess I'm wondering about techniques for like teaching or like engaging like the community in live coding. I think like I've tried getting into it with friends, and I found it super fun, but I feel like, yeah, it's just like an interesting thing to learn for someone without a coding background, because they've got to pick up the language and the music aspect of it. So I'm just curious, like, what that experience has been like, if there have been people who joined like the cybernetic orchestra without programming experience.
Yeah, thanks for that great question, which, is really close to my heart. I don't know if this is going to answer it directly. I mean, I think different people have all kinds of different experiences with these things. But I think, for me, like we don't have enough languages. We don't have enough diversity of computational interfaces out there, and not just in live coding, but in general, actually. And so that can be a really oppressive thing, right? Like, and then there's another oppressive thing on top of it, which is like how many people, like coding, computation, how much is there this general social discourse out there about it as this thing that you have to do or else you will be obsolete, like learn to code or else, it's as a kind of like gun that is held to the collective head. Those are really distorting factors, I think, that come into when people are learning about computing or when people are live coding. So I think being able to create situations that are playful with languages and notations and interfaces that are as easy to use as possible helps a lot. Having like just jam sessions, there's a bunch of those that people organize online, are great. And just like encouraging people to have fun with it. And maybe, I guess, jumping back to my point from a few seconds ago, maybe trying not to think of live coding as something that's going to teach people Python or teach people how to be machine listening engineers or whatever, but rather simply as a way of exploring improvisation and art in the world that we live in, which, for better or worse, is littered with computational devices. Like I'm gravitating more and more to thinking of it that way, and like kind of like finding ways of subtly pushing back on the "you should do this because it's good for you" narrative that is too easily out there about anything to do with code. But I have so many other thoughts about this, so we could chat about it later too. Like that's one of my favorite questions.
Cool. Thank you, David. That was awesome.
Thank you all for listening.
Is that the Nick Collins on there? Super Collider Nick Collins? I was asking, is that Super Collider creator Nick Collins, right? On the yeah, okay. I went to a show many years ago in New York that was Nick Collins versus Nick Collins.
Right.
Which was awesome. A guitar player named Nick Collins versus someone live programming, and
was an amazing experience. Well, kind of interestingly, going to the next talk here, there's a tie-in. I mean, Edwin Brady, who I've known for a good amount of years now, is all about showing your screen and dealing with dependent types. Who here has used Idris before? Cool, a couple people. Idris 2? Nice! You have that. So Edwin's is at St. Andrews. I've actually been lucky enough in my life to have been semi-taught by Edwin for like a week's worth of type theory camp at the Oregon Programming Language Summer School. Highly rec for people who love type theory. But one thing great about Edwin is he teaches with demonstration, and maybe people have went through his book, Type-Driven Development. Anybody? Type-Driven Development? Woo! Yeah! Yeah. In this work that Evan will go through today, he'll be showcasing quantitative types in action, which are like linear types. I dabble in type theory in my other job, and so for me, type theory could be really, really fun, and he makes it very, very interactive. So, without further ado, Edwin Brady.
Well, hang on. Do I need I'll probably need a mic, won't I? Or can you hear me through this? If I stand still? We can. The next question is, can I stand still? It's a challenge. And we need code, and we need that. So yeah, I'm actually going to do live coding as well. Not in the same sense, I'm afraid. I'm sort of imagining a future talk where I do live coding via live coding in Idris, and that will be, I think that's my new career goal. Because David, you were obviously having enormous fun there, and I was having enormous fun too, playing along, and that's the rest of my week gone. So anyway, so yeah, I saw a couple of hands go up when Zishan was asking who knew Idris, and I'm kind of glad there weren't too many hands went up. Firstly, because you have nothing to unlearn, and secondly, because I've kind of worked under the assumption that this is an audience who is familiar with functional programming concepts. Is that reasonable to say? So you know about higher order functions. You've learned some of these details from Shriram this morning, of course. But you haven't necessarily seen dependent types, or what I'm going to talk about here, quantitative types. That's my assumption about the audience going into this talk. My goal for this talk is that by the end of it, that you will know what this title means, and if we get that far, then we've succeeded. Right. So I'll tell you a little bit about Idris just to set the scene. So Idris is the programming language that I've been working on since goodness knows when, as long as I can remember. So 2008, something like that. And it started because I started working on it because I just wanted to see. I wanted to see if dependent types, which I'll talk about a little bit more, were a reasonable way of building a practical programming language. Since then, I've completely lost or changed my opinion of what practical even means. I don't know what the word practical means anymore. I'm just going to leave that to the audience to decide if there is anything practical about this. But let's just say I'm trying to do something general purpose that makes programming fun. So it supports. I think the key thing about dependent types, that just to keep in mind throughout, is that types are first class in the language. So if you've done a bit of functional programming, one of the things that people will tell you when they're teaching you functional programming is that functions are first class. First class meaning, kind of informally, you can assign them to variables, you can return them from functions, you can pass them from functions, all of that. So if your language has first class types, then you can assign types to variables, pass them to functions, return them from functions, and so on. So you can compute with types, and there's not any more a syntactic distinction between types and values. And we're going to see throughout this talk how that all changes the way we think about some kinds of programs. And this new version, basically, maybe 5 or 6 years ago, I'd got Idris to version 1. It was kind of working okay. We were able to try out some interesting things with it, and I thought I want to scale this up and see if I can write some realistic-looking programs. Or I can write some programs of reasonable scale. So what should I implement? And I realized two things. Firstly, Idris 1 was just far too slow to do anything interesting with it. And secondly, I don't actually know how to write any other kinds of programs. So the only reasonable thing to do was have a crack at implementing Idris in itself. So the end result, I put these numbers on the slide just because every time I give this talk, all of the numbers go up, and it's interesting to see how it changes over time. But also to give you a sense of scale, that it's a reasonably sized project. It's able to compile itself, and so that's just the rite of passage for a programming language, I suppose. And there's enough libraries with it, and it's kind of the performance is reasonable. Built on quantitative type theory, and I'll give you a rough idea of what that means up front. So when you write your APIs with types, or when you give the type of a function or the type of a variable, that type is ask 100 programmers for a definition of type, you'll get at least 100 answers. So I necessarily come up with a definition of type, but that type is there to say what the program is supposed to do. In a kind of very vague sense, it's a kind of a plan for the program. So dependent types, first-class types, give you a bit more precision in explaining upfront what the program is supposed to do, and then bringing in quantitative types. What that's going to do is allow us to have a bit more precision in when the program is allowed to do it. So conventionally, types are about what. Quantitative types, they're going to be about when. And that when might be now or later or once or never, and that's the thing to keep in mind. Now, I think the best thing to do is just do some. You don't need to see me reminding myself about things. I'll start with just a warm-up example so that you've seen some Idris code that is doing something that is familiar to. I'm sure you've all written code to append to linked lists. I want to give you a sense of how we work on programs in Idris. So this is type-driven development. I like to call it type-driven development by analogy with test-driven development. And there are some similar concepts going on. And I suppose the main similarity is this encouragement to think about what your program is going to do before you're... Again, looking back to Sriram's talk, think about what your program is going to do before you start working on the program. You can do that with examples. You can do that with tests. You can do that with types. Here we're going to do it with types. We've got a type signature, so we can write type signatures without a definition, and Idris will happily compile that, and you'll get a runtime error if the program is incomplete. One of the principles here is that programs spend most of their time in an incomplete state. So the majority of, as programmers at least, the majority of time you spend with a program, it's with an incomplete program. And it's quite useful if your compiler will help you along with that. While your program is incomplete, your language implementation still knows an awful lot about your program. So you've compiled it, it's done a lot of syntactic and semantic analysis on it. So it knows about the types of various expressions, various variables, and I don't think the compiler should keep that to itself. The compiler knows these things. You write the program, you get an error message, which is essentially the compiler saying, ha ha, I know something you don't know. And one of the many principles of type-driven development is it shouldn't keep that to itself. So we can think about programming not so much as writing down a complete incantation, feeding it to the oracle or feeding it to the teacher, who then says, ha ha, no, you've got it wrong, see me after class. Rather, we should think of the compiler as being our lab assistant, where I've written down the type and I say, here's what we're going to work on together. And the machine says, okay, how can I help you? So I'm just going to interactively write this program. I'm doing this inside Vim because I'm like that. But there are other editor modes. So VS Code, I think, is what all the cool kids use these days. Emacs as well. So if I ask it to give me a skeleton or candidate definition, that's what I've got here. This thing with a query you see on the right-hand side, this is, or I should say, just for the sake of those who aren't familiar with Idris, this is, we're defining programs in terms of recursively defined equations. So if you've seen any Haskell, who's seen Haskell? Yeah, most of you, good. Or ML or any kind of that form of language, recursively defined equations. And we can leave holes for things we haven't written yet. If we have a hole, we can ask the machine to tell us things about the hole. So it will tell me, what have I got? Well, I've got y's is of type list of A, x's is of type list of A. Types are first class, so A is of type type. What's the type of type? Type of type is type 1, the type of type 1 is type 2, and so on. Goes on forever. Don't worry about it. We lied all of that stuff. And the thing we're trying to get to is also a list A. So there's a mysterious 0 here. I'll come back to that. We'll just finish this definition. Another thing I can do is ask the machine to give me all of the possibilities for one of these variables. So lists are defined as either nil or a cons cell. So it's either empty or it's a head and a tail. So I'm going to ask it to do a case split on the first argument. Gives me two possibilities. So in this first case, I've only got y's now. I'm trying to give a list of A's. Oh, so I'm trying to get a list of A's, and I've got a list of A's. So I think there's two possibilities for this. It could either be the empty list, a list of anything, or if it's going to be a non-empty list, the only thing it could possibly be is y's, because I don't know anything else about A. So I actually just asked it to search for that, and it picked y's. And then in this third case, I'm just going to fill this in. And I'll reload that just to make sure. Good, that's good. So far, so familiar, hopefully. All making sense so far, yeah. Here's a fun thing I can do, just as an aside. I'll delete all of that. Something I'm going to use just a little bit in this talk is a built-in type-driven program synthesis mechanism. So it's fairly basic. What it does is, if I ask the machine to generate a plausible-looking definition from the type, it will essentially do what I just did, which is invent a candidate definition, do case splits, do searches for plausible things that fit the hole on the right-hand side. It will do that. It will search through, I think it's, if I remember rightly, it comes up with either 16 candidate definitions, so a nice round number like 16, or it stops after 1 second, and then it picks the most likely one, where the most likely is defined by, does it use all of the inputs? Which is, this, by the way, I'm going to call that an algorithm, in the sense of a thing where I can explain exactly what it does and know what result it's going to get, which is apparently not what algorithm means anymore, however. There we go. So I asked it to generate it. It actually did come up with a pen, which is quite pleasing. I asked ChatGPT to. I've got to mention ChatGPT. It's. I can't really get to this point and not mention LLMs. ChatGPT also comes up with this definition, but I think it probably does it by web search. Another thing I can do if I don't get the thing I want, I can sort of repeatedly hit it with a hammer, and this is just giving me lots of other plausible looking. I mean, none of these are really append, are they? But oh, I mean, it's valid. It's anyway. Let's just use the one it first thought of because it happened to be correct. Okay, now first-class types are when things get a bit more interesting. So if I want, let's say, a type synonym, a type def, I don't need a special syntax or a special feature in the language for type synonyms because I can write functions that compute types. So this one's a teensy bit contrived, but I'm just going to go with it anyway. I'm going to take a Boolean as an input, and I'm going to pick a type. I'll pick one type if it's true, one type if it's false. So if it's false, let's have strings, let's say, and if it's true, let's have integers. Now, why would you ever write a function to compute a type? What's it for? Well, where do you use types? So you use types as part of bigger types. So here, again, a teensy bit contrived, but I'm going to convert from one type to another, and the type I'm converting from is going to be given by this first argument. So here we're going to see, I think the sort of probably the biggest thing to understand about first-class types, or about dependently typed programming in general, is that once you are allowed to express relationships between values and types, you can then start learning things about one part of your program from the behavior of another part of your program. So you can learn about, well, you can reason about which branch of an if-then-else you've gone down. Or you can say, well, the input here was a Boolean, therefore I must be expecting a string now. There is kind of a very familiar mainstream example of this concept, which is printf. So printf, you've got a format string. That format string tells you what the type of the rest of the inputs should be. So, so you probably have seen this before, just not in this sense of being baked into the language. Okay, so if I look at the type of this right-hand side now, it says, okay, we've got something of type make type X. We want something of type make type not X, but I have no idea what these types are. And the way we'll find out what these types are is by pattern matching on the Boolean. So if in the case where the Boolean is false, if I check that right-hand side now, okay, it now knows more about what we're supposed to be doing. We've looked at the first argument. That means we've learned something about the second argument, and so we've learned something about the return type. So we're doing a little bit of type level computation here, so it's a symbolic computation on the type to work out what the inputs are actually going to be. Now, I'm not going to complete this definition because hopefully you get the idea from that. Just one maybe realistic example of that, where you might use something like that. I've never actually done this in practice, but maybe you have you've got a dictionary, and in the case where the dictionary is small, whatever that means, 3 or 4 entries, maybe you'll just use an A list, so pairing strings with values. And if the dictionary is bigger, maybe you want something a bit better, like this. So sorted map is implemented as a I think it's a red-black tree internally. So it's a balanced tree internally. So you might want to compute the type that you're using for a data structure at runtime based on information that you don't get until runtime, but you want to reason about at compile time. So this is allowing us to reason about what's going on at runtime using information we only know at compile time. So that is... Yes, oh, I should have said this. I will take questions anytime you like. Just shout out. I'll repeat it for the sake of anyone who you know, so that Zishan doesn't have to run around the room. So, go ahead.
Could you go back to the code you had a moment ago?
Yeah.
Because I'm trying to figure out, so if you scroll down to the bottom, to the dictionary example.
Yeah.
What's going on with the braces?
Oh, what's going on with the braces?
The insert line.
Yeah, what's going with... do you know what? I'm going to defer that because it's a really important question, and it's so important that I even plan to talk about it. See, I did plan this. Who'd have thought it? Okay, so I'm going to talk about it in the context of actually when we get to quantities, because we need to know about quantities to know what's going on with the braces. So, tell you what quantitative type theory is. It's a lovely little It's a lovely calculus designed by, well, it is quite little actually. Let's be honest. It is. There's only a few rules compared to many other languages. So it's we're combining linear and dependent types. So dependent types you've just seen. This is first class types. Values can tell you something about types. Linear types. If I can, again, massively oversimplify, a linear type system is one where every value has to be used exactly once. So if a value can be used exactly once, that means you can start tracing stateful programs, for example. So the way we do I/O in Idris, for example, is we talk about the input world state and the output world state. Now that once I have done an operation on the world, like I've printed a value to a screen, the world has changed, so I can't use that old world anymore. So linear types allow us to reason in that way. Turns out to be quite tricky to come up with a system that combines linear and dependent types neatly. Many efforts have been made. Connor and Bob came up with something that I think is beautiful, and the key idea is that every variable is associated with a quantity. There's lots of possible choices you can make for what those quantities could be. I've kept this really as simple as it can. Well, not quite as simple as it can be, but almost as simple as it can be while still being interesting. And my quantities are either 0, that is, which means it's not used at runtime. So remember we saw 0 A of type. That means that type is not available to us at runtime. And then there's 1, which means it's used exactly once at runtime. And then there's this omega, which means it's unrestricted at runtime. So in your usual programming environment, everything is omega because it's unrestricted. If you're a Rust programmer, then it's not quite as simple as that. But in most mainstream languages, you're talking about omega. So what this does for Idris 2 is it solves a really irritating problem that we've had for a long time and not really had a good solution for until now, which is that when types are first class, and therefore when values are allowed to go into types, it's not entirely clear which of those values are going to show up in your program when you compile it and which aren't. And this can be an absolute disaster for performance because your program might end up computing things that are only really interesting in terms of reasoning. If we've got these quantities, I can say, right, the thing I care about reasoning about is not available at runtime, and then the type system will tell me that it's the type system will guarantee that I'm not doing needless computations. So this 0 quantity is really useful. It's the reason for having quantitative type theory in Idris 2. This 1 quantity, however, is far more interesting. And so 0, I use a 0 quantity all the time. I wouldn't be without it. It's fantastic. It allows me to know what's happening at runtime. 1, I play with this all the time. It's lots of fun to see what we can do with it. But as we'll see, we're getting somewhere with figuring out how to do things with it. We're not necessarily, found the right answer yet. So let me show you quantities, and in the process, answer the question about braces. So I'm going to do this this is my new favorite introductory dependent types example. If you've been to a dependent types talk before, you've probably seen vectors. There are no vectors in this talk. So, I know, yay! That's a second. I know how I said I was going to repeat things, but I'm not going to repeat them. Okay. So this is run length encoding. So run length encoding, it's a nice simple compression scheme. It goes back to I think television signals. And for those of you who are playing around with computer paint programs in the 80s and 90s, it's a way of compressing images that don't have too many colors in them. So essentially, you say how many of a thing you've got. And then the thing. What's going on here then is I'm declaring a new data type for run length encoded lists. The type of run length encoded lists is parameterized by a list of something. So this tie is a type. So lowercase, something that begins with a lowercase letter is an implicitly bound type variable. And the meaning of this is going to be that the if I see run length of x's, that means when I uncompress the run length encoded thing, I will get that original list x's. So the idea is that we have a sound, if not perfect, representation of the compressed list. So an empty run length encoding is a run length encoding of the empty list. That's all this is saying. And if I have some number n, a natural number, and some element type x, and I have the rest of a run length encoded structure, then that will represent the uncompressed list, n repetitions of x, and then concatenating more onto it. Now this isn't a perfect representation because, for example, this n could be 0, and then I've got 0 repetitions of the number. So it's not guaranteeing that it's the best possible compressing, but it is guaranteeing that it's sound. I should, by the way, implement rep. and I'm going to do that the easy way by asking the machine. It's kind of fun that when I do this type-driven synthesis, you're probably thinking, ha ha, I bet he's only doing the things that he knows works. And you'd be right. Of course I am. I've done this before. Honestly, it's a magic trick. It's a conjuring trick. That's all it is. It is valuable in practice. So particularly if you're doing some kind of boring plumbing, or if you've got a little function that you've written hundreds of times and it just follows the structure, that's what it's pretty good at. And the good news is what it generates, it's going to be type correct. And it doesn't free you from knowing what you're doing. You still have to look at what it comes out with and check that it's the right thing. But it's a handy little time saver. So I've got a test compressed list here. I'm not going to show you compression. What I want to show you is more about the quantity. So I'm going to show you uncompression, partly because the compression is a little bit fiddly anyway. The important thing is the uncompression. So I'm going to make my first attempt at uncompressing the list. So firstly, we've got these braces here. So any of these implicitly bound names, they are arguments to the type, or they are bound as function arguments, but they are bound implicitly. These braces here are saying, right, well, tie was an implicitly bound argument, but I do want to talk about it. So it's just bringing that implicit thing back into scope. Because X's has type list of tie, and that's what I want to produce is a list of tie. I'm gonna try generating this just to see what happens. Do we believe that? No, no. Right. So what about? We haven't used n. Now the heuristic for the synthesis is that we try to use everything. The only trouble is here it doesn't know what it's supposed to do with that n. It doesn't really play any part in the rest of the type. Now, I think the problem here is not so much that the types-driven synthesis is weak. I think the problem here is that the type hasn't explained what it is we're trying to do. So, it's like, I don't know how many academics are in the Sriram certainly is academic. You've probably had the experience of students coming to you and demanding a more precise specification because they don't know how to solve the problem. That's kind of what's happening here. But before I do, I'm gonna rule out one other possibility. So let's give that a better name. You might think, well, I've already got X's, so I've got the original list here. And I can, I have the original list in scope, but you'll see that it's got a 0 next to it. And that 0 means we're allowed to talk about it, but we can't use it at runtime. So this is a thing we can talk about at compile time for reasoning purposes, but not at runtime. So if I blunder on and try, it gives me, it says X's is not accessible in this context, which is perhaps an unhelpful message. It'd say, X's is not available at runtime. What I can do, one possible solution to this is I can make it available at runtime. So these braces, to answer the question from about half an hour ago, these braces are saying I have an implicit argument X's. Now, if I just leave the implicit arguments unbound, it will infer them, and it'll infer the type, it'll infer that they are an additional implicit argument. But if I say nothing else, it will make the assumption that I didn't intend that to be a runtime thing, and it will say the quantity is 0. If I actually give it and put it in braces, then the assumption is this is unrestricted quantity. So if I've got a function argument, whether explicit here or implicit here, and I don't give a quantity, then the quantity is assumed to be unrestricted. I can be explicit again. So the reason for those syntactic choices, which may seem a little bit mysterious when they first come up, these syntactic choices are made because the most common thing you want to do is the thing that involves the least typing, which I think is a reasonable heuristic for making language design choices. Let's just finish this off though to show how I might write this program a bit how I might give it a more informative type, because it's kind of annoying that I have to write an uncompressed function when I've kind of already written it. It's already in here. This run length type tells me everything I need to know about what an uncompressed list is. But but X is its compile time. So what I'm going to have to do is find a way of promoting that to a runtime value, and I'm going to do it using this singleton type. And because I'm British and in my 40s, I'm going to call the constructor val. And if you know why I've done that, have 5 points. Well done. Some of you clearly do know why I've done that. Okay, so this is a singleton. Then the singleton type is saying that, or the parameter of the type tells you the only thing that the value can be. Now, why would we want that? Well, in this case, the only thing the value can be is x's, because that's the uncompressed list. But there's no quantity annotation here, meaning it's unrestricted, meaning that we will have it available at runtime, which means that the job of this program is to take what we know at compile time about x and turn it into a thing that we know at runtime about x. If I ask it to generate that, it knows. It's in the type here. So I don't have to write that program again. It'd be annoying to have to write that program again. What is slightly annoying is it's put an underscore here. So it puts an underscore if it can infer it. But this is a case of the machine might not need that, but I do. So I'm going to add it. Okay, I'm not going to run this program. I'm just going to take it on trust that this does the right thing in the interests of time. So that's, I hope that's answered your question from 20 minutes ago. So that's what quantities are for. I think it's really, it's in this case, in the case of uncompressed, I think it's vital that we have the quantities that, if this x's accidentally leaks into the runtime program, then I haven't achieved anything by compressing it, because I'd be carrying around the uncompressed and the compressed version. Okay, so let's move on to the linear quantity, and I'm going to do this with an example that I imagine you're all familiar with. These days I use an ATM about once a year because my local barbershop doesn't accept card, and I get a haircut once a year whether I need it or not. But I used to use ATMs, and pretty much how they work is, or how the bank would like them to work, is that they shouldn't dispense money until you have validated, you've entered your PIN and it's been validated, and we're in a validated session. So here's a simplified state machine that shows how an ATM works. So most of the time it's sitting in this ready state, just sitting on the street waiting for someone to insert their card. When someone's inserted their card, it leaps into action. We're in the card inserted state, and at that point it can start doing more things. So it can start taking the input of your PIN. It can check any PIN that has been entered. It can eject the card. So obviously ejecting card doesn't make sense here. Checking the PIN doesn't make sense if the card is inserted. So we're thinking about when we can do things now and not just what we can do. If we check the PIN, that doesn't automatically get us into a validated session because the PIN might be incorrect. So we've got a transition for if the PIN is incorrect and one if it's correct, and then only when we're in a validated session can we dispense money. I showed this to a friend who works at NCR, the cash machine company, expecting to be ripped apart. That's a massive oversimplification. He said, "No, that's pretty much how we do it, except we do it in C." So, draw your own conclusions. So there is just to show this is a little bit there's a little bit of syntax to figure out here. I'll just highlight the most important bits because I'm not here to give an Idris course, but I am here to give you a sense of what it can do. So this L, again, I'm just using a single. I'm using a single letter because I'm a functional programmer, and that's just what we do. But the other reason for using L is because if something is being used a lot, I'm keeping the names short. So L is, in a sense, it's a linearity monad. So it's a way of constructing programs in a linear context and being able to say something about how many times the result is used and how many times the inputs are used. So this use equals 1 in the return type, there's a little bit of monadic magic going on that we don't need to think about here, but it's good to know it's there. That is saying the result of initializing the ATM is an ATM in the ready state that we are allowed to use exactly once. And then inserting a card, we've got an ATM in the ready state. It will give us back an ATM in the card inserted state. We're allowed to use that exactly once. We're using this ATM in the ready state exactly once. So these ones in the annotations are saying that once we have done an operation on that machine, we can't do an operation on that machine again. We can still talk about it. We might want to reason about it. We might want a trace of what's happened that we do at compile time, but we don't have it at runtime. Let's just see that working. And I've just got the types here. I haven't implemented an ATM visualization. Maybe one day I will. But I've got those types written down. Check pin is the interesting one. Did I have that on the? Yeah, I did. Let's talk about check pin. It is worth looking at what's going on here. So when we do these state transitions in the types, sometimes we as the programmer are in control to some extent. So we're in control if the card is inserted. Well, we're saying the card really is inserted. That's an operation that doesn't fail. I suppose the reality is that operation could fail, but I'm saying here that this operation can't fail. Checking the pin, on the other hand, as programmers, we are not in control over whether that pin was entered successfully or not. That is the environment's job to tell us if that was done successfully. And the way I've captured that here is with the machine that we're returning is going to be a resource that depends on the result of a pin check. If that pin check was correct, we move into the session state. If that pin was incorrect, we move into the card inserted state. Now what you see here, if you've been looking at these for ages, they get much easier to read. But as it is, it's a little bit, there's kind of a lot to take in here. And I think it's a lot easier to take it in by developing the program interactively, by developing the program as a conversation with the machine and having the machine help us refine what we know to a complete program. So the first thing I'm going to do is get out my crib sheet, because although I have done this 100 times before, I only forget it when I'm talking to an audience. You've all been there, haven't you? So the first thing we're going to do, I'm going to make a new machine. I'm going to call it M prime for the moment. We are going to insert a card into the machine we've initialized, and we're going to call it M prime. And the reason I'm going to call it M prime is so that you can see what happens. This gives us back a machine with a card inserted that I'm allowed to use exactly once. And now we have the machine M where the ATM was ready. We can still talk about it. We can talk about the glorious past where we had an ATM that was ready for action. But the fact that there's a 0 means that we can't have it anymore. So I guess there's a cake and eating joke. I did not, and so I'll do that now. So yeah. Sorry, I didn't hear that. Right. Okay. So, you know what? I'm gonna go back to the thing that I decided to skip, and I've decided given that you've asked that question, I've decided it was a bad idea to skip it. So I've got what I believe to be a cool example, but I'm more interested. I'd rather get the fundamentals across. So here's a small example. I'll get rid of these. I'll get these out of the way. So it's the duplicate one I'm interested in. So we've seen the quantity 0. So here's an example with a quantity 1. So I've just put the quantity 1 on the type to say that I can use this x exactly once, but I'm going to try to make a linear pair with it. Now, hopefully this isn't going to work. I mean, because we've only got one of it, and I'm trying to make 2. So if I try to generate it, it says no search results. but I'm just going to carry on anyway. I'm going to try to write it. So if I check the type of .RHS now, it says I have exactly 1x. The reason I have exactly 1x is because I said so, essentially. And then once I spend it, so this hash is the constructor for linear pair. So a linear pair is one where I use both I can use both elements of the pair exactly once. So yeah, if I now check the type of .RHS, it says, well, you can't use it anymore. Sometimes people ask here, what if you put the whole first? And I think they're trying to catch out my type checker to see if it goes left to right, but no, I thought of that. Well, if I have the two holes, then it assumes that I want to use it in whichever one I'm currently looking at. So when I'm looking at help, .RHS has an x of 0, and when I'm looking at .RHS, help has an x of 0, but I can't look at them both at once. So it assumes that I want to use it in the one I'm looking at. So that means that in this case, the reason that this M has a quantity of 1 is about the type of the bind operator in this linearity monad. So it's a little bit fiddly to get there. In fact, it involves some type level computation based on the use equal 1 in the return type. But essentially, it's a function type that has that 1 in the right position. Anyway, let's finish writing this program. So I'm just going to call it M throughout, because then we won't get the clutter of the old version. I'm going to try checking the pin, and I'll put my real pin in just to. So what do we get? We get so this is we saw this in the API. The result is this mysterious res thing, and then this calculation that depends on something. Now, I think that's a little bit complicated to have to think about, so I'm going to ask the machine to help me. And I will use a little shortcut to create a case block, so I can do case analysis on intermediate results. And you saw me earlier on, I was doing the case split on lists and case split on booleans. So I can do case splits on, I can ask the machine to give me case splits on whatever really. So if I do a case split on the result, it says, well, a result is, it's actually one of those linear pair types that we've just seen. It's a dependent linear pair type. And we can look at the type of the whole to get a little bit more information about what these individual components are. So it says, right, well, the R is the resource, and the resource is going to be an ATM. And what we know about the ATM, well, we're only going to know anything about the ATM when we know a bit more about val. So that's what this asking the machine this question has told us. And then the res that we had before, we can't use it anymore because we've spent it by doing the case analysis on it. I'm just going to simplify it because of what it's told us. I am going to change the names of some things. All I'm doing is factoring out the pair here. Yes, sorry, that is what I wanted to do. Yeah, that's what I wanted to do. So I've got my crib sheet. I'm not even looking at it. It's if I looked at it, then this would make more sense. Never mind. Okay, so all I've done is factor out that pair so that it's the code looks a little bit neater. Right, so we now have a machine where the case val, so that's this thing, is unknown. And we've got a case expression on it, and the clue in the type here is that if I do a case analysis on it, that might refine what's going on in the type of the ATM so that I can make more useful progress. So I'll just do a case split on it. So we've now got the two cases. We've got two branches. Either the pin was correct or it wasn't. In the case where the pin was correct, it says, great, we've got an ATM that has been validated. We're in the session. Off we go. And in the case where it's incorrect, It's still in the card inserted state. So thinking back, way back to the beginning of the talk, where I gave this contrived little example of, if I'm going, I'll just show it again. I got this contrived example of, the type changes depending on the Boolean. That's exactly what I've done here. So I'm reasoning about the two different code paths based on some result that I got from an operation. Now, something people sometimes ask here, which nobody has asked, and therefore I'm going to ask it for you, is why not just return an either? So the either type being a type which has two possible values of two possible types. So it either returns an ATM card inserted or it returns an ATM session. So the reason I don't do that here is it's a bit more flexible to not require you to check the result first. So again, I'm told by my cash machine friends NCR that you know when you enter your PIN incorrectly, I'm sure you all do this occasionally, and then it carries on asking you questions. So the machine will carry on asking you how much money you want and what services you want, and it's only when it gets to do the actual check that it tells you, oh, all of that stuff you just asked me to do, can't do it. So it carries on prompting you for these things. Apparently the reason for that is that they run on very slow internet connections and they package up all the requests at once. That may or may not be true, but I'm saying it on the internet, which makes it true by definition. So I don't know why I say these things out loud sometimes. Anyway, the point is we can do things in between asking for the result and getting the result, and it might be the same thing depending on the branch. So, and maybe I want to write a message on the machine. Is that the right? This sort of thing. So it just gives a little bit more flexibility to give that dependent pair rather than returning the either. Now, I've got just enough time to show you the bit I wanted to get to, which is about why would we actually want to do this. So this ATM example, I think it's pretty neat that you can define protocols this way that are checkable. These small little examples, but it would be fun to see if we can scale this up to realistic examples with, say, distributed systems or concurrency. So I'll tell you a little bit about session types and how we might represent those using a quantitative dependent type system. So session types, going way back to Kohei Honda in the late 90s, it's a typing discipline that allows us to describe patterns of communication. So you can imagine the state of a channel. So say you've got a protocol where you send a string and you get back an integer, whatever that means. Well, the type of the channel at one end will be, well, I have to send a string and then I have to receive an integer and then I'm done. And I'm not allowed to do any other send any other values in any other order on that channel because the session type tells me what order I have to do things in. So the goal here is to implement exactly that using quantitative dependent types, using this mysterious L monad that I've just kind of sketchily told you about. So the first thing we're going to do is define what it means to be an action on a channel. So this is kind of an embedded domain-specific language for describing communications. So on a channel, we can send something of type A, and then the next thing we do on the channel, I'm going to say that I don't want to map out exactly the pattern of communication in advance. I want to be able to do different things depending on what I've sent. So let's say I send a Boolean, I send true or false. Maybe I want to receive a string if it was true and receive an integer if it was false. So the following thing after I say what type I'm sending, I'll give a function that tells me what the next state of the channel is going to be, and we'll calculate the value of that function when we've sent the value. Same thing for receive. So if someone sends me a value, I will need to decide what to do based on the type of that value. Based on that value. So only when I get the value will I know the type of the rest of the communication. And then a channel is parameterized by the actions that we're going to do next. So this actions that you see in the channel type, it's pretty much the same as the ATM state. It's a bit more complicated, but it's the same idea as the ATM state that can have just those three values. So I need to define an overall protocol. So we'll call this the global session type. So this is the overall pattern of communication that the entire system is going to do. and that is, we say that a client can request a thing, a server can respond with a thing, or we can sequence a protocol. So if I've got a protocol that returns something of type A, and I know how to take that A and get a protocol gives me a type B, then overall that gives me a protocol gives a type B, so it's kind of like a monadic bind. And then when we're finished, that's a protocol that doesn't give me back anything. I'm going to write two functions, one that interprets a global protocol from the point of view of the client, one that interprets it from the point of view of the server. If I really want to, I can prove that these two functions are dual to each other. I'm not going to do that, but it's useful to know that the client interpretation is exactly the opposite of the server's interpretation. And then I'll just define, I'll show you what a protocol looks like. So this is a protocol where a client will send some command to a server. If that command was to add two numbers, then the client will send a request with the two numbers and the server will respond with a number, and then we're done. And if the command was reversed, then the client will send a string to the server will respond with a string, and then we're done. So this is a global thing that tells us what the client and server have to do, and then I can interpret that from the point of view of either. Just to show that we can get, we can start having loads of fun with this, I'll show you what a dependent protocol might look like. So maybe I send a number, and that number will be how many more things I'm going to send. So you see this sort of thing. I'm not going to pretend I know much about network protocols. I think you see this sort of thing in, for example, HTTP, where it says how many bytes are coming, how many lines are coming, so you know how many to ask for. So we can encode that sort of thing precisely too. And then we have an API that is similar concept to what you've seen before with the ATM, which is if the channel is in a state where I'm supposed to send a value, then I better send a value. And the next thing we do on the channel is going to depend on the value we've sent. So remember, this next was a function that says what happens next based on the value we've sent. Well, there you go. There's the value that we've sent. Receive is the other way around. You've seen this res type. You saw res in the case of card inserted. Well, again, as programmers, we're not in control of what the other end of the protocol is doing, but we are going to explain what to do depending on what arrives. So depending on the value that arrives, that tells us what we have to do next on the channel. And just like with the ATM, it's really easier to see this in action. So I've got a simpler one here, just so it's clearer what's going on. So I'm just going to send a bool, or the client will make a request using a bool, and the server will make a response either with a character or a string, depending on what that bool was. Let's comment out these branches. I can't use help again. There we go. So I can, while I'm working through this protocol, I can do anything that's unrelated to the protocol. I can do what I like. But as soon as I do something with the channel, it has to follow the protocol. So we've received a command. If the command was true, then we have a problem because here we go. I like to put errors in just to show that this isn't a video. Yeah, if it was true, then the next thing we have to do is send a character. So let's do that. Oops. Once we've sent a character, that we can't do anything more on the channel. We have to close it. And then the other case, we have to send a string. So again, that choice we made, or that the value that we received, and this if then else is telling us what we have to do in each branch. So each branch of the if then else has a different type depending on the thing that arrives. And even though that thing's only going to arrive at runtime, we can reason about it at compile time. Yeah, question. Oh, that's a good question, and I was going to yeah, let's do that one. There are no uses of linear name Chan. So it says you said you were going to use it and you didn't. So was that what you meant by what could go wrong? Or do you mean what could go wrong in the world if I didn't close the channel? Sorry, I didn't catch that either. Oh, yeah. I mean, would you be able to do something arbitrary with the channel as long as the arbitrary thing you're doing is not insisting that the channel you're passing is linear. Now the things get a little bit complicated because if you pass a linear thing to a function that says I'm going to use this in an unrestricted way, that's not valid. So you'd have to be. So the type system wouldn't allow that. So I guess the short answer is it depends. I'm seeing hands going up. I'm just going to finish the talk at this point and just go on to the questions because I think you get the general idea. So yes, there was a question over here, I think.
So after you sent a string or a character, is the chan variable is being bound to the result of those two sends, right?
Right.
Is those closed chans? Are those the exact same type, and like you could move those closes like after the if, or are those like two separate types? Like, do you mean like close after string or close after char?
Let me try something. I don't think this is going to work. So what I could do is, I love it when I don't know what's going to happen. What I really want to happen here that probably won't work is that it returns me. So because both of these branches return a channel, that it will bind it to this chan prime. The reason I think it won't work is because they've gone through two different sequences to get there, and we'll have a different history. But let's find out. Yeah, it's not a very helpful error message, but the answer is no, you can't. So, yeah, you know what? That is a really interesting question, and I want the answer to that question to be yes, you can use the channel. And I'll forget that live coding music I was talking about. You have nerd sniped me. Yeah, thank you.
Yeah, are 0, 1 and unrestricted, are 0, 1 special, or can I say, this value can only be used exactly 7 times, for example, or other integers permissible? Or?
Yeah, so for the moment, yes, they are special. I don't think they have to be. So there's some work going on in graded monads, for example, by Dominic Orchard and his students at Kent, where they're kind of doing exactly that sort of thing. Can we have arbitrary numbers? There's some work going on the opposite coast of Scotland to me, so coast to coast, it's a whole like 40 miles away, where they're looking at more general ways of talking about quantities. So I can't quantify over quantities, for example. So I might want to say that something works for all quantities. Now, the reason I haven't done any of those things is because of a lovely concept by, I think due to Steve Klabnik, called the language strangeness budget, which is that when you add a new feature, or when you're inventing a new language, you have only a certain amount of weird things you can do before users will run off screaming. Now, there are some languages, like, for example, Haskell, where it's more threshold than a budget. Where, but I felt that if I was introducing something new in Idris 2, I should probably keep it fairly simple. But I really want to explore something much more general. That's a great question. I mean, 0 and 1 are, in fact, 0 alone. If we just have 0 and unrestricted, it's already really valuable. Yeah.
So I was going to take this offline, but because you just mentioned this work, I'm assuming it's Granule that you're talking about?
Granule, yes. Granule is the language I'm talking about, yes.
I wanted to ask about this, actually, because, like you said, graded modal types are like a generalization of quantities, but I have had a hard time wrapping my head around whether you're actually able to do things with graded modal types that are not possible in something like Idris 2. Is it just a matter of performance, or...?
I think maybe a matter of expressivity. So I could, for example, say that I can use a thing 5 times by having 5 arguments, each with quantity 1, and then a proof that they're all the same.
Yeah.
I don't want to write programs like that, but
Okay.
but it's possible that they are equally expressive.
Okay,
And
awesome, thank you.
I imagine you could write something that computes the type with a different number, and I don't know. That could be an exercise for the reader. Unary bit strings. Yeah.
The third use of dependent.
Yeah. Right. Yeah.
Awesome. Thank you, Edwin. This was great. Thank you so much.
Thank you very much.
It is now snack break time. So get your snacks, get your breaks, and we'll start back after break time with Michael Bernstein's The Hardest Problem in Computer Science. The answer is on the schedule. All right, we're starting in 5 minutes. Computer science will be marketed in 5 minutes. All right, 1 minute, everybody. 60 seconds. 1 minute till we start the next talk. Last 2 talks of the day. Come on down. All right. How's everyone doing? Yeah. Rowdy crowd today. Really glad. Everyone having fun so far? Conversation has been great. Causal connections being made, maybe casual connections. So one announcement again. We have the party tonight. There will be food. People have asked that to me. There will be food tonight. So do not worry. All right, so our next speaker, him and I have a long history together, been friends for many years. He gave the first ever Papers We Love talk in some year that I cannot remember. Has Michael's morphed as a musician, as a computer scientist, and now co-founding a company called Reify. I knew him as the paper reading person and the person who was doing all this like cool stuff in New York and technology, and now the real problem that we're dealing with is marketing. I come from different backgrounds. Selling your work, academics, they talk about this in academia a lot too. You got to sell your work. How do you make people understand really difficult things or really easy things? But Michael's been, it's his first talk in 4 years.
Yeah, the 4-ish.
Which is awesome.
4+.
And so I am glad to have you back, Michael, on the stage. Without further ado.
All right, thanks so much. Thanks, everyone. Can you all hear me okay? Yeah, we're doing good on the volume. Yeah, being loud enough has never been my problem, so I think we should be fine. It's really great to be here today. Thanks so much for having me. Like Zishan mentioned, it's been a little bit more than 4 years or something since I've given a talk like this, so if I'm a little bit rusty, I guess that's your problem. I'll do my best. But I really want to say that before I dive into the meat of this talk, that this has been really, this has been a really interesting experience so far. I'm going to talk about a little bit about, sort of like why I decided to pitch this talk to this conference, which might seem a little out of place, a little bit like different or left field than maybe what you were expecting. But I did have the experience sitting up in the balcony, heckling Edwin during his talk a little bit, that reminded me of like why we do this to begin with, in order to get exposure to things that we normally wouldn't get exposed to, in order to exchange germs and pheromones with other human beings in a constructive setting where we all feel safe and secure in the knowledge that we're here for like a similar purpose toward a similar end. And though what I'm about to talk about is really different from what everyone else is talking about, I hope that you will draw a line from wherever you're at, whatever your experiences are, whatever got you here, instead of thinking like, do less of that, and try to, draw that line. I'm really interested to hear how that works out. Okay, so let's jump in. The hardest problem in computer science, what do they say that, the two hardest problems in computer science, cache invalidation and naming things, and then the joke version, cache invalidation, naming things, and off by one errors. That's a good joke, right? We all like that joke. And we all know that saying, and we also all know that good talks, they start, I think, with good provocations, right? Things that get you thinking. And I like to front load mine, put it right on the title slide. And it says the hardest problem in computer science is marketing. And since I'm pretty good at marketing and, I've packed like kind of the whole point of the talk and everything you need to know right into the title slide, I think they're pretty good, but that was supposed to be a joke. But since I've got another 20-something minutes or so to go, I want to unpack it for you. And, if it is so hard, there's good news. I think I can help you with that. I think I can help us all get better at it and understand why we want to. But why am I here? I hinted at that in the beginning of my off-script portion of the talk, but I haven't given a talk in 4 years. This topic isn't as on topic as a lot of the other things were, but I was inspired by this phrase. The future of computing. This is the Future of Computing conference. I love the audacity of that. That's just great. That's what we're here for. That's what we're interested in. And we're all here. Okay, I'm on board, And, Causal Islands, I was going to make a casual islands joke, but it got taken yesterday, but you can laugh anyway. It's a great name. And this is good marketing, really. I mean, whoever wrote this or pushed this, you're doing a pretty good job. It's a good phrase, and that's a big part of what inspired me to look more into this, because I wasn't that familiar with a lot of these aspects of, Fission's areas of expertise and stuff. I've been learning a lot this week, but that's what got me here, that phrase. And then seeing the community pop up and form around the conference and seeing familiar faces involved, I got reminded of those early days in my career as a computologist, RubyConfs and Strange Loops and these conferences where you would go and you got to find something to do. You end up sitting in a talk. You have no idea what it is, and you learn a thing. Or you get exposed to something that you never thought you would. And that's why I'm here, surrounding myself with all of you beautiful people for the first time in so long, just to think about the future. And, I have some ideas about what the future of computing will look like, but only a few. And I'm going to wait till the end of the talk to talk about that, because there's some things I want to get into before that. And how I think I can help us get to the future. That's kind of what this talk is about. Because I think that the future of computing depends on good marketing. It doesn't depend on paid advertising and a lot of bullshit, but it depends on good marketing. And you're probably wondering, you said you're here because of the future of computing. What's futuristic about marketing? I think we need to be effective communicators if we want to usher in this future. And as I was watching Brooklyn's talk earlier, which I thought was really interesting, that's something that I was thinking a lot about. I was yeah, we need this. Yeah, we need this. But how are we going to communicate to anyone who's not in this room that we need it or why we need it? Because they don't know what a casual island is, and I guess they should. So that effective application, the application of effective communication in the context of selling products, or even in the context of academic or open source communities, that's just called marketing. That's all marketing is. So the more people like you who innovate and have big ideas, the more we get good at effectively communicating about those ideas, the sooner the future will come and the easier it will be for us to explain to people why they need these things that we've been spending all our time on. And like I said, serendipitously, I have a lot of experience with this. I've spent the last several years helping smart people like you with this exact problem. And so I figured that that's the best way that I can help, by giving you all as much of the foundational information as possible that you need to be able to effectively communicate about your big idea. So that's what I'm going to call this throughout this talk, your big idea. And that's going to be like a catch-all. If you're trying to sell your thing, if you're just trying to get people to use your thing, if you're just trying to explain your thing, it's your big idea, right? This is not all about crass commercialism and selling and turning software into products, though, of course, that's the end that a lot of this is used for. And if you can get good at marketing, you can get good at selling software. But if you can get good at effective communication, you can get good at explaining your ideas. And soon you'll find that other people will be doing the work for you. and that other people will come up with better explanations. And that's the power of community. That's why we want people to use our stuff to begin with. So what have I been doing the last 5 years or so? I haven't been out in public talking about it much. Basically, just to give a quick recap, in 2016, after several stints in technical and non-technical roles at startups, my partner Brian Dole and I started a company called Reify. It's a marketing consultancy for high-tech software companies. Since we've started, we've worked with over 100 companies. And we've gathered a lot of data, which is a fancy way of saying that we've tried our best to learn from our mistakes. And our idea was pretty simple. We had both met so many people with so many amazing big ideas during our roles in startups, but there was an issue. They weren't effective communicators. Often what was holding them back from getting help was something that I noticed that was like the insight for why we started this consultancy was that if you're a software founder or someone trying to get help with marketing, you hire a marketing agency and they don't know what the hell you're talking about. They don't know what a cloud is. They don't know, anything about the foundational elements of what you're talking about. So what happens is technical founders, technical people with big ideas, they hire marketers and they hate it because they burn themselves out trying to explain what they do to this very well-intentioned marketer who's probably quite good at their job. They just don't have a background in computer science. And so my partner and I had both been engineers, and we thought, let's go for it. Let's see if we can do what we've been doing at the companies that we've worked for as many different companies as we can. And I think it's worked out pretty well. And the way that we explain it is this. This is what people used to think. If you build it, it'll be awesome. And people will just start using it, and you put it on the internet, and you put a price on it, and that's how you get people to use things, right? Except not, because if you don't tell them about it, if you don't communicate effectively about it, they're not going to come. They're not going to try your product or your big idea. It won't go anywhere. And that's fine if that's what you want. I do all kinds of creative things. I write, I make music, sometimes I put it in a drawer, sometimes I try to share it, right? We should all be cool with that. There's nothing wrong with doing things for yourself. But I know how frustrating it can be to have a big idea that you're very convinced will make people's lives better in some way or solve some specific problem. And you know that what's getting in the way of adoption of that big idea is not the quality of the idea or the implementation of the idea. It's simply that you can't get anyone to listen. You don't know where to go. Who are you talking to, and what are you trying to tell them? These basic foundations are what this talk is all about. And so what has made our work so impactful at Reify is, since my partner and I were both engineers, we know what you do already, for the most part. You're going to have to explain some nuances of your domain, but the basic aspect of that is taken off the table, so you don't have to explain your idea and then go through this other process. That's where we come from. That's how I gathered all of the information that I'm presenting to you today by doing this over 100 times in the last 6 or 7 years. And so I'm going to try to teach you a compressed version of what we do with most of these clients that we work with in order to get them from where they're at, which is they have a big idea, to where they want to be, which is they're capable of communicating about that idea in an effective manner. Does anyone have any questions? Does everyone know what I mean by effective communication? Is that clear, or can we get some nods? It's yeah, you got it? Okay, so it's I tell you the thing, you're I get the thing, cool, and then you have a conversation about the thing. That's pretty much what I'm talking about. Easier said than done. So because it's important to give your consulting framework an important sounding name so that you can do important work for important clients, we call ours the value story framework marketing. It's called this because given that the hardest part about spreading your big idea is communicating about it, if we believe that's true, then the most important thing to communicate is the value of your idea. That's what it's all about. I was making like a V with my fingers for some reason, the value of your idea, but that's what it's all about. That's what you really want to communicate to someone, right? You want to get them hooked on like the why. Why does it matter to me? What have you done for me lately? Like, sure, I'll go download your thing, but like, why, right? And the most effective way to communicate is via a story. We tell stories all the time. That's what spreads ideas. That's what spreads products and everything else. Humans are extremely story-driven people. We like to know things in context in order to make decisions about them. And the best way to capture these complex foundational ideas is via a framework. So that's what it's called, but how does it work? So the way that it works is that to get from your big idea to this grail of effective communication, it happens in 3 steps. First, there's the why, where we document your big idea, its origin story, and the problem statement that it's meant to address. Then we move on to the who, which is given this big idea and the value of it, who is the initial audience that you're trying to communicate with? And we're going to talk a little bit more about how specific we need to be when we talk about who, because we can't just say people that use computers or software engineers or even really back-end engineers or front-end engineers. These terms used to mean more specific things. Now they're much more general. And so we're going to talk a little bit about that level of specificity. And then we're going to move on from the who to the how. So that this how, the last part, is what most people think about when they think about marketing and advertising. They think about like, I'm in an episode of Mad Men and I'm like drinking vodka and like saying inappropriate things and we're just like shooting cool ideas back and forth and like, bam, that's how Think Different happened or whatever. But it's not like that. I wish it was, but it's really not. And so throughout, like I said, I might call your big idea your product accidentally, but know that what I mean is I know you all have cool ideas that you want other people to know more about, and that's the thing that I'm talking about, whether you're trying to sell it or not. And so another thing to note just about these stages is that all 3 have inputs and outputs, and I'm going to show you like roughly what they are on the slides, and that's why this text is so poorly aligned on this slide. The inputs are going to be data or things you're gonna write down basically, and the outputs are just going to be refined versions of those inputs. But we're going to talk about what you need to know and what you can expect to happen because you did that stage. So let's start with the why. Your story. The input is a questionnaire, basically, that you'll fill out about your backstory, how you arrived at your big idea, what you've learned about it so far, your problem statement, and more. And the output will be just documentation of that for the first stage. Sit down. We have a questionnaire. You can download it on our blog. You fill it out. It's going to ask you all kinds of questions that you may or may not have asked yourself about your big idea. And it will give you probably some pause about how well refined this idea is. We all know the very important role that documentation plays in conveying the intent of software. So similarly, we should take an approach to documenting the idea itself. And that's really what this first stage is all about. So we start with you, how you got there. And the big question we're trying to establish, the baseline, is essentially like, why you? What makes you uniquely suited to address the problem you're addressing? And this is the important thing. What is the problem? What are you helping people with? What is this thing intended to accomplish? What did you notice that needed changing in the world? What rabbit did you chase? What hole did you chase them down? Toward what end? How lost did you get? Write it all down. We start with you because if you don't have an authentic connection to this big idea, you will not be able to effectively communicate about it. And this is because effective communication relies on authenticity, especially when it comes to new ideas that you're trying to expose people to. Because we've all heard things that sound too good to be true because they are. And that doesn't happen when you're real with your problem statement and all of these other things. So, and an interesting thing happens when we do this client work with companies and there's like multiple founders, multiple people involved. We ask them all to do this documentation on their own, and then we come back and compare them, their results. And we do that for each of the 3 stages, for the documentation component, for the story, for the persona, which is the next stage, and for messaging. We ask the group to do their homework on their own, and then we come back and we discuss. And this amazing thing happens where, believe it or not, sometimes 2 executives at a software company think they're doing 2 completely different things. And it's a really good idea to get that out of the way, like early on in this engagement that we do with them, where we're telling them, you're going to pay us money to help you come up with all of these words that you're going to use to communicate to your potential audience. And y'all are working at cross purposes right now, and you need to solve that problem before we can move on. Because if you're not on the same page about this problem, you're not going to be on the same page about the next part, which is really important, and that's your ideal audience. And so in order to figure out who your ideal audience is, who your target persona is, you're going to fill out a list of questions from the point of view of the ideal user of this big idea. And the output you're going to get is a refined persona profile, basically like a 1-pager that anyone should be able to look at and get a good idea of who you're trying to communicate with. And now that we've gotten that problem statement written down, we can move on to these people, right? The target persona. And we use different questionnaires with different folks who are trying to sell different things, but basically, I'm going to show you some examples in the next slide, but I just want to address one thing, which is that in the course of your own work, you may have experienced this idea before of like a persona or ideal customer profile or something like that. Raise your hand if you've ever tried to do something like that before. Okay, good. A lot of you. That's great. And sometimes they're good, and sometimes they're really dumb, right? Like Jane, the Java programmer, lives in Berkeley. She takes Bart to work, and she orders her matcha oat latte at Starbucks. Okay, like that's awesome. What does that have to do with your software, right? And if that doesn't matter, then what does matter, I guess, is a good question. And it's really straightforward. You just need to focus on the problems that they're facing that your big idea is intended to help with. And the problems they face, they should align with that problem you're solving, right? And if you're talking about, front-end TypeScript developers who work on heavily regulated products, as an example. That's like a pretty good, right? We have like front end. We know we're writing a TypeScript thing for some reason, and then maybe it's some security related thing. So like only people who are in tightly regulated industries would care about that. Can we all see how like that's a much better definition of our profile than front end developer, right? Or Jane, the Java programmer, or whomever that is. We're not selling commercial we're not selling consumer products, right? I'm going to talk about that a little bit later. Like, it's not a can of Coke. It's not a can of Coke. You're not going to get someone to just like buy your thing off of 3 words. You know, like there's no one who's super in the desert. You know, they need a beverage so bad, and you need a good tagline to get them to choose your beverage over the other. That's like much more complicated. And so that's the whole reason you're pursuing this big idea to begin with. Is to solve a specific problem for a specific type of person, and that's who we're trying to find the audience for. Yeah, and we're just trying to find who they are, trying to find where we can find them, and who faces that problem. And like I said, along the way, we document other essential characteristics of this abstract individual. Here are some good questions. What type of company do they work for? Like what industry do they work for? Like what industry? How many employees does that company have? Do they work in a specific industry vertical? Those are like firmographic questions about the firm they work for. The type of firm they work for. Then there's demographic questions. Do they need a certain level of experience to get value out of your big idea? What are the biggest problems that they face? Right? Maybe in this TypeScript, whatever example, it's encryption is super hard, and this makes it easy as an example. Right? And what type of tools do they use? And skills do they have? And the tools that they use is really interesting. It gets glossed over. It's an important thing to think about. If you want people to use your stuff, you have to know what other stuff they use, right? Because it might not be compatible with their stuff, right? And people are not quick to drop their own stuff and use yours. Right? It's not easy to get people to do that. And so you have to be quite persuasive in order to get anyone to care at all what's below the fold on your marketing website. Right? And so you got to take this seriously. We don't just want VPs of engineering and mid-sized companies. We don't want something that can be reduced to a LinkedIn search or some other targeted search on a paid social platform. Not going to work. You have to get the foundations correct. And here's another thing that we use. It's hard to overstate how so many people get this crucial stage of understanding how to communicate about their big idea. You can't overstate it. People are building things right now with massive funding, and they have no idea about any of this stuff, right? And so here's a rubric. You can use it to help you figure out who you want to talk to. Like, is a good use of this rubric? So maybe you're not sure. Do we want to try to communicate with the person who's going to buy this software, or the person who's going to use the software? Do we need to talk to the manager that manages the people who manages the software, etc. You fill out this rubric, and you should be really confident about most of these questions. I know what problem we're solving. We have a unique value targeting this persona will represent a sizable enough addressable market. Sorry for some marketing jargon in there. Targeting this persona is compatible with our go-to-market strategy, like we distribute our software to begin with, and we can communicate authentically with this persona, and we know how to find this persona, and we can reach prominent examples. And this last one is hugely important. Where are they? This is getting harder to answer. Right? It used to be Twitter. Was so good. You could hit anyone on there. And we can't rely on that. We can't rely on that platform anymore. I'm not even on there. I don't even think Jen. So what are you even on there? What are you even on there for? Right? What's that? Scoots. Yeah. All right. Blue sky. Fascinating. Somewhat out of scope, but you understand the idea. It's not there yet. It's not there yet. That would not be the answer to the question. If you asked me 8 years ago, how do you get every nerd to know about your thing? Tweet about it. Right? It's a lot harder. Right? It's a lot harder now.
For a lot of reasons.
Okay. That's a pretty good amount of stuff about the
right. So we started with the why.
Right. So we started with the why.
And then we moved on to the
and then we
who.
moved
And I
on
just
to
wanna
the who.
be
And I just
clear.
want to be clear.
You can go and
You can
do
go
this
and
for yourself.
and do
That's
this
what
for
this
yourself.
whole
That's
thing
what
is
this
about.
whole
I have
thing
all
is
of the
about.
materials.
I have all of the
for
materials
all of these
for
questionnaires.
all of these
Everything is on our
questionnaires.
website.
Everything is on our website.
Go do it for yourself.
Go do it for yourself.
Please.
Please.
Tell me that you did it and that it was awesome, or that it was awesome, or that you hated it and you didn't understand it.
This is not about getting
This
you
is
to
not
like
about
hire
getting you
me
to
to hire me to help you with this. This is about getting you to do this for yourself. Okay.
I don't want to help all.
I don't want to help all.
enough time.
I don't have enough time.
Okay, I'm getting old.
Okay, I'm getting old.
You know, I don't want to be on my
computer for the rest of my life.
You know, so y'all are gonna have to get good at this because I need a break. Because I need a break.
Okay.
So let's move on.
So now
we're
gonna move on to messaging. And the inputs are a list
these things that we call
supporting examples, which I'll talk to you about in a little while, and the output is a messaging framework. And that framework will contain all of the words necessary to effectively communicate about your big idea.
Pretty cool,
right?
Pretty cool.
And
this last part
is
what
what
most people
probably think about
when they think about marketing.
When they think about
playing Mad Men, like
I talked about earlier. And it's the most fun part. Because
it's all about getting
a stranger oriented to your big idea
in the smallest amount of time possible.
That's a great challenge.
That's a great challenge.
Right? All we want is for someone to want to know more. Okay, with a big technical idea, can't communicate the whole thing all at once.
So you have to start
small.
And this is an example.
Of a messaging framework.
It's fictional.
And actually, this is something that I wrote as a joke
like 5 years ago.
But it was unintentionally prophetic.
Because you can basically do this now.
This is my token mention of LLMs in this talk.
Apparently mandatory.
This is for a fictional
product called Whisper Code, and the idea was you would whisper to your computer what you wanted it to do, and it would write all of your code for you.
Which is so fucked up that you can actually do this now.
Anyway,
and so believe it or not,
the
end product of all of this work,
documenting your story,
doing your persona work,
being super certain,
filling out rubrics,
doing this messaging step.
It all boils down to this.
It's not a lot.
This is very little.
Right?
Everything you've worked on, all of the history, all of the sweat and blood, it can be boiled down to this few words. And what's interesting here is what's not on this page. Because you will always have way more to say than what's here. But you're not allowed to have more than what's here.
This is what you're limited to.
And as someone with a big idea,
who isn't necessarily
ruthlessly adept at ruthlessly cutting words,
frighten you a little bit.
As a recovering poet and marketer,
this delights.
There's nothing better
to me than just crossing out
all of your extra words.
You're just shut up.
No.
Too much.
Shut up. Right?
Too much.
You don't need more than this.
Okay? You don't need more than this.
Let's talk about it a little bit. So the top. This is the thing. What most people think about. A tagline.
They need a tagline.
Right. We're going to talk about that.
So this one is.
Never write a line of code again.
Right. And if you're me,
you'd be like,
like me, you'd be like, yeah.
Tell me more. I want to know how.
I want to know how.
Okay. And so that's what the brand promise is all about. The thing at the top of this framework.
It's actually the part that you write last.
Okay, that's a big inversion
that most people don't get.
You don't sit around
trying to come up with some
sounding tagline
and then
fill in the rest.
It does not work that way.
You start
at the bottom
of this framework.
Which is which is a big list of stuff you already know about your big idea. That's what these supporting examples are. They're examples that support the claims that are made in this framework. So in this framework, I'm telling you that this product called Whisper Code is three things. It's fast. It's easy. And it's secure. And so if I said to you, Whisper Code is fast, and you said to me, well, what's the value of that to me? And I have my smart ass way of saying, well, no code is faster than Whisper Code. Meaning, this is the fastest possible way that you could get your code written. And I'm like, really? Like that? Are you sure? Like, can you back that claim up? And those are the supporting examples. So programs used to take hours. Now they take seconds. If your program isn't perfect, simply ask us for another one. It will probably be better. No more thinking about whether or not you can or even should. It's that fast. So these are just me coming up with stupid ways to try to support the claims fast. And hopefully this illustrates to you at least a little bit about how this framework works. The idea is that you're taking all of the values that you have and you're writing them all down. So you're going to get together. Do it separately, like I mentioned, with you and the other folks involved in your big idea, and you're going to write down as many supporting examples as you can. These are things that are going to get people interested in, wanting to know more, all of the cool things about your big idea, right? Like, I could write down like 100 of these about the fission work that Brooklyn presented this morning, right? There was so many benefits, right? And this is not to criticize that talk in the context of a highly technical conference. That was just the correct, right amount of detail for this context. But if you were to try to extract just like something like this from all of that big pictures work that was presented, you will start to see the challenge that people have when they're attempting to effectively communicate about their big idea. What do you talk about first? There's so many cool things to talk about, right? And we can do all these things anonymously, decentralized. You know, I know who I'm trusting. I know who I'm not trusting. You know, is it about that? Is it about scalability? Is it about getting the 50 million people in the circle who don't have access to the internet? Like, where do we start? It can be confounding because it's so much easier to build software and pile on your big ideas than it is to take a step back and do this work to make sure that you're communicating about what really matters. And so what happens is we ask people to make these big lists of these supporting examples, and we refine them with them. We look at them. Here's a pretty interesting graphic that I made a while ago to try to like visualize the whole process. So it's about personas and messaging, but this middle part is basically about how we take all of these supporting examples, and if you had like 3 or 4 people who are on the big idea, and they each come up with 50 examples, even in those cases where people are, you know, working toward cross purposes, and maybe like it seems like they're divergent, like most of the time they'll still come up with mostly all of the same supporting examples, and there'll be some differences, and it's great. We sit down, we talk about them, and what we do is we do a kill, keep, combine on them, which means we cross out ones we know we don't like, we circle ones we know we think we like, and we combine like ones, and we iteratively do that until we have a sort of, you know, canonical list. And then we look at that list and we look for patterns in that list, right? That's where fast and easy and secure came from, because the maybe 50 examples that preceded this framework, maybe there's like 20 of them that were about how fast it was, and 15 of them about how easy it was, and 10 of them about how secure it was, and 8 of them about how something else it was, right? So basically, like, you're going to come up with 5 or 6 categories. but you can only choose 3. So you need to make sure that those 3 work together and tell as much of the story as possible to communicate the essential value just to that one specific audience that you're trying to communicate with. And you don't get 4. There's never 4 columns. There's never 4 supporting examples or 5 or 2. There's always 3 groups of 3. Don't ask me why. Okay? But this has we have never compromised this once. I've literally done this 100 times, and every single framework we've produced has been 3 groups of 3. You don't need more. Yeah, but like, do I need more? No. No. Whoever you are, no. I'm telling you. No, you don't. No, 3 groups of 3. Here's another way of saying it. If you only had 9 things to say about your big idea, those are the 9 supporting examples that end up on your framework. And ones that don't fit into the categorization don't belong there. Right? There is a lot of value in creative constraint in these types of situations where effective communication is the goal. Say less. I should take that advice. And so from this refinement, that's how you get from a big list to a smaller list, categorized lists, etc. And that's how you get from a big mess to something like this that's really concise, by being really hard on yourself and by not letting yourself exceed these constraints. And it is hard, but it's easier than you think, and it's a lot easier when you have a framework to do it with. And that's why I really felt like this is something that I could hopefully get some of you to be more interested in to do for yourselves. I can't teach you everything in this short period of time. Good. All right. So the only other aspect of the framework is essentially like you move up, you do the supporting examples, you do the headline benefits, which are the benefit statements for those. You write an elevator pitch. I don't want to dig too much into it. You can check this out on your own later. I hope that you will. But the elevator pitch is really just comes from the stuff below it on the framework, and I'm going to show you a better application of that in a second. And I just wanted to highlight something like how you come up with your good brand promise is really difficult. I mean, it's really challenging. I'm not going to make it sound like it's something that's going to come to you easily. I wanted to show you these 2 examples to compare and contrast. On the left, you have a consumer product, which is a high-end luxury watch, Patek Philippe, like the greatest watchmaker of all time. And they have an amazing tagline. It says, begin your own tradition, right? On the upper left? Yeah, begin your own tradition. And then this tagline is just the greatest. You never actually own a Patek Philippe. You merely look after it for the next generation. What? That's like a once in a lifetime. This guy got like a fat gold watch for writing that. That's just like, what? But you see that like everyone gets that, right? And like anyone would understand, I think, what that means. That kind of message does not work for selling your serverless database, right? Okay, so we're like, we don't get to have as much fun as someone who's marketing like, high-end watches and, horological expertise, but, PlanetScale is the world's most advanced serverless MySQL platform. That's really good, okay? I didn't write that. I helped write it, but I didn't write it all on my own. But someone else came up with this, so I'm giving someone else credit. That's really good. You get exactly, you're like, okay, I want to know more about that. Advanced, serverless, MySQL platform. Like, okay, I get it. I'm probably going to want to try more. or learn more, or get started, or whatever the button says. Okay, I need some water. I've given you a fast-paced introduction so far for how we get from your big idea to how to communicate about it effectively. We started with the problem, we moved to the audience, talked about value propositions and brand promises and the messaging framework. And how do you use it, though, is an interesting question that we get a lot. Like, now what? How do we apply this? Because it's not the beginning. I mean, it's not the end. When you make your framework, it's the beginning, right? Like, you have this framework. Now you can go talk about it, okay? That you didn't do anything yet except, the work for yourself. You haven't tested any of this yet. You haven't outwardly communicated. You're not communicating until you're talking about it or putting it out in public for someone else to see. And so the first thing that we do is we take their framework and we turn it into a landing page with them, right? So this is a Google Doc wireframe fake web page that you can look at and see, right, where all of this stuff came from. The H1 is the brand promise. The 3 sections below the fold, there's one for each pillar. The H3 that titles each of those sections is just the headline benefit for that pillar. The text underneath those, the text boxes underneath each of those are the supporting examples that back up that headline benefit. And believe it or not, straight up copying your framework into a format like this is an excellent way to get your first prototype expression of this big idea communication thing out there. That's pretty much all you have to do, right? I mean, you need to add things like buttons, and I don't think this works as a web page. Like, I think there's, coding to do to turn it into an actual web page, you know what I mean? But that's the easy part, right? And so this is where we end with most of our clients that we do the foundations work with. We go through that whole process with them. We create the messaging framework. We get feedback. We turn it into a web page. They ship it, and then they're on their way, right? We used to just hand off the framework and suggest that they use that to make a landing page, but we don't do that anymore because they just didn't do that. So now you can only hire us to do your messaging framework work if you are going to ship this landing page, right? So we give you you need to be like, okay, I want that too. And still a lot of people don't ship them, believe it or not, but we're getting better. It's hard. Shipping web pages is very challenging. I would never want to have to do that. And what's great about this site, you get your artifact, right? You get your link. You get your ability to share. And that's the important concrete output, I think, of all of this work. So we started with the problem statement, defined our persona, came up with our messaging, and shipped a web page in 46 minutes. Not bad. And so back to the future for a second. What do I think it's going to look like? I'm not sure that you really care, but I do think that it's going to be, I mean, I wrote this before I heard any of these other talks, and I think a lot of us are on the same page, that the future in computing is going to be in doing it yourself, moving away from the big platforms, conceiving, creating, and publishing for yourselves, and going back to the roots of the web. The future should be decentralized, offline, and hopefully as in-person as possible. But how do we get there? And that was the idea, by empowering people like you in this room right now and viewing the video in the future, hello future, to build this for yourselves. And what about the future of distribution that I talked about? The Twitter problem, like they say first-time founders focus on product and second-time founders focus on distribution. And that tells you distribution is more important than product, essentially. How people find out about your big idea is one of the big aspects of the persona that we talked about earlier. Like, if you don't know where you can reach these people, then do you really know the audience? And as to the future of it, I don't know. I'm unclear. I know that it's very important to figure out. I hope someone in this room is involved in helping figure that out. And is the future as decentralized, offline, and user-owned as we hope it will be? Then if so, we have the opportunity to build things more on our own terms, right? But not only that, in that world where we all own, and we're in control, being able to authentically communicate about the value of your big idea in that context is even more important. It will be even more challenging in a lot of ways. It'll be harder to cut through. And so that's why this matters even more. And the big idea is, don't need consultants like me, right? The future will be awesome when all of us take responsibility to the same extent for our communication as we do to the technical level of whatever that we're all striving for. And on that incredibly weak sentence, that's all I have for you. So thanks so much. Thanks you all for having me, and all the other speakers. Like I mentioned, you can go to our website and find a lot of this information. I'm happy to answer any questions if anyone has any. I'm also, one second, I think I'm also the only marketing consultant that also has an acknowledgement in the first or second edition of the type-driven development book that Edwin wrote a couple years ago. So I'm going to just go ahead and say that's probably true. Okay, yeah.
I think distribution is a really interesting question. I think we have a wave of change that we're in the middle of and coming towards, and I think just hand waving over that distribution, there's a whole talk there that we have to have, right? Where there's a whole tech war of okay, we're going to point LLMs at marketing copy, and cold outreach, and we're going to create a custom landing page for every customer.
All of this puts so much money in my pocket. I love it. It's great. I'm joking. Yeah. So, and comment on that is what you're saying, or
what
is it,
do?
What do? So okay. So I did hand wave over it a little bit, but I will back up and say that it's not all that mysterious for a lot of people. Right? A lot of times you do know where you can find some of these folks, whether or not you want to approach them on that level. If you're not writing some language specific tooling, go to PyCon anyway, right? Go to any, the idea is to find as many of the people as you can in the places where you know where they're at, but it doesn't answer that specific question.
I'll give it more nuance. Is this the return of in-person? Are we going to sell 10 lobby booths at the 1,000-person Causal Islands next year? That's not a real thing, but imagine that there's an alternate version, the Casual Islands version.
Right, that's more like a 3-year goal maybe. But I don't know. I mean, I was having a conversation with my friend David earlier, who was like, I didn't expect this kind of thing to come back. And I was like, I knew this was going to come back because I don't know really why, but it just is an essential aspect of the human experience. I think that people just really like being in a room with other people, and I'm kind of old, so maybe that's not true for people that are, half my age. Maybe some of you in here might think completely differently about that, but I just don't see it going away. Do I think it's going to go back to pre-pandemic crazy levels right away? No. But does it need to? No. And another thing is that this conference itself is sort of an interesting thing. It's a paradigm shift from 5 or 6 years ago. You see a lot more of these conferences that are sponsored by individual companies that are about their niche. And, whether or not that's effective for Fission's purposes is sort of an interesting question on its own, But I'm bullish on these kinds of things. I don't think they're going away. I think I would be sad for all the kids that never got to experience what I experienced, which is learning about something that you didn't think that you cared about. I mean, that's like the whole thing about knowledge, right? It's like you want to learn about a thing you didn't know you wanted to know about. So, Hi.
Hello.
Hi.
I'm curious if you would recommend any like modifications or something like that for people who might not know exactly what it is they're doing yet. Because like specifically, like there's questions like, who are we building this for, right?
Mm-hmm.
Like, I think a lot of places here are doing some really like fundamental research where it's like kind of even a question mark, is it even possible to do the thing we're trying to do? And obviously the answer is, well, don't sell it until you know the answer, right?
Sure.
But like, is there a bridge between like, let's make a marketing website and we're still figuring out all these other pieces?
Absolutely. Yes. Great question. I think that something that I didn't mention explicitly is that this whole thing is like, you're ready to do all of this when you have a pretty clear idea of at least the problem statement, right? And like I hope this comes across. I'm 100% for exploratory research. I want everyone to do the cool thing that you want to do. It's awesome, and you and your homies think it's dope, and that's great. But that's just a different scenario than trying to get other people to use it, right? So I think that writing down your problem statement and thinking about the people should be a clarifying exercise for you early on in your research. And there's a great, there was an earlier version of this talk where I talked a lot more about like the differences between academia and industry. And I was like talking about like this and that. And I was like, but that doesn't matter because we all need help with the same thing anyway, And I like to think about like the Matt-Mite diagram, the PhD thing, where like, that's the idea. Like, has everyone seen that thing? It's a really cool graphic. And if you look up Matt-Mite,
We'll share it on the
PhD.
Discord.
Yeah. And anyway, it illustrates the idea that when you're doing academic research, all you really need to do is like push the tip of the spear out like ever so slightly, right? And it's got this great visualization of that. And when you're in that stage, that's not like, in some ways, academia is like overfits for who. Right. And they're so focused in on this like tiny thing that it's like no one has that problem. Right. Or they are able to solve it to some specific end, but think, well, but on the other hand, this is not tractable in any scale. We're just proving that this theoretically works. I love that stuff. That's really obviously essential and foundational. It's just a little bit early on for this kind of thing. So hopefully that helps.
Hey, thanks for the talk.
Sure.
I was going to ask if we could do 3 groups of 4. No, I have an actual question.
That was a good joke.
I know what the answer is. I think it's really useful having this framework, and I've like written a bunch of notes about it because it's just great to be told like in simple dumb steps, like you just do this and you do this, and like, but the one bit that feels light in that is, and you kind of alluded to it at various moments, is that like channels, like making a website still doesn't solve the problem of no one's coming. So is that part of this, or is that sort of like a whole separate process?
It's sort of that's after this, right? So the idea is that we have a saying in marketing, like we don't like to create leaky funnels, right? So the funnel concept is like, this many people come to your website, this many people read more than 3 seconds of it, this many people click a button, this many people sign up, and then this many people, which is like 0.0001% of all visitors actually like do the thing that you wanted them to do. So we don't want a leaky funnel, meaning We don't want to draw a bunch of attention to our idea and send people to some website that sucks and doesn't communicate what we're trying to communicate, because they're never going to give you a second chance. Okay? They are let me repeat that. They are not going to give you a second chance. They're just not. It just doesn't happen. You know, they might see you again like 2 years later and be like, you know, but it's tough, you know, so you usually have one shot, and that's why we want you to have the right words in place before you start thinking about how you're going to get all the people there to begin with. So it's sort of a separate thing. But I would start small. Start with your community. Start with your Discord. Start with your user group. Start with where you know you have at least 5, 10 people that you can communicate with this thing about effectively, and then move on from there.
Thank you, Michael.
All right, thanks everyone.
Thank you. All right, one announcement before the last talk. If you're outside, you should come in for the last talk. But the restaurant is closed. So some people have their stuff in there. It's at the registration table. So if you're like, where's my stuff? It's at the registration table. Okay. Do we have up Jen's slide? Yeah, period in blue. So this next speaker, actually, this happened really early in the process for the program committee, which was, you know, talking to Boris, like, you know, to Michael's point, the future of computing, and like, what does that mean? And the first thing I thought was, you know, I love Jen Schiffer's talks for forever. She hasn't given a talk in like 4 years, so this is super, super dope as well. But I was like, future of computing. I want to hear Jen Schiffer's take on the future of computing. And so I was like, that's what I want. And then I emailed her, and she was like, yeah, okay. Huge mistake. Jen is the director of community at Glitch, and now Fastly. Has done great talks in the past. I highly recommend people go through everything and watch videos. She's an amazing speaker, amazing person, and I'm really excited for this one. So Condemned to Compute. Exciting.
Hello, everyone. So first of all, I want to give a huge shout out to my fellow speakers. Can we give a round of applause to everyone that's gone on so far? Everyone's going to go on tomorrow. It's been really super inspiring and also validating, but they put things into better words than I could have. So thank you for that. Also, I want to thank the organizers, the venue staff, everyone who's in here, everyone who's on the live stream. Thank you. Great. It's very nice to be here in Toronto. As Ishan said, I've not spoken in 4 years. I'll talk a little bit about that. I love Toronto. It's one of my favorite places to visit. You're in the correct time zone. Like New Jersey, where I come from, I live in Jersey City, which is a cool little peninsula across the Hudson River from the World Trade Center. Another cool thing is between Toronto and New Jersey is we both have a medieval times. Here I am at yours several years ago. This is my pal Gianni and your king. Toronto has a king, right? Like, we paid a lot of money to take a photo with your king. So as Ishan mentioned, I'm here to give my take on the future of computing, which feels like none of my damn business. I've never really had like the drive to predict or plan for the future. So this is all very much like out of my comfort zone, but I'm trying to like get back to my old hobbies after the last few years. And one of those hobbies is not minding my damn business. So it's also not really too much of a stretch for me to lecture on this topic. I started my computing studies almost exactly 20 years ago. I entered the industry almost 10 years ago. I've, without the use of LLMs, accidentally convinced an uncomfortable number of JavaScript developers that I coined the phrase "life is a highway." And I am also pretty confident I could have gotten away with Theranos. So I embody the present of computing. And the present, if you think about it, is just the future of the past. Also, who is even good at predicting the future? You know, when Elizabeth Holmes' fraud came to light, I think a lot of us thought well, lesson learned, no one's ever gonna pull such a wild scam in the tech industry ever again. But we keep being wrong. History keeps repeating itself, and not even in new, exciting, evolved ways. So considering that, and also thinking about how trend cycles work in art and fashion, technically all I really need to do to predict the future is to take the past and repeat it. And that's my methodology today. Unfortunately, history has always been my worst subject in high school, college. But to be fair, I mean, the history they were teaching was incorrect and whitewashed and painfully boring. And fortunately, now we have AI. But I didn't use AI for this talk, not because I believe in some kind of purity of doing hard, tedious, bespoke work, because working kind of sucks, unless you're my coworkers or manager who's watching the live stream right now. I love working. My favorite. The reason why I didn't use AI was because ChatGPT doesn't even know Elon Musk bought Twitter, so it was really helpful in what I was trying to do. So what I ended up doing was logging events from every year over the last 2 decades from onthisday.com, which is absolutely riddled with ads. No exaggeration. Every year I downloaded over a dozen megabytes of ads that were mostly for Hidden Valley Ranch dressing, which I don't eat, I'm plant-based. Those ads kept refreshing, so that number of megabytes kept going up and up the longer I took to go through the page. And it was lazy loading, so every year was a 15-minute process. I popped all of those historical moments into a spreadsheet, the True Gentle Person software, and I did a select all and drag fill, which in theory should have not only incremented the year's headers, but it also should have just predicted the future, right? It seems like something AI should be able to do, but Google Sheets just repeated the last 20 years to the next 20, which started the Iraqi war, and it relaunched Facebook, and I did not want to do either of those things. Again, you think that with all the data in the world, Google would have implemented that feature. Maybe Web3 can fix this. So on the rare occasion that spreadsheets fail me, I turn to WikiHow. This is the website that knows WikiHow to do everything, allegedly. It suggested I consult an oracle. I might have chosen the wrong one, because in response to what's the future of computing, their result dates back to 2008, where their prediction was that cloud computing wouldn't kill relational databases or render most of the DBA jobs obsolete. And they were right, but that wasn't really exactly what I was looking for. It turns out you can't always have machines do all the work for you all of the time, so I leaned in Sheryl Sandberg style into that purity of doing hard, tedious, bespoke work that I was avoiding. And so what I'm going to do now is drag all of you gently along with me through that work. We're going to skim through the last 20 years of history and go over what I see from the next 20 years, given how bad we've been at not repeating the bad parts. By the way, hello. My name is Jen Schiffer. I'm the Director of Community at Fastly, and I've been managing the friendliest community of coders building the web using glitch.com for over 6 years now. Not unlike Google Sheets, I do not have an innate paranormal ability to predict the future of computing, but I am a classically trained computer scientist with no fewer than 500 megabytes of ad tracking cookies downloading onto my machine, so let's rock. So we're going to start with 2003 to 2007. The NASDAQ composite at this point was climbing out of its low from that dot-com bubble burst. The computing industry started to see a lot of disruption and growth rebuilding over those next 5 years. And I saw a lot of disruption and growth personally. I had started college to study computer science against a lot of odds. Like at that point, I had spent the latter half of my high school senior year sleeping at motels, crashing on friends' couches. I worked many weird jobs. I was peeling a lot of frozen shrimp at an Outback steakhouse. I was disassembling blood surgical kits for a biomedical company, selling used books. I was doing a lot of weird stuff to get by, and I was one of the few women in my computer science class and really didn't have like a support system. And at times I didn't really even have a home. So things were really fucking hard, but what was going on in the tech industry during these years at that time made me feel really hopeful that all that hard work that I was doing and like surviving through was a worthy investment. And I was kind of right. During these years, there was explosive growth in both software and hardware that enabled the things that I loved most about using computers, which was socializing, collaboration, entertainment, creating art. During this time, B2 was forked to create WordPress, which really got me more into building for the web for fun, while my studies had me trapped in the Java virtual machine. Social media platforms like Facebook and MySpace connected me to my peers in a time that I like really needed it the most. And the cloud was becoming interesting and accessible to developers with AWS launching S3 and EC2, as well as other hosting and web building services coming out, which were more sophisticated and I guess like work friendly than GeoCities that a lot of folks my age at the time had kind of grown up with. And while I imagine that many of you would think that the most impactful invention during this block of time was the iPhone, I think my fellow Galaxy brains in the room would say that the true gift that tech gave to us was Yahoo Pipes. Shouts out. So for those of you not familiar, Yahoo Pipes, I think, was a timeless example of how powerful and interactive web-based interfaces could be, even back then in the early 2000s. It let you visually mash up data across websites and services, which is really like super helpful at the time when all these new content platforms were coming out. I'm only like half trolling, and that's generous, when I say that Yahoo Pipes walked so the decentralized web could run. And that takes me to my prediction, which is that the cloud, as this like big corporate-owned monolith, is going to dissipate into like tiny little baby clouds run by communities and normal people. So several months ago, the creator of Rails, DHH, he blogged about moving his company off of the cloud and onto their own servers. Like, I guess the cloud wouldn't stop talking about human rights at work. And not that I like to give any validating attention to Mr. David Hamburger Helper when he does these like, I'm the underdog, big companies are bad performances. There's a reason why companies and people flocked to renting computers, because his thing is like, it's so expensive, why did we do this? The reason why we did that is because many of us are not able to run our own servers to even begin with. So like, congrats to the rich who can, buy their own data centers today. Like, it is cheaper. And also like, owning a home over renting a place, owning servers to run your web apps over renting computers is a great investment. Like, buying the hardware now, it's expected to kind of be a cash cow for those who are able to do that. So we're gonna see that a lot more. But again, it's like not accessible to most people. So we have to like work towards popularizing like local hosting, community governed mesh networks. I want to give a shout out to Mob's talk at this event about local first software, the Agrigore browser. It's an absolute must watch. If you didn't catch it, or if you're watching the video in the future, check it out. I get shy at Q&A parts of talks because I like end up on stage and I get to talk so much. So a question I wanted to raise my hand about, Mob, if you're here, is more like a challenge I think we all face, is like, how can we make mesh networks interesting and convenient enough for non-technical users? Like, there's gotta be some essential app, but also with onboarding that's not just easy, but like actually delightful. I think like, what I've been watching over the past couple of days is, I've been on Mastodon for a while, and Michael's right, I don't tweet anymore, but I'm seeing a lot of people getting invites to Blue Sky, and I'm seeing people who are non-technical, like the shit posters that I also follow on Twitter, moving to Blue Skies, and I fear that the community there is going to become just Twitter 2.0, like the bad practices and relationships and the way that we are not really nice to each other ourselves on there are going to keep happening there, but everyone's joining because it's a much more delightful experience to onboard than it was to Mastodon. So I don't really have like a solution to that, but it's like a challenge I want to put out to everyone in here that is advocating for and building these solutions. It's really important, but we have to make onboarding like really delightful, not just easy, delightful. I think a lot about like the WordPress model where if you want the convenience of not hosting, you can use WordPress.com and you pay and they host and whatever. But if you want to run it yourself, you can download from WordPress.org and you still get like a pretty good community guided experience. And then like other hosting companies will have that delightful one-click install. So you can like blog on the cloud or you can blog for your own server. So I just want to kind of like put that out into the world and manifest it. But we have to move towards that community-run software. So yeah, you can blog on the cloud, or you can blog your own server. But then, like, what about all the other kinds of content creation that saw its rise in the past 20 years, like the launches of YouTube and Facebook? I think that decentralization of content creation, and I'm going to talk about content creators a lot here. Every single one of us in this room is probably a content creator. Like, I think we sometimes think of like influencers, which, you know, me being on stage here talking to you, I am an influencer. If you were out in the lobby as an attendee and you have a lanyard on your neck that says that you can take photos, you are a content creator. So all of this applies to all of you. Decentralization of content creation is definitely going to be a core theme of innovation over the next 2 decades, just like how centralization of content creation was a core theme over the last 2. We've seen this begin already over the past several years, like with the, huge wave of people getting into the Fediverse in response to our favorite space idiot pushing the limits of Twitter's awful and what that can mean. We're already seeing multiple protocols being created, like the App Protocol, Blue Sky, ActivityPub, which has been around. And I think it's good that we have multiple protocols. Like, I don't think that there should be one winner. And the last 20 years have kind of brainwashed us into there has to be a one winner mindset. Like, you will see me on Blue Sky, you will see me on my Mastodon instance. We can create solutions to connect those multiple protocols. And we can call it Yahoo Pipes because that name is available. So while the 5 previous years gave us the power to post, it also innovated systems of locking us, the posters, into centralized platforms. Boo. These platforms paved the way to like exploitative creator and gig economies becoming the norm. Instead of like kind of starting with hope, this block of time started with the Great Recession, which is the perfect time for me to graduate from college. I had such a hard time finding a job in the tech industry that I just went back to grad school to continue my comp sci studies. And then I became a department administrator and an adjunct because let's just say, I think a lot of people in this room know that like grad school is not really the most lucrative career. And during that time, I learned JavaScript and even brought it into our curriculum. So it was a big thing for me. Despite like the recession and also the New Jersey Nets moving to Brooklyn, which I only call out because it's really unfair that y'all have an NBA team and New Jersey doesn't. There were exciting things happening in tech. Apple launched the App Store, which is like hands down like one of the most important launches for all of us in this room, whether we like it or not. And with that came the innovation in developer experience that exploded too. We saw the creation of Stack Overflow, GitHub, Node.js bringing JavaScript to the server, whether we liked it or not. The App Store also brought new economic opportunities to the streets with rideshare and hosting like Airbnb and Uber, more online paying options and point-of-sale tools like Square, Venmo, Stripe. There's a hair in my mouth. These things like enabled small businesses to get a piece of the online revenue action, which is very exciting at the time. Of course, in hindsight, as you can tell as I name these names, we were diving headfirst into the corporate innovation to exploitation funnel that we're kind of like spinning our heads around about today. And of course, so much innovation, sacrifices had to be made. So I want you to allow me a moment to be dramatic and say that the end of Google Wave was a huge gut punch to me. Google Wave is to thank for all in-browser collaborative experiences, not just with Google Docs, but any in-browser IDE you might be using today, especially Glitch, through the research on operational transforms. But also Google Wave, personally, its sundown that to me came out of nowhere was my wake-up call that I needed to be extremely careful about what platforms I became dependent on. It was like a foreshadowing, if you will. So decentralization of content is not going to be enough. I'm hoping that content creators, again, all of you in this room count towards that, will not only follow in the footsteps of gig workers today demanding rights and what they're owed, but join them and blue-collar unions and retail and food service workers who are already fighting for fair wages and benefits. Everyone may not be ready to run their own mesh network today, but in the meantime, there needs to be collective action to set the boundaries to prepare for that and new expectations that are in place so our content is protected while we work towards more community governance. I wish we could flip a switch and be like corporation to community, but that's not going to happen. So we have to kind of think about the process that gets us there. If we don't think about that and if we don't enable that to happen, we're just going to be harmfully fracturing the web in a way that to fix it, we'll just end up centralizing it all over again. This is kind of my worry about all the non-technical people from Twitter all going to just one other platform. I worry that it will fracture all of our conversations, all of our community, and then they'll end up in one place and be unsatisfied and not delighted, and then allow someone to come in and swoop in and centralize it all over again, which will unravel all of the amazing work that all of my colleagues that have spoken at this event are doing, and also the consequences will be more dire than we see today, because as we go through this timeline, it starts hopeful and then ends up in the bad times. It's hard to imagine what can be worse than Elon destroying years of work by killing access to the Twitter API for something that is a little bit more recent. I think it's situations like the Twitter API thing that make it, I don't know, it's so interesting to me that community is becoming a refrain for more and more companies. I'm speaking with both my director of community at a tech company hat, as well as my non-work community organizer pants on. Tech companies are investing in creating their own communities, and I think that anything that gives community a voice is great, especially since I think that these companies' APIs for community-generated content, including Twitter's and all the other social media platforms, I think that they should be owned by the community. For many reasons, including the fact that we can't expect companies like Twitter not to take access away to make more revenue. And what they're taking the access away of is the content that we've created, our conversations, our knowledge sharing. I want to call out lightly that Reddit and Stack Overflow right now are starting to charge large AI companies for API access. And I'm assuming it's to get ahead of all of their data being scraped, which it's done been scraped, with no benefit to their communities or their bottom line. And I hope that doesn't devolve into charging the creators of the content on their platforms, the members of their community. But that's probably where we're headed if we let them, by not protesting that path. I think it's great for the tech industry to really invest in community. And not just because community is in my title and has been for 6 years. I chose to pivot into that space from consulting and web development because I experienced the importance of it firsthand growing up on the internet, and I've also seen companies fuck it up. And I'm like, well, if I kind of go into it and can kind of vocalize that you can make good change and not lock people into your systems, then that's the job I want to do. That's like the legacy I want to leave. Also with the pandemic and like the looming recession and massive layoffs at the hands of content platforms, we need community more than ever. But also, again, I've been working in the community minds for quite a while, and I know that when something becomes table stakes, as community is, this is when the snake oil salesmen come out of the woodwork about it. So I want everyone, content creators and community people alike, to keep an eye out for growth hacks acting like community. I kind of think of how like flash mobs, remember flash mobs were a thing? Like flash mobs are often not just like goofy fun parties, but they're marketing stunts. So I just want people to be cautious of thought leaders who try to make community out like it's some kind of rocket science. Not because I think they're particularly dangerous, I just think they're annoying and I don't want to be associated with them. But like I want us to, when we think about like community owning, community governance, community sharing, these are not new novel things. We're relearning what the past has done. I think of how like people used to share recipes with each other before there were computers. People told stories. We hear stories from before times we can even think of that have existed because there's stars in the sky that make cool shapes and they explain them. Like community generated content and sharing and hosting has existed. What we're doing is we're, again, like going back to that thinking after these decades of brainwashing and fighting against that. So I just want us to make sure that we don't try to over-engineer human relationships like we did single-page apps, for example. And if there are any community engineers in the room here or watching that work at tech companies like myself, I just want you to know that your most important job, no matter what your boss might tell you, is not locking your community members into your community infrastructure. It's helping them succeed with it because they consent to use it, because it's a delightful experience for them. And your job is also advocating for their ownership and governance of the content they're creating or hosting with it. And it's possible. We have a lot more work to do like at Glitch, but we actively decided not to create a new language or to lock you into our platform. We just let you build the web with open standards. You can export it, you can download it, you can take it wherever you want. We just hope that you hang around and share your knowledge and creativity with the rest of the community if you want to. And we're there to create the delightful experience to, hope that you do that. And again, we have a lot more work, but that work is what I'm actually surprisingly excited about for the future. Okay, where was I? So Google Wave died, causing the world to take a turn for the worse, especially politically in the United States. I was having a horrible time working at the university, so I quit academia to work at the NBA, which I couldn't convince them to keep the Brooklyn Nets in New Jersey. I ended up then leaving the NBA to work at a consulting company, which was probably my second biggest career regret next to the year in grad school where I was like, yeah, I'll teach Excel courses at 7 a.m. That's a vibe. It was also during this time that I not only entered the industry, but I also started to become visible in it. I gave my first conference talk ever at jQuery Portland about art and code. I will be talking a little bit about that at the social later tonight, so I hope to see you there. Around that time, my pal Nick that I worked with at the MBA and we started a satirical online magazine called CSS Perverts, powered by the then new and invite-only medium.com. Again, the exclusivity of the Blue Sky invites is giving me extreme medium.com vibes, in not a bad way, but it's always just kind of funny how exclusivity really does bring the hype. We humans have evolved, but not in that sense. So yeah, we were writing web development satire, which it seems pretty niche, but there is a whole lot of things to write about satire. Satirically, in the tech industry at that time, we had the JavaScript framework wars. Who else here was a veteran of the JavaScript framework wars? Yeah. The JavaScript community, company included, was so annoying that developer experience was evolving to make it possible to avoid it entirely. And we had the Equifax breach. So cybersecurity was finally becoming mainstream in a way that it probably should have decades ago. This is also when companies truly started to fuck with us in ways that like no person, like not even myself, can even like imagine or come up with. I think that like forcing U2's album on every iPod and like a year later also deciding we just really don't need headphone jacks was maniacal of Apple. The shutdown of Yahoo Pipes, feral. And Amazon tried to insert its eyes and ears, disguised as the Internet of Things, into all of our private spaces, and you motherfuckers let them do it. But I'm hopeful that's going to change. I think in response to the convenience of smart devices and affordable hardware like the Raspberry Pi that had come several years before that, we're already seeing people create their own IoT options without giving Amazon and the cops that work with them free surveillance. And I love what like Mav had said during the Q&A yesterday in her talk of like how if it's expensive, it's not worth it. Like, of course, that applies to hardware and software and everything. If you were in that talk and you heard someone annoyingly snapping, that was like me the entire time. So, yes. So like democratization of hardware is like really important good. I also want us to make sure that we are aware that privacy is something that everybody deserves, not just people who know how to build a camera or connect it to some network. We have to be aware of also who we're all pointing our cameras at. So be careful what we're actually contributing to. Is it the democratization of hardware, or is it the democratization of surveillance? I also want to give a shout out to the right of repair movement that's slowly making strides, which is really great. We just have to make sure that we not let the companies that provide that hardware and have to kind of like allow us into it use subscription software as a way to lock us into their hardware if they can't physically lock us out of repairing it ourselves. That's something we have to keep an eye on because legislation is being made, so we're getting closer to being able to have more access to repairing our devices, but corporations are always going to fight us on that. Also, I wasn't sure how I was going to fit this in here, but I think it's really important. We need to figure out the lithium-ion battery problem. Last year in New York City, there were 200 fires associated with lithium-ion batteries exploding, mostly due to the lack of access and affordability of legit batteries and the kind of gray and black market. 6 people had died, 150 were injured. That was last year. This is increasing this year at an exponential rate, as does the demand for food delivery, and it's often delivery bikes that run these. The scooters that we see, like the hotel I'm staying in, I saw 2 scooters inside. It got me a little nervous because I'm thinking a lot about that. I think that increasing access to anything, whether it's software or hardware, always increases abuse vectors and bugs, and hardware has that added problem of counterfeit batteries and parts that put all of us in danger. So I just felt like it would be irresponsible to talk about hardware and not call that out. They are trying to think of ways in New York City to alleviate that problem due to the large volume of that happening. It's important that we blame the providers of the hardware and the batteries, not the people who are consuming it, because again, we have to think about the rights of gig workers that have no other option. So yeah, I think just like overall, just paying attention to the hardware aspect of computing will lead to all of us, not just those who understand computing, to have options, choice, and autonomy when it comes to pairing convenience with privacy. And if we focus about the potential disasters like battery fires, it can also save lives. On the topics of option choice and autonomy, actually, In 2015, I wrote a satirical chapter about JavaScript and how it should and could be the only language, and for some reason, O'Reilly published it. At that time, I was becoming incredibly fatigued with the community, and not so much the speed I wish developer experience was evolving, but like the weird directions I thought it was taking. And satire has always been my tool for communicating what I want to see in the world, and I think we're starting to see it. And again, I love JavaScript. And being humbled doesn't have to be a bad thing. I just think there should be no one programming language of the web, and I think we are getting there thanks to the much needed innovation of WebAssembly and edge computing. I mean, we can keep making JavaScript frameworks and make JavaScript less like JavaScript, but it's still JavaScript, but harder to do. But I also think that instead, like the ability to run dynamic content on the edge sounds infinitely better from a developer experience, as well as an end user perspective. And I think that if the cloud couldn't kill relational databases and DBA jobs, I don't think WebAssembly and edge computing will kill JavaScript. So for all the JS folks out there, again, I'm in company with you. Humbling is not all that bad. Everyone hydrate for this one. Okay, so here we are at hell. Political hell, tech hell. It wasn't all bad. I started working at Fog Creek to launch a thing called Glitch. I got an IUD, which made me like a bionicle, technically, maybe. I gave my last conference talk before today at JSConf EU 2019, which I think marked the end of the new wave JavaScript era. I became a remote worker, like many of you probably because of COVID. Glitch became a startup, Glitch went through layoffs, Glitch got acquired by Fastly. And people have been asking me this, and so I just felt like this is a good opportunity to say it. That acquisition was a good thing. I know we carry a lot of valid trauma from seeing the tools that we like and the companies of the people that we like being acquired. I think that our acquisition enabled us to continue our mission and also work amongst really incredible smart people working on forward-thinking technology, like everyone's talking about at this event. All the things that like I'm hoping for, like the Fediverse, edge computing for the developer community, WebAssembly, and a community of creative people using code to express themselves. We're working on all of these things, which is really great. But it was a real slog to get to that point, and not just because all the bad things happening in our world creating such uncertainty. Like there were lots of doubts, lots of uncertainty. I became really sick and was in the throes of thyroid disease, and like all the stability that I felt like I had built from the bottom up was hanging in the balance. And that's like, again, I'm not trying to be dramatic. Like I just want to call it like those last 5 years fucking sucked, and I think a lot of you would agree with me. So I wanted to just acknowledge that, like this is hell. It's very hard to pull out any highlights from the last 5 years. And not just because it's not been enough time for me to process. This all feels like this has happened in the past couple of weeks. But like there's just been so much absurdity, like violence, loss, Mark Zuckerberg trying to claim thought leadership over network connected virtual experiences and like literally not having 2 legs virtually to stand on as he did it. And then here's the part of like my talk that I've had the hardest time with. It's time to talk about artificial intelligence. So I was thinking a lot about the deletion of Yahoo Answers last week when I heard about BuzzFeed News shutting down, especially about how crowdsourced information and digital journalism fed a lot of the language models that are now being used to ultimately destroy them. And like I know like that's capitalism, baby, or babby. But without community crowdsourced content and digital journalism, like what's going to further educate those models? Like would it just start teaching itself and getting dumber? Like that's like kind of something that I worry about. I think just like the cycles of innovation and hype that we see with virtual reality, the same will be true for AI. Like it got hot I think we're getting into a plateau right now, I think, a much needed one. And then it will get hot again. Hopefully not in worse ways, but probably. I think that also like VR, the community will make it better and fun, not Microsoft. And I'm hoping that creation and usage will get cheaper. Like the waves of innovation in VR, like the way that it brought us cool hardware, like portable headsets and motion detection, I'm hoping that AI innovation will like bring us closer to quantum computing. And like I know that like a lot of people say that it's impractical, but we made crypto mining and Gary Vaynerchuk's NFT restaurant happen, so anything is possible. Also, like VR, I think, and this is like not like a good hopeful note, militarization will be what fuels innovation and corporate gains. I think this is where Elon got things wrong with Twitter Blue subscriptions. Like military is where the money is at, not check marks or clout. I think a lot of people hopefully will realize that like clout is a fake currency created to distract us from our own exploitation. I think that's why it's so obvious that Elon is like, how do I put this in like he's just like out of his own league. And that's like why he acts so irrationally. Like he has no idea what he doesn't know, but he thinks he knows everything. Anyway, I just like, I worry about the militarization be driven by what the community is creating, which goes back to what I was saying about the boundaries that we have to set and the resistance that we have to have, not just to corporations, but to the military, because the corporations are working with the military already, if you didn't know that already. This is a snippet from an open letter that Elon Musk signed calling for the pause of AI systems, which I think is just as irrational as the whole Twitter checkmark fiasco. It's very obvious that Elon's fear, and the fear of other people that signed this, like Andrew Yang and Steve Wozniak, their fear is not the riskiness of AI, it's their fear of missing out on money. There's a lot to catch up on. Really smart people have been studying and publishing and calling for action on the potential and current effects of AI usage for a very long time. And they're all being fired from the corporations that are rushing AI launches, like as we sit here. I think that if it were possible to pause an entire field of computing that has the momentum it has right now, we should use that energy instead to pause the actual biggest problem with AI, which is the people who hold power over it and ultimately benefit from it. I think that people like Elon want to pause AI because they didn't anticipate us calling out the risks and fear we have. And by us, I mean I'm a technical person, but I think even normal people are like kind of afraid and scary at like how good this stuff works. I think people like Elon thought that we'd think that they were gods, and some do, some people do. I think that he's starting to feel a discomfort from logging on only to see us making fun of him and resisting like hyper-capitalism. Like people are booing him in public spaces, maybe making him feel a bit self-conscious with all the guillotine memes. Like, I might be naive, but I think I'm also manifesting a good thing. And I struggled with like the entire process of this talk, trying to find the balance of like warning with hope. I don't often like to end my lectures making everyone feel bad. But it's really hard to see hope in the future of computing when it's been a weapon used to cause so much harm. And honestly, I'm like exhausted from witnessing like all the bad stuff at such close proximity, like working in this industry and using these platforms. It's a big part of why I left Twitter. It's also kind of like close to why I've spent the last 4 years thinking like, well, I pivoted from academia into the industry. Maybe I should like do something else. Because like all I really want to use computers for is to like hang out with my friends, with my community, express myself with art and humor. Like, it's just like not fair that only 20 years ago, I was hopeful about all the concepts in my textbooks. And artificial intelligence was one of those textbooks. What we get is like rushed corporate poison-fed white supremacist models. And those white supremacist models are being used to determine if someone incarcerated should get parole or not. I'm a student of prison abolition. I'm on the junior board of the Women's Prison Association, so I pay a lot of attention to how computers are being used to oppress those who are touched by incarceration. The prison industrial complex, especially in the United States, is incredibly unfair, and computers are facilitating that. The same white supremacist models are being used to auto-reject job candidates, which could be you in the future if you don't look the same way or have a name that looks the right way or you don't use the correct number of keywords in your cover letter. The same models are being used to determine if you can get a loan for your home. So basically deciding if you deserve a roof over your head. Like, where does it stop? Like, does it stop when it comes time to tell whether a family gets food assistance or access to clean water as that becomes more scarce? Like, AI, though, is not inherently the problem. It's how we decide to use it. It's supposed to optimize our workflows, not replace humanity and thoughtfulness and tenderness, which is, again, why we need community. It should be for enabling research, bringing creativity to life, maybe whatever the hell this is. I really like how Jeffrey, in his talk yesterday, approached the use of AI in the Potluck project. We just can't allow anyone to use Potluck to organize parole sentencing, please. And I probably could have saved a month of work and used AI to generate all those tables of the last 20 years of history. And I didn't use it because it just didn't occur to me to do so. Like, it's not something I grew up with, like I did spreadsheets. I'm also just not very moved to have my computer do everything for me, which is why I really appreciated kind of in David's Q&A, kind of talking about like not having to, have the computer do everything for you. Like, it's just not something I'm compelled to do. I consider myself an artist and a storyteller first, and maybe like a computer user fourth or fifth. I turned to spreadsheets because spreadsheets were my like earliest aha moment for optimization. And I don't know, when I was kind of coming to that while writing this, I thought that was like really like super interesting. Like, it made me think like there were previous cycles of technology where people felt the same way. There was like the people who are like, I didn't know because I just didn't know it was available, or like I'm just not used to it, or people who are vehemently against it. I remember when Wikipedia had come out, which I believe was 2001, teachers, like Wikipedia scared the shit out of educators, much like it's scaring the shit out of them with all the AI stuff coming out. The idea of a community maintained encyclopedia as a valid source was like, what are you talking about? That's insane. But like when you think about it now, Wikipedia is so necessary, and not because of corporate stewardship or rule. It's because it's mostly like the community creating it, and that's what I think we need to tap back into if we really want to make a good future for society. I think we need to go back to the basics, like the beginning, where the web was created to share information, not let a select few turn it into a predatory data bank. I think that like with the lessons we've learned from the last 2 decades, hopefully, we are equipped to give people the tools to not only learn to correctly consume the web, but to be able to build it, host it, moderate it, and also make it faster, secure, and I think most importantly, fun. And the primary tool that we can do that with already exists. That's right. I'm not the only one in my 30s that's getting hotter and smarter. We've got HTML. HTML is portable, it's free, it makes the web archivable. No one can acquire it and shut it down. It's fast, it's fun, it's here. I want to give a shout out to platforms like NeoCities, communities like html.energy. I can't not mention all of the incredible creators on Glitch that are expressing themselves and sharing information in less complex ways using HTML as like their main tool. I think that's really exciting. And I know that this is something that a lot of you are longing for, like kind of this return to what brought us onto the web so long ago. I had asked the Fediverse what tech trends they'd like to see come back, And while it all feels nostalgic, it like feels possible. Like 20 years when you think about it is not all that long of a time ago. And I'm not just saying that because my 20-year college anniversary is coming up. I think like the recession that we're heading into now doesn't feel so far from the one in 2008 when I was in grad school. And, you know, I don't have an incredible memory, but I remember hearing the phrase the cloud for the first time. And I'm a visual person. I like looked up to the sky and I pictured like racks of servers and hot air balloons and HP Pavilion entertainment notebooks being carried by storks because that was like the laptop I was using. Like I just vividly remember like just the movement of my head looking up and thinking of that and not really understanding quite what the cloud meant or if that was something that was meant for me. And I think about it today and I'm like, wow, that was only 20 years ago. I like learned so much and I've done so much since then. So while I'm like cautiously hesitant to be excited about the future, like what's the other option? Like pause AI so Elon's army of laborers can catch up? Like hard pass. I don't think we can undo what the last 20 years have done, but we can course correct through all the topics that we've been discussing here at this event, and that's the decentralization of content creation, democratization of hardware, and community and collective action. And the vehicle through which we do that has to be the web. And I know that like some folks might say, just like they did when we kind of went through the like web apps or native apps deal was, well, web-based software can't do everything we need. And that might be true today, but I think that sentiment is a huge part of how we got here. Like, look at how much you can do with the web today that we couldn't do 20 years ago. And that's despite corporations cosplaying as community. Now imagine we put the future of it in control of the community and not corporations. And I'm talking to those of y'all building browsers. I think that's the future of computing. And I think that that is fucking exciting. So I would love for anyone who wants to talk more about like the Fediverse, WebAssembly, edge computing, even Yahoo Pipes, I'd love for you to join the conversation on the Fastly community forum. You don't have to be a Fastly customer to use it. This is a place to chat and knowledge share. And if you have any questions, like please, like, or if you want to have conversation about this tonight, I'll be at the social. I'm going to be doing a speed run of some fun art, code, and comedy stuff that I made in order to help me survive the last 20 years of being in this industry. And I'm not on Twitter, but pixel.kitchen is my single person instance. And I will see you all on jenschiffer.com.
Hello. So to your earlier point, I actually just saw somebody announcing a project to recreate MySpace on Blue Sky Tech. So it's happening. But for my actual question, I'm curious if I could consult the Gen Oracle and hear your perspectives on what conflict looks like in the near future. And when I say that, I mean anything from, Ukrainians hacking drones to drop grenades on Russians, to Twitter powering protests from Arab Spring to 2020, to stuff like Twitter kicking off Elon Musk or Blue Sky trying to have community moderation. Like, all of these can be conflict, and just, what's the vibe? What are you looking at?
First of all, thank you for your question. This whole corner has been asking such great questions. I was like, I hope they ask me something, so thank you. Something I've been really frustrated about as someone who does content moderation on like Glitch is this hope, this kind of blind hope that you could get rid of every bad person on the planet. You can't. First of all, someone probably would have done that already, because what's a bad person is in the eye of the beholder, just like Republicans in the US see trans people as bad. And if we have anything to do with it, we're hoping you're not going anywhere. Like, there's always going to be resistance to that. People worry when they join a new platform. It used to not be, how do I find the people? It's like, how are you going to get rid of the Nazis? And the platforms that get started, they're never quite prepared for that. And not even not prepared for that, but not prepared to answer the question. And the answer can no longer be, it's on the roadmap. Just like when you launch something, Blue Sky, you can't not have alt text enabled. And just like with a lot of these AI models and usage of it, I want to give a shout out to Ramsey, who's always pushing for advocacy of allowing people that speak other languages to use software. We have a very English xenophobic centric idea of what it means to build for the web. And I just want people to remember www, World Wide Web. So I think that we need to understand that it's impossible to get rid of everyone bad of the world, but what you can do is make your spaces smaller and more manageable. The problem with Facebook and Twitter, amongst many other problems, was that they were trying to become a huge macrocosm of society. And our society is white supremacist, it's misogynist, it's violent, it's stupid, broadly. So if you're trying to grow at all costs and get them all in there, you're going to have a white supremacist, misogynist, violent, shitty community. And so the question should not be how are you going to get rid of the Nazis? Or why aren't you doing more than banning them? It should be how are you going to give us, the new community, time to create the norms so that we collectively can get rid of these people? Because it's not just about getting rid of them, it's just not making a place that's attractive for them to be. So I think people who are creating communities also have to study how communities work, the bad people and the good people, and not just assume oh, well, we started and it's all good and isn't this great? Because it just takes one person to ruin the entire experience. And we're at the point now that we quite weren't at 20 years ago, where actual lives are at stake and words are very violent. And as far as protesting, I, follow what the people who are starting protests are doing and applying that to your digital spaces and creating digital spaces that enable them and also educate them on avoiding surveillance and all that stuff. When you're protesting for your life, it's hard for you to think about all the other abuse vectors that are happening, data collection. I'm thinking about I'm very openly I have an IUD, and in 10 years, IUDs might be outlawed, so there's always thinking about where you're contributing information about you. It's very overwhelming to have to think about all of that while you're also struggling for your life in the moment. So I ask for people who are, not marginalized in a situation to be those ears and eyes and knowledge sharers to help protect and be allies for people, again, virtually and in person. It's all going to feel like one place at some point. That was a lot. I hope that was coherent in some kind of way.
It was a big question. Hi, Jen. Thanks so much for your talk. One of the questions I have is the interventions needed to prevent the same types of white supremacist structures happening in community, right? You have a lot of people, they all want to be heard, and then we do see centralization of power and governance in the loudest voices, usually the whitest voices. So what have you seen or experienced that could help kind of community builders in the digital space, safeguard that from really rolling over where we won't be able to stop it with the momentum it has currently?
Thank you. That's a great question. I'm in a very privileged position where I work with a team that trusts me and I trust them, and we can say what is sadly a radical phrase, which is we don't allow Nazis on our platform. That has to be normalized. I think it's hard, with public companies and how I've only just started working at a public company, and I'm learning about the market and stocks and how you just like have no control over what the public thinks, especially again with the society that we live in. You always have to like, if you're a community leader, part of your responsibility is like pushing the envelope and trying to see how far you can go and taking risks in what your beliefs are. That's your responsibility, not only because it's good for business, but for the people that you want to have in your community. And if you're not taking those risks, then you're leaving kind of those holes open for the behaviors that you don't want in your platform. So it takes an incredible amount of privilege to be in that position to do it, which I'm happy to be in. It's kind of why I have stayed around. I still get invited to events, and so I'm like, well, it's my responsibility to talk about this stuff, and keep talking about this stuff, to the point where phrases like "we don't allow Nazis on our platform" doesn't seem quite as radical. Also, when you create a community and you're a community leader, like, don't be afraid to model what you want to see, and think about that versus growth. If you have a community of 4 people, that's great. You don't have to have so many people as like Facebook does. And I'm hoping that, I think like, for better or worse, governments are passing legislation that's like kind of performatively in response to lack of moderation, but really it's like, you're silencing my political beliefs and whatever. There's going to be, I think, in the next several years, a reckoning around how corporations build communities and grow them, and what they try to do instead, which is like not creating spaces for their users to talk amongst each other, but I think, having subscription-based models on APIs and all that kind of stuff. Basically creating a web for people who have money, which is a huge problem. Again, if it's expensive, it's not worth it. I don't have the answers to anything. I'm kind of just like going through the motions and taking risks where I feel like I can. I am in a state of like constant frustration and sadness about the way things are going, because it's not even like my peers that are making the wrong decisions. We're just like under the weight of corporations and capitalism and all of that. But I don't think I would be able to talk about that stuff on stage like I am right now 10 years ago. So I kind of see with these movements happening, there's more room to have these discussions in this is kind of a non-academic setting. This isn't like, I'm not in the quad of a university, but in a more like at a tech company's event with people that work in these corporations. And my coworkers are probably watching, and I'm hoping I'm doing them a good service. But they're not like afraid that I'm gonna, I don't know, like say something too scary that leads to, I don't know, a news segment about somebody saying that free speech is bad or something like that, I'm not really afraid of saying the wrong thing, because I'm saying just like what my beliefs are. And that's also something community leaders need to do. They need to say like what they believe in and really advocate for it, versus just following what the business plan is. Because if you do it the right way, what you say is going to be good for business. And we can talk about some other time other internet infrastructure companies and how they handle content moderation and who they allow and how to be good neighbors. That's for the social tonight, though.
Hey, you talked about, people with technical skills.
So is mic closer to your mouth?
Oh, sorry. You talked about people with technical skills helping, like, activists and people who are putting their lives on the line. But what do you think people with technical skills can learn from the people on the streets?
Everything. I think of when Trump became president and he started banning certain countries from coming into the States, and there were people who were trying to connect with their families or who were stuck here. There was these calls where we need developers to make software for them, and all these developers made these CRUD apps, like CRUD, not like actual CRUD apps, but they kind of were cruddy because it wasn't exactly what was needed by the people that had that problem. So as developers, software creators, and designers, we really do have to listen to the people that we're creating solutions for and not be prescriptive of what we think those solutions are. This has kind of always been a friction I've seen with civic tech spaces have been in. It was something because we had a chapter of Code for America in Jersey City, and that was something historically they had a problem with, of creating software for the sake of software, bringing to the people that like need help. And like that case, it was people who were having trouble with gaining rights as renters and like not having rent stabilization actually be in effect. And any of the software that was being built didn't exactly help them, and it left the developers frustrated that they weren't seen as gods, and therefore took their skills to other stuff, probably cryptocurrency, and left the people who actually really like needed help without that help, and even worse, because they had spent time working with these people and expecting to have a solution. And then they were afraid of working with future civic tech people. And then they turned to centralized platforms because the companies are like, well, I can solve this problem. Like, I'm Zillow and I bought like all of this housing. So like, come to us if you want to talk about housing, stuff like that. So absolutely, we can learn everything from them, but it's not like super complex. We just say, what is the problem that you're trying to solve? What do you need? When it comes to prison abolition, you know, as a lot of states in the US are legalizing marijuana at the state level, a huge part of that is going back to all the people who have been arrested for marijuana, mostly black and brown people, and expunging their records, which is unsurprisingly an incredibly complex problem. It's a complex problem getting people who are incarcerated even to have access to the paperwork they need to fill out in order to get out of prison, as is their right to do at some certain point. And so we're starting to see organizations trying to galvanize the developer community to help them out. And I've been telling them, you need to like really write out and document like what the problem is and how you think it could be solved, and do not let the developers speak over you. And you know, if they're saying we'll use React for this, the point is moot. We've lost the battle. Move on to something else. So really kind of like thinking of it from a community human level and not a technical level. And also, you know, be effective communicators. As Mike was saying in his talk, like marketing is just being able to communicate what you're creating, what problem you're solving. So if you're a developer and you want to make something and you feel like you can't do that, collaborate with other people in the community that are good at that. Look outside of developer communities, look to designers. There's a whole really awesome open source designer community. There are marketers. There are people who are developers that pivoted to marketing, like Michael. There are people like me who pivoted from development into community. Keep talking to those people, even though they might not know exactly technically what you're into. We all want to know. We all want to collaborate together to build software that helps enable society.
Over here.
Hi, Jen. Thanks for the talk. I'd kind of forgotten about the naive optimism of that sort of 2006 internet era about like, we're just going to sort of connect everyone on the internet and it's going to sort of solve all these social problems and information will travel freely and all this sort of stuff. And like, yeah, seeing this timeline made me remember that feeling, which is definitely not here now. I was talking to a friend of mine, non-technical friend, not that long ago, and talking sort of like happily about Mastodon and sort of smaller communities with their own rules and moderation getting together and like a lack of conflict in those communities. And he said to me like, isn't that sort of an admission that this like multicultural project of the internet has failed and actually people don't get along and we should all just be in our own little silos? And then, yeah, I just didn't really know whether to feel happy or sad about how that's progressed. How do you think about that? Like, what does that say about us as people? And is this a positive, negative, neutral? Like, how do we frame this?
That's a great. Y'all have such great big questions. So humans are incredibly complex. I would say we're more complex than computers by far. And as developers, we are intimidated by machines. We understand they're complex. We're trying to learn their complexities. But then when it comes to humans, we try to oversimplify it. It kind of goes back to, I had a quote from Dallin Knuth up here about like premature optimizations, the root of all evil. You can't optimize the understanding of human beings. You can't, they're not all a monolith. Even amongst races and religions and sexes and even just like people who think a certain way, they're not a monolith. It's a hard pill to swallow because it makes it a problem that we can't solve. We have to accept that there are problems that we as individuals can't solve. I can't solve the content moderation problem. I can't solve how to make the best online community where everyone is happy. That's my North Star. I'm working towards that. I go to events and talk to other people about that and make myself visible, which is a risk to myself as a woman. In order to work towards that, these are those risks. But at the very basic level, just accepting like humans are complex, you're not going to be able to crack that code, nor should you. If we weren't complex, how fucking boring would it be? We wouldn't have like David's like live coding art talk. I've been to an algo rave and I've seen live coding at events, and like my mind was blown at that demo earlier today. And like even like what some may seem as like the niche space of live coding, music and visuals, still there's so much variety and like beauty and just like diversity there, because he has a vision and someone in the space probably has a different vision. And I don't know, that's like really fucking cool. So if we embrace that versus trying to solve how to make humans do the things I want to do, we'll all be better for it. Even Elon Musk. He'll get better memes.
Thank you, Jen. That was awesome. Thank you.
Thank you.
All right, so that is a wrap for today. Was it awesome? Lula Lounge tonight, 6:30. We have to be out of here by 6. There's posters, but you can also pick them up tomorrow. What else, Boris? We're good. See you at the Lula Lounge. We have more cool demonstrations, live coding. You can pick up Halo, specialized beer, sparkling water. We're at the lounge. Cool. See you all there. More conversations, more things. Thank you so much. Thank you to the speakers today, AV, registration, everybody who's been here. Thank you.